Hello, I'm excited to welcome you back to day 2 of Google Launchpad for Women in the Americas International Women's Day edition. I could not be more truly thrilled to be here with you all today, upskilling you on day 2 of your cloud digital leader journey. We've confirmed that there are over 2,500 of you attending this America's event. Just incredible. As you heard yesterday, I'm Kate Rivera, Global Head of Cloud Learning Offers at Google Cloud based in Chicago. One of the reasons I love my job is that I literally get to lift people up all over the world every day by upskilling them in Google Cloud. It truly aligns with my personal mission statement of doing work that matters and makes a meaningful difference in the world. And one of my favorite mantras, which is up on my home office whiteboard and I look at every day, is we rise by lifting others. We rise by lifting others. And I remind you that that is what we are here doing together on this Launchpad for Women journey. So today, I'm going to ask you to persevere and get this training done, and then return for one or both of the exam prep office hours on March 14th and March 21st, and study. And finally, schedule and take and pass that certification exam. You can do it. And I've got 3 questions for you. First, did Marie Curie give up when she was prevented from attending any university in her home country because of government restrictions where she lived because she was a woman? No. Thankfully, she picked herself up, moved to Paris, enrolled at the Sorbonne, and ultimately discovered polonium and radium. And she was the first person to win 2 Nobel Prizes. Second question, did Ruth Bader Ginsburg give up when she graduated first in her class from Columbia Law School, but could not get hired as a lawyer because she was a woman? No. She took a clerkship for a judge, worked in research for a while, then years as a professor, and then finally as a judge herself, and ultimately got to the Supreme Court. Third and finally, did Caitlin Clark give up and stop playing basketball when her team lost in the women's NCAA final championship game in 2023 in the US? No. In fact, she came back better than ever in 2024 last year, and she broke the NCAA women's and men's all-time point scoring record in March of last year and became the #1 draft pick for the WNBA last spring. How cool. So use these stories as inspiration for yourself, as a catalyst to continue on the journey and complete it. Remember, there's an extra incentive for you, an extra bonus, if you take and pass your certification exam by Monday, March 31st. Write that on your calendar. By Monday, March 31st, you will not only earn your Google Cloud Digital Leader certification, which is the big prize, but the first 500 of you will also get a $50 swag voucher, so you can get yourself a cool hoodie or whatever you'd like at the Google store. And if you haven't done it yet, please make sure you sign in on the Google form to mark your attendance using your corporate email address, as that is how you will, #1, receive that free certification voucher, and #2, all the materials for the course. Only fill it out once, so if you did it yesterday, you're good, but we know there are some new folks joining us today. That will be sent out early next week, the follow-up with the certification voucher and all the materials for the course. And I strongly encourage you to come to those office hours I mentioned on Friday, March 14th and Friday, March 21st, where Charlene will show you exactly how to register for the exam. She'll also walk through sample problems from the exam, and you can sign up literally that day to take the exam. So you got this. Stay with it. Pay attention and keep taking your notes today. I promise it will pay off. Lastly, I recently heard Simone Biles speak, the most decorated American gymnast in history, and I loved what she said to her teammates. She said, "I can't wait to see what you're capable of." It is now my honor to introduce another one of our amazing executive sponsors, Megan Riley, COO for North America, Google Cloud. Megan, please take it away.
Thank you, Kate. And thank you all for taking the time to invest in your own personal growth and development. Let me ask you to imagine yourself 1 month from now. You've prepared a study plan. You've completed all the training. You've taken the practice tests. You've taken the exam. And you passed. What an amazing feeling. And what a great role model you're all going to be in your own organizations. I'm Megan Riley, and I'm the Chief Operating Officer for North America Google Cloud. I joined Google Cloud a year and a half ago after working at many companies, including SAP and Oracle. One of the reasons I came to Google Cloud was to be part of a company that is leading the largest technological transformation that will happen in my lifetime, working with the most incredible colleagues, customers, and partners on the planet. And the most rewarding thing about my role is having the privilege to be a sponsor for programs like Launchpad, where we are empowering thousands of attendees with the latest in cloud and generative AI, and empowering each of you to lead transformations that will improve the outcomes and experiences of your employees and customers. For me, life is about continuous learning. Benjamin Franklin said, "Tell me and I forget. Teach me and I will remember. Involve me and I will learn." So here are some suggestions for all of you. Involve yourself on this wonderful journey. Set a date. Put together a learning plan. Dedicate the time to study. The sample exam questions are really helpful. Go through each question a couple of times and give yourself this gift of learning. And as Kate mentioned, as an extra incentive for the first 500 of you that take and pass your exam by Monday, March 31st, you'll get an extra swag voucher to the Google Store. Thank you so much for going on this journey with us. You've got this. I'd now like to introduce our final executive sponsor of this fantastic program, Janet Hoffman. Janet is the Vice President for Google Cloud Consulting North America Strategic Industries. Janet, please take it away.
Thank you so much, Megan. It is a delight to follow such an accomplished female executive in the tech world, and we're delighted to have you here. I have been at Google Cloud for about 3.5 years. I live in Santa Monica, California. I'm out of our Playa Vista office, and I do run strategic industries for Google Cloud. Really exciting job. So you might ask why I've been at Google Cloud for 3.5 years, and I left a long and a very progressive career at Accenture. And I will tell you, when Google Cloud called, I thought there is no more ambitious technology organization that has incredible integrity in the world than Google. My personal passion is to enable organizations to transform, to be the best for their employees, the best for their shareholders, and most importantly, the best for their customers. And I knew that at Google Cloud, that could be a vision that came true. And we are well on the journey to making it work here at Google Cloud for all of our customers. How did I get to the cloud? Interesting, but I'll keep it quick story. I was in the cloud before my time. I was running retail at North America and globally on behalf of Accenture. And I was looking for ways to catapult us into the future. And I said, we need to have a cloud experienced executive on my team. I will say this was about 12 years ago. And I will also say that everybody thought, what are you talking about? What is the cloud? And why should retail lead from the front? I'm happy to say I proved them all wrong. Some of our biggest and best customers in utilizing some of today's technologies, the AI technologies, are in fact from the retail industry. Now, that's one of my 12 industries that report up to me. But I still have sort of a chuckle behind the scenes that I really was before my time. Now, why didn't I be more successful in making that happen? I'll tell you candidly. It's because I did not have the skills training that you're going to get today. I did not know as much about the cloud 12 years ago as I needed to create a compelling position. You have the opportunity today to wrap up your 2-day session and be extremely knowledgeable, to be able to sit at the table, whether you're from TCS or Ford, Schwab, DaVita, Elevance Health, Tech Mahindra, Equifax, TELUS, Home Depot, Target, Northwell Health, Electronic Arts, Common Spirit Health, TIAA, Cardinal Health, SLB, Infosys, CNA, Deloitte, P&G, Jack Henry, and many, many, many other customers that we have. That's just a few. One of the reasons I believe this is so exciting, an opportunity for each and every one of you, is that it is your chance. It is your chance to level up your skills. And in the market, it's all about skills. Google Cloud skills are particularly in demand. They are particularly hot. Investing in yourself these 2 days and the get ready for your certification will enable you to be cloud savvy. You'll be able to be conversant in cloud. And that really means being able to talk about cloud as it relates to your organization and beyond. You can sit at the table, be in the critical business conversations, enabling your organization to outperform their competitors. And you'll also be able to take a future role leading Gen AI effectively at your company. We are the future of Gen AI. Words like microservices, Kubernetes, and CI/CD will be easily rolling off of your tongues, and you'll be able to describe the power of those technologies and how they can help your company. Delighted to have you on this journey with us. Dedicate yourself to finishing this training. Stay strong on day 2. If there's anybody that can keep you engaged, it's Charlene. And I think it's great that you have the ability to have you join her in this journey of learning. Love the Ben Franklin. Keep that in mind. Together, let's upskill ourselves to have a seat at the table and drive digital transformation to drive business transformation. There we go. Kate, back to you.
Oh, amazing. Thank you so much. Thank you so much, Megan and Janet. Really, truly, thank you. What a great intro on day 2. Let's do it. So without further ado, I will turn it over for day 2 of Cloud Digital Leader Training with the fabulous and energetic Charlene Banks. Please take it away, Charlene.
Hey, Kate, thank you so much for that. That was amazing. How exciting. Day 2, you guys. Woot! Let's go. Now, I cannot start without shout out to all of Kate's references to such impactful women. That's what we want. We want to make an impact, correct? This is what we want for ourselves. No one was able to stop those women. That was great. And then Megan, the COO of North America, dropped in to say, hey, you got this. And of course, Janet, the VP, hello. She's got 12 streams reporting to her. Oh my gosh, I'm so impressed that they all took the time to drop in to encourage you to keep going. So I have to do my part. I better bring it. Day 2, let's go. Now, quick warning. We're going to be doing several demos today. I'm going to be showing you some of the things that are being used right now in industry to make businesses awesome. You're going to see it live right here. Woot! All right, let's go. Day 2, Launchpad for Women. Now, I do want to show you my agenda for day 2. Starts out with modernizing infrastructure and applications. That's happening until 11-ish. Of course, there'll be some breaks in there. Don't worry, I'm not a monster. And then we're going to come back and talk about trust and security in Google Cloud. That conversation will not end because we have to take a break for lunch. Refer to the previous statement, not a monster. All right, but here's the deal. I'm going to need you to right now get onto your app. Okay, some of you actually cook for yourselves. How wonderfully healthy of you. You don't have to do what I'm about to say. But the rest of you, get on your app, order the DoorDash, Diner, what's it called? Yeah, you know, the people that bring you groceries and food, do it now. Get your grocery, get your food delivered. Get it between 12 and 12:10. Bring it back to your desk, plunk right down here, because we're all going to be watching the panel. There will be a lunch and learn session where we get to watch the Women in Cloud executive panel. They're going to discuss how being in the cloud, I imagine, I don't know what exactly they're going to discuss, but it's going to be based on their lived experience working in the cloud and how that has brought them where they are, I hope. I don't know. Let's hang out and do the lunch and learn, also known as munch and learn. All right, then we'll come back together at 1. And for the first part of the afternoon, I will finish the discussion that we had started before lunch, finishing up talking about how Google Cloud can be trusted because of its security posture and the kinds of things we're going to leverage as a company on these capabilities of security. And then the final section will be scaling with Google Cloud Operations. It's going to cover things like high availability and security in terms of having all your systems available all the time in a way that's reliable. So we'll do that as the last thing, and then we'll talk a little more as we wrap up the last half hour of the day. We'll discuss that. Wait, what did they say about swag? And when can we sign up? I'm wearing one of my swags that I got. It's little, you see it? See the little cute Google? It says Google all over it. I love my swag. We are all suckers for a good piece of clothing that says Google on it. So yeah, that's a good incentive, am I right? Okay, let's get into it. Module 4 to start the morning. Here we are. We need to talk. We need to talk about these migration terms that you're going to hear, where Janet was talking about, yes, I love that she said that she was in a company 12 years ago, and she's like, yeah, guys, I think we're going to go to the cloud. And they were like, aw, hush. You don't know. But what I'm going to show you are some terms, some concepts that are in place right now that are allowing companies to migrate to the cloud, modernize once they get there, and then, of course, we'll talk more deeply about applications, microservices, what's the difference between a monolith and a microservice. We're going to cover it all right now. So let's jump in and talk about cloud migration terms. And I will start at the very beginning. I'm going to show you this slide and then press the pause button. That's right, I'm going to do that because this slide assumes that you're already familiar with what is a workload. And when companies migrate to the cloud, they're migrating workloads to the cloud. That didn't explain it for you, did it? I know. Well, there I was wanting people to explain it to me. And like you know me by now. Like you already know, I teach what I would have wanted someone to have taught me. So if I were you, I would be like, so Shar, what does it mean a workload? Like, what are you talking about? Here is a quick little journey. I'm just going to see if I could get this to snap in the way I want it to. I'm going to take you on a short journey. This journey is called From Monolithic to Microservices. I want to write a book. From monolithic to microservices, ... A journey. Well, okay, so I mentioned yesterday morning that when I was working for a particular government agency and I built them an application, when I built them an application, I built it in such a way that was perfectly aligned with all the things I'm good at. Why? Because I'm not crazy. As my mother says, I didn't raise no fool. That's right, Mama, you didn't raise no fool. When that government agency came to our company and said, can you help us with these spreadsheets? You see, we're managing hundreds of millions of dollars in fines and stuff, and we're doing it on a spreadsheet. And I was like, oh my gosh, let me help you. So they said, you can build it any way you want. We just need it to work. I was like, anything? They said, anything that's reasonable. I said, okay, yeah, let's do it. So I built them a virtual machine. There's my virtual machine. And the operating system I chose was Windows. So every virtual machine has an operating system. For me, I put Windows on it because I'm not shy. I'm not ashamed to tell you. When it comes to the ecosystem of work, I usually choose the Windows platform. Fine. Some other people are like, no, Linux is better. You're probably right, but I happen to be good at this, so this is what I chose. Now for databases, I chose, every system needs a database behind it. For the database layer, I chose SQL Server because, refer to the previous comment about Microsoft Windows, SQL Server is a Microsoft-based database. So after that, I was like, developing. The best environment to develop in, because I'm good at it, is .NET. So for .NET, I used that for my APIs. Everybody needs an API because your API is the thing that's going to shuttle information between the front end and the back end. You go through APIs. You get the data, you put the data, you post the data, you delete the data. It all happens through that layer. Obviously, right? You might be thinking, sure. So I wrote that in C#.NET. You might have chosen something else, but this is my story and I'm sticking to it. Anyway, so now this is the back end. Some people might call it the middle tier and then the back end. But what's in front of the customer? Remember, they're using spreadsheets right now and they're going to get something nice to work with. We don't want to make them think too hard. So, as you probably already know, in the front, when you pull up a website, you're looking at HTML. And it's usually looking pretty because of some CSS. And for me, I chose Bootstrap for my CSS because it's pretty. Yeah, there are other choices. Again, refer to my previous comment. Bootstrap to make it look good. And then, cascading style sheets, Bootstrap. It's what makes a button blue. It's what makes it's what makes things look nice. HTML on its own is just text. You don't want it. Okay, now for the fun part. Many people are like, okay, you need something else, Shar. And I know. And so I had lunch with someone who told me about something called Angular. Google made it. It's a JavaScript, TypeScript thing. And its job is, it was Angular JS at the time. Its job is to bring things from the user pressing the button on the front end to the APIs on the back end, which then takes the ball, think of it like football, then it takes the ball and it runs it to the database, the API takes it to the back end, and this is how websites work. So, long story short, too late? Was it already too long? Long story short, this is a stack. This I call my software stack. Have you ever heard somebody say that they were a full stack developer? Full stack, this is the stack. And the full stack developer says, I can code on every layer of this stack of capability. So this is the workload, my friends. This is it. Once it was all built out, we tested it, deployed it, and the customer that we worked for, they got awards. The number of man hours saved. And I always joke that the man hours were longer than the woman hours. Ha! Maybe I shouldn't joke like that anymore. Things get serious if you start joking. All right, that's your full stack. That stack is the workload. And this is what happened. We lived like this for years. And then, and this is the part I'm not terribly proud of, but it's okay. It ends up fine. The journey has a happy ending. But there's a part of the hill on the journey where here come some people. They come to our organization and they're like, this government agency is moving to the cloud. We have taken a look at all your different applications, and we think this one that you wrote, Shar, that has been chosen to be one of the first ones that we moved to the cloud. And then they looked a little closer, and they said, oh, looks like you have a monolithic app. Now, imagine a record scratch. What? Did you just call me monolithic? I am not a monolith. And I start moving my neck and grabbing air. It got ugly. But they said, no, this is not personal. This is a monolithic application because of the very hard references on every layer of this little, okay, pretend that's a Jenga tower right there. Pretend that every single slice of it is so closely and tightly coupled that there is no looseness. You can't just pop out one of those blocks and no. Every one of these things have to live or die together, and it makes for a monolithic application, which they didn't say, and all apps like this are deemed monolithic, which is kind of why I took it personally. But they told me to let go of my tightly clutched pearls to crawl away from the edge of the building, and don't jump, Shar, this is not bad. I was like, oh, is it okay? It's okay. A lot of apps are monolithic because that was the way we coded back in the day. And then they explained microservices. They said, well, here's what is more modern. You take this monolithic app, and yes, it's true. Initially, we do think that we're going to use your app, but we're going to do a lift and shift first. I was like, a lift and what now? And they go, a lift and shift. We're going to take that whole monolithic app, and we're going to lift and shift. I talked about this yesterday, and we'll put it in the cloud. Now, what's going to be in the cloud at this point is an exact copy of each one of the different layers. And forgive me if I don't follow the exact color scheme of my previously drawn stack. But as you can imagine, there's my stack happening in the cloud. And this first step is a commonly deployed first step. It's what we're going to talk about in the next few slides. But just remember, the lift and shift step is part of the baby steps that you take when you're moving to the cloud. It is not the destination. It's just one step on the journey. We are still monolithic, but we're in the cloud. Now, how do we get to microservices, which is really, that's our stated destination. So as we slide this little drawing up, now we realize that, great, it's wonderful that we came over to cloud technology. We lifted and shifted our virtual machine, but it's not really gonna be, it's not really gonna be modernized. Let me turn up my volume. Hold on, I'm being told I'm too quiet. 1 second. Up with the volume. Up with the volume. There we go. All right, it's louder. I don't know. No one ever told me that I wasn't loud enough. But first time for everything. Okay. Hopefully that's better. All right. So listen, that is the first step. You've got a monolithic stack running on a virtual machine. It's running in the cloud. But if you think about this app, think about this application. What if once we put it in the cloud, it gets super popular and we need more capability? Right now, because it's monolithic, I cannot scale pieces of it. I need to break up this app into pieces. So let me show you how that might look, breaking it up into pieces. What I want to go for is, I'm going to need a little more room. I want to break this up into pieces so that in this cloud environment, I now have a piece of the app that is just doing HTML and the CSS, the part that makes it pretty. This is the website, you guys, the web front end. And separately, I'm going to add another piece. I'm going to separate. Think about that Jenga game where you separate piece by piece in a way that doesn't break the whole tower. You really are going to re-architect this. And then you're going to create another piece that does the angular part. And then you're going to create another piece that does the API, Application Programming Interface. And I'm going to pause here because technically, if I take my application and break up the code base so that it's 3 different applications that are each microservices, they can still refer to each other loosely. not tightly. So now I've got microservices, and if everybody's excited about this thing and they're all coming to our website, we can scale that piece up. Couldn't I scale up? Remember yesterday I said if things get busy, just throw another one on there, and now we have more capability. This is what I can do. I can scale up that website portion without having to scale up everything else. I've made independent, not so brittle connections. They're flexible connections, and it's very nice. Now notice what I did not draw in a box. I did not draw the database in a box. You know why? Microsoft has Cloud SQL. Couldn't I have the API refer to the Cloud SQL instance that could be supporting my app so that it's not inside this section here? It's not microservices that support my database. No, databases are databases. They're not microservices, although they can respond to microservice requests. They're data stores. And that part of it definitely can scale a little slower than the web front end. This is brilliant. And there's something else I did not draw here. The operating system. Not necessary because we're using microservices to support this. So that was from monolithic to microservices, a journey. Now, how long does that journey take? All right, it could take a minute because it all depends on how you're going to architect this. But in a nutshell, you're taking an application that had one huge code base for all of the layers. You're breaking them up and you're going to store each one of these microservices in containers. So you're going to have containerized app here, here, and here. And it's going to run in a serverless, don't need a VM environment. So that's where we're going. And now we will return back to our regularly scheduled slideshow. How does that fit in with this slide? Well, now you know what a workload is. That right here, this little picture is Google's little icon for a virtual machine, otherwise known as a compute engine instance. And this is what we have running. It's a specific application, possibly running on that VM stack, or it could be a service, or it could be some capability, something that it knows how to do. And now, what does it have in it? Well, like I mentioned earlier, it could already have containers in it, or it could be just the database, or it could be a whole virtual machine. That's our workload. Now, here are the choices. When it comes to migrating to the cloud, I have to admit that the very first step is, does everything need to go to the cloud? I mean, you might want to look at a workload, a list of all the things you're doing at your company, each workload separately, and categorize it. And the first thing you should consider is, do we need it? I mean, yeah, you're doing the Marie Kondo. You know how she says, keep only the things that you love. So you're looking at your closet and you're deciding, am I ever going to use this again? Right? Only the things that bring you joy. That's what. So we're looking at these workloads. We're at our company and we're like, yeah, so we have 3 access databases. We use this thing, and somebody says, hold up, wait, let's go back. Did you say 3 access databases? Oh yeah, we use them. When do you use them? When was the last time you used them? This is the Marie Kondo method. When was the last time you wore that dress? Does it still fit? Yeah, maybe you don't need it. Consider that this is a good time to throw out the things that you no longer need. That's a good idea. So, are they unnecessary? Are they not cost effective? Instead of bringing you joy, do they bring you revenue? How about that? Are they insecure? Are they not secure? They really are running on Bob's laptop. Shout out to Bob. But seriously? Like, do we need that? And maybe it's not compatible. Anyway, it's a good time to clean house. Now, you know, if you've ever moved, you really get judicious. You do not want to box this up and put it on a truck and pay for it to move all the way across the country if you have not decided, yeah, I think I still need this. You get really good at tossing things. Now that we've had that discussion and you've moved out everything that doesn't bring you joy or income or whatever, now let's get serious. Let's decide. If we do need it, then we have to figure out, does it stay on premises as part of the hybrid cloud? This thing I'm looking at, this little piece of code that operates the robotic arm of the device that only we have in this building, do we need to move this to the cloud? That doesn't make sense. Why would I move it to the cloud if I'm using it as a local piece of code that supports that machinery? Not everything needs to be moved to the cloud. Sometimes you'll decide to keep it local as part of the hybrid part of your environment. You're managing it yourself. It's not subject to the same kind of things that all the other apps will be subject to. A lot of times you'll hear people say this about maybe some COBOL or some legacy app that runs on magnetic tapes. It happens. People still have this capability, and it doesn't make sense to move it to the cloud. Not everything needs to go, so you lock it down. You chain it to your you chain it to the business. You're like, yeah, you're not going anywhere, right? Now that we've gotten those out of the way, let's discuss. When you decide that the rest of these workloads, they're going to the cloud, let's decide what layer, what level of movement that we're going to choose. Now, the migration of a workload to the cloud without changing anything in the code or how it's architected, this is that lift and shift that I talked to you about. That when they came through and looked at all the apps that the government was running, and they picked a few, they looked at mine and several others, and they were like, well, these are monolithic apps. What we'll do is just lift and shift. So you take your workload, which is a virtual machine with a stack of capability on it, and boop, shift it over to the cloud. Haven't changed a thing, except maybe the login, because when you move to the cloud, the identity provider will probably shift. That's the only layer that you have to fix, is how people log in. And that's it. It's living in the cloud now. And a lot of people like that because it's baby steps. You do this if you get a lot of pushback from people who don't want to go. And I'm just going to tell you, I was one of those people that didn't want to go. And also, I think about this. This was maybe, I want to say 2019. It's not that long ago. I just wonder what people are saying, people who know me as a person, the way I pushed back about migration to the cloud, and now I'm teaching migrating to the cloud. Oh, I wonder. I'm waiting for somebody to LinkedIn me and go, is this you? And then show me all the things I said about, we don't need to go. I'm just waiting for it. It's going to happen. All right. What's another way to go to the cloud? Replatforming. Replatforming, what's that? Well, that might actually apply to what I was mentioning before. So if you migrate the workload to the cloud while making some changes to the workload's code or the architecture, like what if we lifted and shifted my actual virtual machine and just took the little database piece out? Did that one little Jenga tower, one little block, just slide it out? And then we use the hosted database instead. That's what we're talking about. Replatforming is where you change a tiny little bit of something, but the rest of it's not necessarily different. And it's also a bit of a baby step. Now, once you get to the cloud, a lot of times you'll take another round of consideration and you'll decide, now that we're in the cloud and we're comfortable with logging into the Google Cloud Console for a few, months, now we've got a level of comfort, let's push a little more. Let's change the code of the workload. This is where you might go from monolithic to the serverless microservices architecture. You see, you've got the buy-in now of all the reluctant people, and they've become more amenable to the idea that maybe they could break the code base up into containers, and then those containers could become services, and those services could be deployed on the microservices architecture, which I'm going to get into and show you exactly what that means. And perhaps you don't need to bring your operating system with you. Maybe you could go serverless. That was the destination that I showed you in my from monolith to microservices journey. That's where we landed. But hold on, there's one more step that I didn't even consider in my little discussion. I didn't even consider this, but maybe you will too when you see it. What about reimagining the way we do things? What if that application that we wrote so many years ago, that is now running in microservices in some cloud environment, but also running with old ideas of, let's run these calculations, let's do a lot of if-then statements to decide if this thing applies. What if we added AI and machine learning to replace those if-then statements? Do you remember yesterday's discussion about how Google's search engine changed from a lot of if-then to the machine learning, I got this? Right? What if we did that? And what if we used Looker for some of these? I'm using reporting systems that are kind of clunky. What if I changed it to Looker, where we had an interactive dashboard with dynamically, and what if we built an agent where we just ask the agent, so which of our customers in this stack are the most maybe close to or at their limit of whatever we're tracking in our spreadsheet? What if we could ask it questions now? That is the reimagining that would just take us to the next level. That's that journey. Maybe I should call it from monolith to microservices and beyond. A journey. Okay, the title is getting long. Okay, in my spare time, I'll write that. I know, I'll tell the AI to write it for me. We'll do that. Okay, so I got a lot of ideas. I'm still in the rabbit hole of yesterday, you guys. You have to understand how this brain works. Oh, goodness. Now let's look at how to modernize things specifically. Let's look at the benefits of running these workloads in the cloud. We're going to talk about the details of something I showed you just a tiny bit of a glimpse of yesterday, and that was Compute Engine. Remember, I went into Google Cloud Console and I configured a machine. And at first I chose an option that was like, yeah, that's going to be $64,000 a day. And I was like, oops, never mind. Did I do that? What we're referring to is the ability to compute. Compute refers to the machine's ability to process things really quickly. And you get to store data on a hard drive in that compute or remotely in one of the other data stores we talked about before. And it should be able to retrieve that information from those data stores. It should be able to retrieve that info, store it in memory, and then process. It should be able to compare information in memory or on disk if it needs extra memory space, and then analyze it in a way that we're familiar with, and possibly, can I get a bar chart? Yeah, of course, that's what we're asking for when we talk about the ability of a machine to compute. Cloud computing has a network of servers, and we're going to get a glimpse into one of the Google Cloud data centers in the next chapter, but for now, just imagine every movie you've ever seen that involved somebody badging into a server room, and row after row after row, you've just got blinking lights and beep boop bop going on. That network of remote servers is all set up in Google regional data centers, and it gives us on-demand access to a pool of resources. And as we talked about yesterday, this is why we use infrastructure as a service. We can put our applications in the cloud. It'll reserve some space. We can ask for storage in the cloud. It'll reserve some space. We can leverage all the processing power that comes with these cloud providers' resources, and we don't have to buy and own any of it. So remember what the benefits are for running a compute in the cloud. Running compute resources in the cloud include leveraging the fact that you're already paying for stuff on-prem, and a lot of people who don't calculate all of the upkeep that's required for their servers, they don't realize that the total cost of ownership, things cost a little more than they think they cost. When you buy a car, it costs more than the price of the car. You got to figure out how much is oil changes, how much is registration, and all the stuff around it. So considering total cost of ownership, the cloud is a good benefit. Remember that scalability. At the press of a button, I go from one copy of a service to many. If my load balancer sees, oh, it's getting busy in here, scalability means let's scale up, let's add more resources to support the load, and as soon as that load goes down, then we can scale back. We need the reliability that comes with cloud providers. We need to be able to do this scalable feature thing at scale, at globally, in a way that's reliable. Of course, it better be secure. We'll discuss that in the next chapter. We're looking for super flexibility. And I like that because the word elastic comes to mind, which, think about that on your waistband. Elastic, that's good. It's super flexible, right? So your resources that you're using need to be flexible, right? And then there should be some layer of abstraction, which means don't show me all the details. I don't care. Don't show me the details. Abstract it away. That means that it's going to be easier for us to leverage all these services if we don't have to think about every little thing. So let me remind you by going back to yesterday's demo, virtual machines are machines that are based on operating systems, but they're not a physical separate machine. A virtual machine is getting its resources from a pool of resources. So imagine on the left-hand side, you see virtual machine number 1 on the left. It might be a Windows OS. But that's not to say that whenever you go to the cloud provider, you have to choose Windows. No. You could choose Linux for your next one. For your second one, I have a Linux server. These are virtual, which means when I ask Google to put together a Windows server with 16 gigabytes of RAM and I want a hard drive that's SSD, solid state drives, you got to get them anyway, and it should be 100 gigabytes. And then I want another persistent disk attached to it, also SSD. This one should be a terabyte. And also I need 2 network interface cards. I'm going to need this one. When I'm choosing from the menu, what's happening at Google Cloud? Are they trying to find a single machine that looks exactly like what I asked for? No. They are grabbing resources from multiple places and putting them together under the same umbrella, and they're just going to call it Charlene's machine. Now, technically, the actual resources that are supporting me may come from several physical boxes. It's none of my business. Talk about abstraction. It's none of my business. Exactly how many physical servers are supporting my virtual server says nobody. Nobody cares. It's a pool of processing. We trust you. Just get it for me, give it to me, and as long as I don't turn it off and delete it, I've got it. It's mine. And I will ask for the storage and the networking to go with it. This is the reason we moved to the cloud. Now, the whole virtualization thing, it was a brilliant idea when it first came out. It said, yikes, if we actually put one application on one physical machine and we can't put any more on that physical machine, that's kind of a waste of space. So when we virtualized it, we just pretty much said, all right, fine. We don't have to bind specific computing resources to specific applications. No, that's too much. In fact, you're going to waste space. It's hard to right size a physical computer. You can't decide how much are we going to use. I don't know. You're going to waste some space. So the best thing that ever came out of this was let's virtualize the machines so that inside a physical box, you've got several virtual boxes. And that is a great idea. Compute Engine is Google Cloud's virtual machine. Whenever you build up a compute engine, you are, by definition, using infrastructure as a service, period. If you go to Google Cloud and you say, I would like a virtual machine, you are using infrastructure as a service. And you might say, well, is that true even if I just load containers on it? You have a physical compute engine that you're paying for that's in your list of resources in Google Cloud. Yeah, you're using infrastructure as a service, which is good. We want to be able to do this. Remember, the first step to moving to the cloud is a lift and shift. And for goodness sakes, most people are running hundreds, if not thousands, of VMs on premises. And so the way you get them into the cloud is tell them, we could do virtual machines in the cloud. And now when we move all of your virtual machines from on-prem to cloud, guess what you no longer have to pay for? All those physical machines, because you've moved the virtual machines that they were running, you've moved them over to the cloud. Google's compute engine has the benefit that is that there are no upfront investments. You don't have to buy physical hardware. You just configure what it is you want. And you can run thousands of virtual CPUs on a system, on a physical system that's designed to run them. And that's the key. Google Cloud invested in infrastructure that supports thousands of virtual CPUs that are running at the same time. It's designed to be fast because that's how they were built, with purpose in mind for that. Each virtual machine feels, looks, and acts like a full-fledged operating system as if it were a standalone machine. There's no real difference to us on the user side of this. We can't even tell that it's not actually a physical machine. It's virtual. And we're configuring it by asking for those things I showed you yesterday. How much CPU, how much memory, how much storage. Do you want Windows? If so, what version of Windows? Do you want Linux? What kind of Linux? There's GNU and these other, there's so many Linuxes. Is that the plural of Linuxes? Linux. I don't know. All right. Virtual machine instances are created through the Google Cloud Console, like I showed you yesterday. Or if you're not a fan of pointing and clicking a lot, you could have written a command at the command line. And you would have told Google Cloud to create an instance. Here's the name. Here's the size. Some developers love to type stuff in at the command line, where the GUI can change, the graphical interface changes sometimes to make it better. Your command line is always going to be what you expected it to be. So 2 ways to do it. Now, when you build your virtual machine, you can choose a couple things. Now, I know that when I built it, it said, this is going to be $64,000 a month. But then I backed off and I chose the other one, which was going to be about $200 and something a month. Now, how do they get to that bill? How does that work? With compute engine instances, you are charged by the second. Now, remember I told you, what if I press create by accident? Well, if I press create by accident and then I delete it immediately, if you had it deleted immediately, you still pay for 1 minute. So take that $64,000, chop it up to how many minutes exist in a month, and then you pay that. Still probably $10. I don't know. I don't do math on the fly, but So, but the thing is, notwithstanding that dramatic version, that dramatic example, let's say that I kept that $220-something virtual machine, I can qualify for a sustained use discount. If I keep that machine running for more than 25% of the month, the compute engine instance does qualify for a automatic discount. How much? It depends, right? There's a little sliding scale, but what it says is if you keep using it, then we'll give you a discount. So that's nice. I think of it as the No, it's like the Starbucks punch card where if you buy 10 cups of coffee, you get 1 free. It's like that. If you keep using it a lot, then we give you something back. So the committed use Actually, sustained use is it kind of kicks in automatically. This just kicks in after a while if you keep using it. You have to do nothing. Just use it over 25% of the month, and then discounts will kick in. Now that just happens, but this other type of discount, you have to actually opt into it. This discount, committed use discount, it's kind of like one of those, if you sign up for a year, then you get a discount because you committed to using this for an entire year. So for you, if you act now, you're going to get a certain percentage off of the rate because you committed to use this thing for a year. Now, the committed use discount has two modes. It goes in 1 year or 3-year periods. I'm curious. Why? Why 1 and 3? Somebody must have done the marketing, but I imagine that people know how long. People kind of see the expiration date. It's kind of like relationships. You know, when you meet a friend, you're like, I give this a year. Or you're hopeful, you're like, I could be friends with this friend for 3 years. You kind of know. You kind of feel it, right? I feel like that's what Google's doing. Don't quote me though. Nobody told me that's what they're thinking, but I feel like with companies, you kind of know whether this is a long-term solution or you're just kind of figuring stuff out. So if you go ahead and physically sign on the line, then since you're committed, you're going to get a discount as long as you actually use that resource over that amount of time. So now that you're thinking about it, you're like, okay, so I get it. I'm going to pay per second for this virtual machine as it's up and running, and I'm going to be testing some stuff. But, I mean, I'm a small company. I've got an idea about running some, okay, I always use this example. What if you're a company and you decided that you want to make an app? Take a picture of 2 dogs, upload them to your app, and your app, if you shake the phone, it'll tell you what the puppies look like. It's cute. It's called Visualize the Puppies. I didn't come up with a good name. Maybe you have a good name. So you don't even know if this is gonna work. You definitely are not gonna commit to a year of a virtual machine in order to get this to happen. And you definitely, not 3 years either. Hello, we don't even know if this is gonna work. And so then you looked at the estimate, and $221 is kind of a lot for a Linux machine. What else can you do? All right, are you ready? You can run a preemptible VM, otherwise known as a spot VM. Preemptible and spot VMs look just like the regular virtual machines, but they are temporary. These machines are gonna be stood up for you, and you can use them as long as Google doesn't need them for anything else. As long as Google doesn't need that particular type of resource that you stood up, you can use it. Now, preemptible says you could use it for up to 24 hours, and then we're going to take it away. Spot VM says no upper limit. There's no limit to how long you can have it, but here's the rub. At any moment, we might take it from you. Now, why would you choose that? Because you get to save 90%. Up to 90% off. So in my example, I'm paying $22 now instead of $220 now. This is looking pretty attractive now, isn't it? Now I know that what I'm doing might be interrupted at any time, so therefore I should create a workload that is able to be interrupted at any time. I should not say, oh, it was just getting good. No. I better run something on that machine that can be interrupted at any time, and then I can go in and restart it again, like some batch job or something like that. And so preemptible and spot VMs, the only thing about this choice, although it's very attractive, very cheap to run, it had better be able to, within a moment's notice, 30 seconds notice, that whatever's running on that machine can be gracefully stopped. And maybe whatever state that you got to can be stored somewhere more permanent, and then it can gracefully go away. All right, so Compute Engine is going to terminate these VMs if it needs it. So notice, a preemptible or a spot VM is not the same thing as a regular compute engine VM. When Google needs more space, all right, think about Black Friday. Black Friday, biggest shopping day on the internet. I think it's all just blending together now, but sure. Imagine you've got a preemptible or a spot VM and it's Black Friday. Chances are they're going to take your resources. They need them. They need them. You can't, and you expect this. But when it's not Black Friday, chances are you can keep using it. So the main difference between a spot VM and a preemptible VM is this. Preemptible VMs run up to 24 hours. So you already know that the max amount of time you get is 24 hours. But with a spot VM, you never know. It could be up for more than a day. You could use it if you get lucky. Maybe they just won't notice you and all the other machines get preempted, but not yours. But just know that you're going to run code on there that's ready. As soon as that VM receives a termination signal, you're going to kick in a batch job that runs and cleans things up and copies things to permanent storage and then gracefully closes. So that's the kind of recommendation. And the same pricing applies to both. Compute Engine lets people choose whatever they need for the job that they have at hand. So as I was mentioning yesterday, when I choose that Windows machine with this kind of memory and that kind of CPU and so forth and so on, I'm able to pick and choose a custom set of features, or I could use Google's little short menu. Remember that little handy menu? I'll just show it to you really quick in case some of you weren't here and you're like, no, I don't remember. You keep saying remember, I don't remember. Okay, sure. I could show that really quick. Look, I'll go to Google Cloud. That's my Google Cloud project, and I go to Compute Engine, and all I have to do is say I would like to create an instance. That instance creation screen comes up, and if I can zoom in so you can see it maybe a little better. Notice the choices I get to fill in here. I could give it a name, my instance, and then tell it where to put it. Put it near you if you can. Northern Virginia is where I am. And here is that menu of predefined computer configurations. It's like going in to a fast food place and saying, okay, I'll have a number 11. You don't have to think. It's like, okay, that looks good. I mean, it's close. I kind of want those things. You could use the shortcut by just picking some pre-configured type of machine and then choosing the settings that work for you. Or you could choose the custom and you can just use these little sliders. How many cores do you want? How much memory would you like? And then you get some advanced configurations. And I love the fact that on the right-hand side, you get a little preview of how much that's probably going to be, not including the discounts that we talked about before. So being able to choose predefined options for Compute Engine, not a bad idea. Definitely play with that. Come back for more classes if that infrastructure as a service, if all of that piques your interest. If you love that, now you know. Come back and learn more. Meanwhile, developers, you've heard of containers, haven't you? Containers. They're awesome. Developers love a container. Now, if you're not a developer, or if you're developer adjacent, is what I call it, let's explain. Now, a container is an isolated environment that lets you run your entire application. That all of the dependencies and everything are all inside this containing outside structure. And that is a good picture of a container. It reminds me of shipping containers. Like, remember during COVID, that one ship got stuck in the canal. It was sideways. We were like, no, my boots. Those are my boots in there. How do you know they're your boots? You don't. Nobody can see inside the container. That's the point. There's a lot of goods that if they weren't containerized, it would be really hard to organize them. Would you agree? How are you going to stack it up and load it up with? You can't. You need a box. So with developers, it's the same thing. I was working on my virtual machine one time. have to tell you about. I won't say his name because, again, these people might find me and they're going to be like, why you got my name in your mouth? I'll be like, oh, I'm sorry. But there I was. I had my virtual machine, and I'm very territorial. You could hear it in my stories. Yeah, I say my a lot, but there's a team of us. Obviously, fine. So this VM was running, and as you know, I was using Angular JS. That's old version. Any developer in here will tell you, Shar, that's like the oldest version of Angular. I know. I did an upgrade. At the time, I wasn't ready yet. I was taking my time. It was fine. So my application's running on this VM, and Angular is a software package that when you install it, it puts little bits everywhere all over the machine, which is fine because my application is running on that machine. And so I have remember my HTML, I have my CSS, all running on this. Everybody's happy. Well, here comes this guy, and he works with me most of the time. He's helping me. He's on the team. And he goes, Shar, this other environment, this other group wants me to do a thing. Can I just use our server to put the Oracle solution on there? Now, when I heard Oracle, I should have said no, but I'm nice. Sure, come on over. So he brings his Oracle, which is fine. Oracle comes with a lot of Java, blah, blah, blah. That wasn't the problem. He brings it, and then when he codes, he decides to do Angular 2. Angular 2. You don't know this, but if you install Angular 2, it replaces and upgrades all the Angular JS. What are the chances that my code written in Angular JS is going to work fine with no changes because a new Angular is on the machine? You're right. That stuff just crashed. It failed so gloriously. I call it, he got his peanut butter in my chocolate, or I got my peanut butter in it. Listen, we should not have been doing this. At the time, I ended up kicking him off and he had to get his own virtual machine. I'm not proud of this. Again, these are all the things you shouldn't do. I said, turns out these two, Angular JS and Angular 2, don't work together. Get your own VM. And he was like, oh. So he went to his own VM. He did his Angular 2 over here. I had my Angular JS happily being old and all that over here. Everybody's happy. Turns out, my friends, containers fix the problem. So if we stretch our script back to the beginning, if I could just go back. But listen, every experience I had led to a good story for you. So I will claim it all. Listen, that one virtual machine, if I just built my app in Angular JS and I had it in a container, my Angular JS is over here being all Angular JS-y, and all my other stuff is inside here. Meanwhile, he can bring his Angular 2 and put it in a container here, doing all the Angular 2 stuff. Everybody's happy on one virtual machine. Interesting. Now, I'm going to tell you, just like I should have taken it personally that people said I was monolithic. No, they said my app was monolithic. And it turns out every single virtual machine in many environments are not using containers. It's just one VM running one app, all wiggly, not containerized. That's just how that is. And so when you come to an environment like cloud, that's when you start to go, oh, maybe I should not just throw another virtual machine at the problem. It hits different when you're in the cloud. You're paying for every single virtual machine that you own. You're paying by the second. And yes, there's a discount, but you're still paying. You're still paying. What if your workloads could be containerized? Then couldn't it use fewer VMs? In fact, couldn't you go without VMs at all? I'll get there. I'll get you there. You see, containers. What happened in my virtual machine that was not running containers? It was not creating little environments for each application to work inside. It was just all, I'm not using technical terms. I'm purposely not. Instead of containers, what was happening on my virtual machine is that all the code, all the dependencies, all the reference files were just loosey-goosey as part of the operating system. So anybody else that comes that tries to change that operating system, they're going to bump heads. But with a container, you've got all your dependencies and all the little files. They're inside. They're limited to their structured walls so that other items can run alongside of it. And in a nutshell, let me just show you this picture that's beautiful. Shout out to Barry's team who created these slides. Look. Virtual machines on the left. This is the way the world is working right now. On-prem right now. You purchased one piece of hardware and you spent a bunch of money and it's fast and it's smart. So it costs you nothing. Okay, maybe it costs you something. We'll talk. To spin up a virtual machine to run my app, another one to run his app, another one to run their app, another one to run the other app, and what about that other app? Spin up another machine. Costs you, well, it depends. It depends on what your licensing looks like. Now, if this is if those operating systems inside those virtual machines, if these are Windows ops, I feel like they would charge you per. I feel like the Windows would get their license money each time you use their Windows operating system. Again, you might have some enterprise license that lets you spin up as many VMs as you like. But these are still operating systems. And if it doesn't cost separate money, they get patched. You have to patch these. Have you ever had to patch a whole fleet of Microsoft? I'm sorry, I'm trying to get the word Microsoft operating system. Usually you have to take your weekend and upgrade each one and make sure it worked and do it before people come back to work. This is a lot. So not only are we using individual virtual machines just to isolate apps from each other, now we created a whole lot of work for ourselves. That's not fun. 6 more minutes, I'll give you a break. Now, what is the solution? Containers. Look across to the solution over here. Containers. Now, notice we still have an operating system that's running everything in general, but think of this as one virtual machine, if you will. The containers are running on the same virtual machine. It's just that they have a little layer between the container and the operating system to help, figure out who's who, what dependencies are whose. This is much cleaner. You can run just as many containers. It depends on the size of the container and all of the resources that it needs, but many containers can run together in this environment on the right versus having individual machines per application inside the environment on the left. So hopefully you understand that that's how that works, how to build a container. Oh, come on back to some of our classes that we teach on application development. It's super fun. So the last few slides I'll show you is the reason why containers run faster is that they're very lightweight. And I'll give you an example of, let's think about your phone. Imagine, because this picture assumes a lot. Let's say this is your phone and this is an app on your phone. If you were using virtual machines to do your app, if you were in the environment that I talked about that doesn't use containers, every time you wanted to open a new app, you'd have to restart your phone. Think about that. Every time, if you want to open a new app on your phone, restart the phone. Takes a while, doesn't it? Wouldn't it take a while to pull up your app if you had to keep restarting your phone? In fact, I submit that we wouldn't have apps if we had to restart our phone every time we wanted to use one. We just wouldn't do it. But that's what's going on in the old world of one app per VM. You had to wait for the VM to start, and then it could serve up your app. But in the world of containers, you have apps on your phone. How fast does it take to spin up an app on your phone? It's quick, right? That's how containers work. To spin up a container, it just starts. It's ready. But yeah, that's the idea. Come on over to containers. And this is the last slide. Then there'll be a quiz question, and then you'll take your break. Just remember this, inside of a container, the developers will put everything they need. The application itself and all of its dependencies. You'll get your Angular file, you'll get whatever you need. It does pretty much an install of all the packages that your app depends on. It'll pull all the package dependencies in, load them in that little containerized area, and then start your app. And all of those little dependencies are not going to get in the way of all the others that are in other containers. This is going to be the backbone of your microservices architecture. Containers are a large part, maybe 90% of the backing that we use for microservices. Okay, time for a question. I know you're ready to take a break. I get it. All right, listen. A travel company is in the early stages of developing a new application, and they want to test it on a variety of configurations, different operating systems, different processors, different storage. Now, thinking of everything we talked about, please choose what option should they use. Okay. I see a lot of you chose A, but a lot of you chose D. It's definitely D. You see, you had the recency bias. You were thinking containers because that's what we just talked about. But because we said a variety of configurations, different operating systems, different processors, different storage options, we had to be talking about different virtual machines. Okay, well done. Let me turn on a little music and turn on a timer. I will give you a whole 15. What? 15? Yeah, 15-minute break. Music is here. Okay. That was fun. Boy, it took me by surprise. I don't know why. Hello. Hi, we're back. So, you want to build a container, do you? Do you want to redo your application so that it runs in a more microservices way? Well, congratulations, come on over. Now, you have to think about it though. What kind of workload are you running in your containers? And do you need help orchestrating them? So in my example, where I had a monolithic stack, I broke it up into several containers. Each container should work together as part of a single website solution. I need to choose, how are we going to orchestrate that? How am I going to make sure that each container runs on its own and also knows how to talk to all the other containers? So I'm going to need Kubernetes. Kubernetes, a Google created platform for managing containers at scale. Now, I know you could probably run a couple of containers without using something like Kubernetes, but it's going to get ugly, and it's going to get ugly fast. For example, you might have to have, like, if your application is broken down into maybe 10 different containers, how are you going to ensure that they can all talk to each other securely, use the memory properly, run on a group of machines? Maybe. All right, yeah, Kubernetes, yeah, you're probably right. Now, Google has been running their operations on a Kubernetes platform for years, and then they open sourced it and they made it available to everybody, so a lot of cloud providers run a flavor of Kubernetes. But don't get it twisted, as the kids say. Listen, Google made Kubernetes up, and I feel like they looked around and said, look at everyone struggling, trying to get their containers to work. Should we help them? And the other people in the room were like, let's be googly. Let's help them. So they open sourced it. Now, when you come to Google Cloud and you choose to run Google Kubernetes instances, you're going to get a bonus. So I decided to walk us through, since we have a little time, I'm going to walk us through the idea of taking an application and running it in Google Cloud. So what I did, I went to my console, my Google Cloud console, and I'm going to build a Kubernetes instance. I'm going to build a cluster. So, hold on, they've changed everything again. Creating a cluster probably is there. Good. Whew, the GUI changes nightly. It's insane. All right, so here we are. I'm going to create a Google Kubernetes cluster. That's going to be the place where I'm going to put my many containers. I'll click Create. Now, the choices I have here are to create an autopilot cluster, which is not what I want. I want to own some virtual machines. Pretty much, I want to lease physical virtual machines, and I want to manage them myself. So I'll choose a standard cluster. And it says, all right, are you sure? Because autopilot makes it so much easier and you don't have to. I'm like, no, I know what I'm doing. Standard cluster. And here I am. I'm going to create a cluster. Its name, fine, cluster 1. Where do I want it? In US Central 1C. Sure. And the next thing I'm going to tell it is that I know that I'm going to get a pool of compute engine instances, and I'm going to pay for each one. This is infrastructure as a service. I'm going to pay for each one, but could you give me 4 computers instead of 3? I just tell it, number of nodes in the cluster, 4. And then I'm going to tell it one more thing, because each node in the cluster must be identical compute engine instances. And then I'm going to base it on the E2 type of machine. This should look familiar to you. I've shown you this several times, right? This is my pick list of what kind of computer should we use. And I'm going to choose the E2 one, but I want each one to have 4. E2 4. Just trust me, I've been doing this demo a minute. Okay, that's enough. That's all I'm going to tell it. If you want to know more, come back to one of our classes. I'm going to click Create. And now, while that's creating, much like the cooking show, they put it in the oven and they move on and it's going to be baking in the background. Kubernetes is back there. It's building me 4 machines. So what exactly is going on while we wait for it? Behind the scenes, Google Kubernetes is really a layer of software that is going to manage a collection of compute engine instances. These compute engine instances are physical machines that as I mentioned before, I'm going to be paying for. Remember, I pay by the second for each one that's running. And there are multiple of the same type of computer. So I asked for 4, I'm going to get 4 of these machines. Each one of them are going to be identical because it's just a set of backing resources that are going to run my containers. My goal is going to be to deploy a microservices application to this cluster of computers, and I'll deploy those as soon as they're ready, as soon as that cluster is ready. This is highly customizable. I could choose the size of the node, how many nodes should be in the cluster, what does each computer look like. Meanwhile, this Google Kubernetes Engine, GKE, is going to orchestrate everything for me. It's going to manage everything from permissions to little firewalls. I can make it private, I can make it public, I could put workloads on. It's going to be crazy container management that I could not have gotten using other things. And now remember, this Kubernetes also abbreviated to this, get this, Katie's. If you're in the world for a while, they take the name Kubernetes, they take the K, then they take 8 of the letters, and they take the S, and they call it Katie's. Isn't that super cute? Anyway, come back to our class. We'll show you how to code Kubernetes. But anyway, as we tell Google Cloud to go ahead and please carve out 4 virtual instances, 4 virtual machines, tie them together, do a little control on top of it so that I could load my containers, it's creating that for me right now. Now, this is a heavy lift. I'm not going to minimize this. If you choose Kubernetes Engine, it's because you have a lot of different containers that need to be orchestrated and they need to work together. So there are different ways, once it creates that cluster, that physical set of servers, there are different ways to deploy applications to it. And one of the ways is through the GUI. And another way is through the my pen is gone, is through the API, which is command line interface. I could use the command line interface to do it, or I could just use a point and click. So for me, as I demo this to you, as soon as it's finished, you'll see how I get Google's microservices demo to be deployed onto that cluster, and you'll see the resulting app, and it'll take less than a minute to deploy. Once it gets set up, it'll take less than a minute to deploy. But in the meantime, because as if we were in a cooking show, we'll talk about something else while the cake is baking. Let's discuss, I don't know, bruschetta? Cloud Run. Cloud Run is an alternative way for you to run a containerized application. You see, Kubernetes is a pretty heavy lift, am I right? It's going to have physical servers, Kubernetes. But what if I just want an app? I've got a containerized app, and it was hard to write, and I finished it. Yay, it's ready to go. Can I just toss it somewhere and have somebody run it? Oh, yeah, you want Cloud Run. You want Cloud Run. Cloud Run is another option to run a containerized app. Now, in this world, it's not infrastructure as a service. Cloud Run is serverless. This is platform as a service, right? And it's fully managed. All you have to do is go to Cloud Run and say, I have this thing I want you to run for me. And it says, where's the thing? And you go, it's right here. And it goes, 1 moment, please. Let's show you how that works. So I have a new instance, same Google Cloud Console. The other one's busy baking. Let me go to Cloud Run on the menu. Cloud Run has no running containers right now, so I click, I want to deploy a container. And it says, what do you want to do with it? Let me see if I could zoom in for you. What is this container going to do? I tell it, it's going to be a service. The other choice was it's going to be a job. But a service is something that's up and running and stays running until you shut it down. I want a service. And then, because containers can be stored in a repository somewhere, I have to tell it where to get the container definition, the image. Where is it? And then it goes, I just tell it this one. I want this thing to run. What's the name of the service? Let's call it Flappy Bird. You ever played that game? All right, you're about to play it. I want Flappy Bird, which lives in a Docker Hub registry by some guy named Bargov Bunny. Shout out to Bargov Bunny, who makes this available to us. Any container, anywhere, just pull it down. And now I have one more thing. I want to let anybody, anywhere run this thing. And I do want to tell it one more thing to listen on port 80, which is the default port for websites. I'm done. I click create. And what's going to happen is Google's going to go over, find the container, download it, attach it to a process, open up port 80, let everybody access it, and it should be ready any second. Normally it's ready by the time I finished explaining that. And it'll be ready in a second. Aw, come on, the Flappy of the bird. Okay, Flappy Bird is normally up by now. Why are you not up? Let me see. It's not routing traffic yet. Okay, now it's coming just now. Good. I'm going to play Flappy Bird. Are you ready? Click the button. Remember this? Oh! So this Flappy Bird, please play it. Here it is. Play this Flappy Bird for me because later I'm going to show you logs. I'll show how I can find how many people logged on simultaneously, how many copies of the container are being used, all the metrics that are available when you host a service like this. All right, I know I've just distracted you and now you're going to be playing Flappy Bird, but guess what? My container is ready. My Kubernetes is ready to go. So while you're doing that, let me get some software into this Kubernetes instance. It's ready to rock and roll. There's cluster 1. So the first thing I have to do is give myself permissions to access the contents of it. So I will ask the gcloud command to give me an endpoint. Message not found, US Central 1C. Oh, yeah, it's 1C. It's fetching my endpoint, and I know you're playing Flappy Bird. Keep playing. If your boss walks by, tell them, I'm busy doing as instructed. Charlene requested that I create a few Flappy Bird instances so she could do the logs. Just tell him you were asked to play. Okay, in the meantime, I'm getting some software in the cluster. What I have to do next is go to my microservices demo, CD the microservices demo, go to my release folder, and kubectl apply -f everything in the file called Kubernetes manifests. Right now, Kubernetes is loading up my microservices. This is the demo. Now let me head on over to this cluster. I'll give you a real feel for what just happened. I'm going to go and ask for the workloads. Please show me your workloads. And look, it's in the process of deploying. Now I know it looks worrying because there's a lot of, oh my gosh, but don't worry. Let's refresh it. They're coming. It's always the ad service that takes the longest time to get itself together. It's coming. Meanwhile, so these are, by the way, what you're looking at right now, these are all containerized services. Google Cloud created a whole website whose job is to sell you fake products just for fun. Each one of those pages, each one of those pieces are served up by a separate container, which each container is serving as a service. This is microservices. Let me refresh one more time. Oh yeah, we're ready to go. However, I'm not really showing you the right thing. I need to show you the services because this is what's really going on. These services are now working together to get me a website. And let me copy the link of this website, give it to Blake so Blake can give it to you. It's a world of cooperation. This right here, my friends, that's the link to the microservices website I just deployed 5 seconds ago. Let me click it. We're shopping. We're shopping. This is the newly created microservices website that has been deployed to my Kubernetes cluster. I have 4 virtual machines. Each one is helping me run this application. Now, mind you, this is the front page. When I click, I'm now looking at the services that came from a different container. Which one? Probably the products service. For each product, there's a picture of it, there's a cost. This down here, served up by the ads service. This is the recommendation engine. When I click to add the glasses to the cart, I'm now looking at a microservice called cart, shopping cart. Now, if I want to see the price, not in US dollars, but Japanese yen, I am now looking at the results of the service called the currency service. If I want this, I'll buy it. So I click place order. I am now interacting with the order service. Dude, the hard part is writing the code. Let's be honest. Deploying it and getting Kubernetes to run it, easy peasy. That's Kubernetes. So everybody shop, buy some fake items if you can, and then I'll have something to show when we start talking about how can you observe everything that's going on in Google Cloud. So in a nutshell, let's remind ourselves what we just did. We created containerized services. One of them was Cloud Run. That's the flappiest of the birds. We just said, please do it. It was like, okay. Now, clearly, if there are how many people of us in this, how many people are alive right now? We've got, a few of you, 1,000, 1,800. Listen, if everybody gets on Flappy Bird, Cloud Run knows to scale up to support all of the requests. The free tier is 1 million requests or a certain, we're not going to go past it. Like, I'm not going to pay a few cents as I would if I had this up and running for weeks and weeks. It's going to be free for now. That's cool. Free tier is awesome. You are looking at, in Flappy Bird, a stateless application. This application does not need to remember data. It is not serving up any inventory products that have to be carefully honed, and it's not trying to remember your login to serve you the right Flappy Bird. It's all stateless, nothing to remember, which is the perfect workload for Cloud Run. It will quickly scale up and scale down to support us, and it's wonderful for lightweight applications like websites or little functionalities like this. Now, if you're thinking about the difference between Kubernetes Engine, GKE, versus Cloud Run, you would be right to notice a couple of things. Kubernetes is something you would use to deploy complex containerized applications. Complex applications that you have a lot of interactions happening. Remember, I think there were like 12 different containers, each one leading to another one. That whole website brought it all together. Now, mind you, that same website was probably served by a monolithic app before they broke it up. That's what we're talking about, the ability to scale different pieces. Now, Cloud Run, simple, fully managed, scales up and down quickly, serverless. Now, there is a flavor of Kubernetes called Autopilot that is a bit serverless, but it's kind of not really necessary for you to know the difference between Autopilot and standard clusters, so I just kind of made mine a standard cluster. So when I talk about serverless computing then, what I mean is that not that there's no server, there is a server. But remember that when you're running serverless computing, you're using platform as a service, and the Google platform will find underlying resources upon which to run your application. You don't have to pay for servers, you're paying for the code itself. Compute power automatically provisioned in the background. And you get The business is going to provide the code, and then I always imagine it as, I have this code, where can I run it? And I imagine that tossing it over to the cloud, and then the cloud's like, okay, got it, we'll run it for you. Another example is another type of thing. It's called a function. I don't know if you've ever heard of functions, but Google has now renamed it. They call them Cloud Run Functions. Cloud Run Functions. Now, what a function is when company writes the code that responds to something. You're going to write code that responds to something that happened in the cloud. Here's the example. You write some software for a business that helps the employees manage their corporate expenses. That's great. That's wonderful. Yay. Now, what you would like to do is write a function so that when a user uploads an image, then it kicks off a function that works with that image and moves it to the proper location, for example. Functions exist so that they can respond to things that happen in the cloud. If somebody uploads something in a bucket, then do something. So functions respond to events. And therefore, let's look. And I didn't mention App Engine. That's another thing that Google offers. App Engine was Google's very first application. It's the very first thing that you would put into Google Cloud, first hosting kind of thing that they had. You would put your website out there and it would be an App Engine. But more modern, you'll put a containerized app, you'll deploy it to Cloud Run. The thing about this, your Cloud Run accepts containers in the first place and then deploys it and runs it. Functions, Cloud Run functions end up being containers. It creates containers, but you don't point to a container inside a function. You create a function, you're pretty much writing some Python, or you're writing some C#, you're writing some code, and then Cloud Run turns that into a container and then tosses it over and it runs that function that responds to events. It's attached to events. You're pretty much going to tell the function, okay, here's when you're going to run. Run when somebody does something. So you've got these App Engine, Cloud Run, Cloud Functions. These are the things that are all serverless compute. All serverless and wonderful. And it's wonderful because we are not paying for compute engine instances. Listen, if I spin up Google Kubernetes Engine and nobody goes shopping on my website, I'm paying per second, aren't I? Paying per second for those compute instances that I have running. So with a serverless computing model, I only pay when somebody uses it. I'm not paying to host the resources. I'm paying for when people use the resources. That's kind of nice. Because again, if I build it and they don't come, that's sad, but at least it's not also expensive. All right, I get to the market faster. I don't have to spend so much time building things. I get improved resilience because Google Cloud's gonna scale that for me. All right, so the next thing we'll discuss is that very item about modernizing and developing. Remember, an application is a combination of things. It's a program. It's so funny. I used to have to explain what a programmer was. Back before smartphones, I used to have to explain what I do. Charlene, what do you do? I'm a developer. What's a developer? I'm a programmer. What's a programmer? Now, if I just say I write apps, they go, okay. So what's an app? It's a program, it's software, it does something. Now, when you're on-prem and you're trying to build an app, it could be slowed down because your organization doesn't have the right containerized, or they don't do things in a particular way. It takes a long time to get these resources. If you move to the cloud and you're modern with your application development, you move quickly to the market. And that becomes the deciding factor on whether your project succeeds or fails. How fast can we get it to the market? It's easy to scale. It uses the latest technologies because I'm using cloud resources, not our on-premise, oh, we don't do that. What? You can't write in that coding language. We don't have enough. What? Yeah, go to the cloud and build it, and you'll be good. Traditional software development, here's the slide. I was like, it's black and white, like those old movies. Do you see the shade that they're throwing on? Traditional software development, monolithic. What does that mean? Just to remind you, single unit. It's tightly coupled. Each piece refers to the other piece distinctly, like it. You want more flexible connections. You don't want tightly coupled because it becomes brittle. And remember what happens with brittle things? They break easy, right? You want to be the palm tree that bends in the wind. You don't want to be the oak tree that's cracked in the middle of the day. So, monolithic apps are more breakable because they're tightly coupled, they're brittle, and they're typically written in one language. But when you come over to the modernized microservices of it all, each developer can pick whatever language they like. Remember, we've got a bunch of services that are floating around that are loosely coupled. And one can be written in one language while the other one is written in the other language. Everybody's happy. And you pay as you go. Highly scalable, highly available, super resilient. Now we can understand why microservices are the way of the future. And why there's a lot to be done. There's a lot of people who probably read my non-existent From Monolithic to Microservices and Beyond, ... The Journey book. It's a work in progress. We'll talk. Okay, now let's talk about this other thing about rehosting. Remember the lift and shift thing. This I wanted to mention because it will be the first step of a long journey. A lot of people will be lifting and shifting their application. Even if they rehost a bit of it by telling this application that no longer is this piece gonna be this way, we're gonna make it that way. You could do a piece of it. You could upgrade just a portion of it while lifting and shifting the whole stack, because you could save money, make it super scalable and be reliable and all that. The only issue with some of migrating to the cloud with a sort of to rehosting, like if you take your thing and you lift and you shift it, if it's super complex, you do risk that the rehosting part could be a really laborious process. So you've got to plan it carefully and migrate so that everything comes over together. There'll be a little bit of risk that you might have to take. Businesses need to assess what that risk might be and then put a plan in place just in case there are any problems. But if you think about it, by moving applications to the cloud, your businesses might become locked into a particular cloud provider. If you lift and shift in a way that needs a particular something, like a cloud provider offers a particular type of thing, and then you move there and you realize, oh no, now I'm stuck. Actually, so Google thought about this and they said, a lot of people are running VMware on-prem. Wouldn't it be a good idea if we let them run their VMware in the cloud? See, this is kind of revolutionary, because if people were going to Google Cloud and configuring a virtual machine that looks just like the one that they're already running in VMware, Google says it might be easier if you just migrate your existing workload to the cloud as it is, using VMware in Google Cloud, which is a serious one-to-one relationship. Nothing needs to change. So that way you're not having to retool it too much. And there is something called the bare metal solution. It's a fully managed cloud infrastructure solution. It lets you run your Oracle workload in a dedicated bare metal server. Bare metal. Okay, what does that sound like? Sounds like it's not virtual at all, right? Sounds like there's an actual physical server back there. Because Oracle's tricky. They have their licensing that's based on things that say you can't really run their software in a virtualized environment, because if you're paying for a certain number of virtual CPUs, because that's how they charge you by CPU, then there are burst periods where you get a little more CPU. And Oracle's like, but we need you to pay for that. We need to be sure exactly how many virtual CPUs you're using. No virtual CPU. We want bare metal, actual CPUs. You pay us based on that licensing. And I mean, okay, bare metal. You can come on over, bring your Oracle, bring your license, put it on bare metal, and let Google Cloud host it. So it's a thing. You can get it done. All right. While we're in here noodling around, if you haven't. Okay, one question. Oh, you're already answering it. I had a question. How far have you gotten on your Flappy Bird? Some people got to 2. Some people got to 1. One time I got to 3 and I was like, oh, 3? Okay, question for you though. What phrase refers to when a workload is rehosted without changing anything in the workload or the architecture? You already know this. All right, so that was a gimme. Of course you chose D. Very nicely done. Very nicely done. Okay, one more thing to talk about, and we'll wrap up this section. I'll probably give you a little bit of maybe a 5-minute break before we jump into our security module. APIs. I mentioned this a lot. API. It's an API. What is an API, you might have said? Well, it's an application programming interface. Of course that's what it is. But did you know that all of the services, all of the cloud, all of the things we do are really applications talking to other applications, and you need an interface. This is what you need. You need an interface, because if this application talked directly to that application, well, what if you have to update it? What if you have to patch it? How do we go through an organized way so these applications don't break? And how do you code it in a way that this guy knows this other guy's gonna ask him questions? It's a little too much. In fact, sometimes it's like, we don't know you. What are you doing? Like, there's gotta be a way, a bit of a way to sort of abstract direct communication from app to app. In fact, the idea of an app directly communicating with another app is kind of crazy, because you can't, how are you going to manage any of that? So APIs were created. Application programming interfaces were created to become a set of instructions that is configured to allow something to knock on the door, and we'll let you in if you qualify. And then once you get in, based on who you are, we'll decide whether you could see this app or that app and in what capacity. Somebody has to be watching the door, right? Or a better analogy, restaurants. What if you walked into a restaurant and you tried to go straight to the kitchen and tell the cook to give you some soup? I think the cook would call security. There's a crazy lady in here asking me for soup. What is happening right now? No. Again, not animals. We go into the restaurant. We sit down. We ask the waiter. That's your API. You know what? I would like some soup. And the API says, we have 3 types of soup. Which one do you want? APIs do surface, or they publish certain callable routines. And if it's not there, you can't call it. If it's not on the menu, you can't have it, right? And then the API receives your request, probably authenticates whether or not you're supposed to be ordering soup in that case, and then it goes to the kitchen and says, all right, here's what they want. This is your database back end that has data. The API is the one that's going to be passing requests, either get requests, put requests, delete requests, back and forth, and then when it's done, it serves the results back to the requester. Everything should kind of go through the waiter. That's all I'm saying. It would be weird to just show up in the kitchen. Now, APIs can be used in a lot of different applications, and I would submit to you that all the APIs, everything you use on the internet is an API. Really, every time. You use social media. Those are APIs that some developer wrote to allow your app to access the back end and pull in only those things that you said you were interested in and not anything that you said you weren't interested in. Although the For You page might be interesting, right? And then mobile apps, of course, every single mobile app is just pulling in some data from some API that they decided was good for this app. And then of course web services, that was what they used to be. Web services used to be the thing we would do. We would write web services to communicate data from point to point. And a lot of times the data would fly through in XML, but anymore they're coming back in JSON, and then websites pull up. It's a whole thing. It's just a whole ecosystem of APIs. In fact, when you use Google, you're using APIs. You go to Google search, that's an API. You go to Google Maps, they do have API. Listen, any app that involves the maps of Google, they're using Google APIs. And they're, depending on what your app is supposed to do, they've got to leverage the Google APIs that allow that to happen. That's how any of this works. In fact, with APIs, knowing, let's say you were in charge of tires. You're a tire shop. I don't know. It just comes to me. I have no idea where this stuff comes from, but you are the definitive source of tire information. Somebody can take a picture of a car, and you're the company that just knows what kind of tires are used for that kind of car. Now, if you're sitting on a pile of information and only certain people who walk into the door can figure out what kind of tire they need, then maybe you're missing an opportunity. Maybe you can write some APIs, and then you can make them available to developers. And you could say, I'm the tire genius. Don't you want to use my APIs? And then developers can use the information from your source. Okay, it was silly. How about your UPS? And everybody wants to know, where's my stuff? Couldn't you create? UPS can create an API that says, if you send me the tracking number, I'll send you the location of your package. That's an example of an API. Are you a bank? Be careful, because this is getting harder, right? As a bank, do you just want anyone to be able to check any balance? I mean, fine. You send me your authentication plus a token plus some stuff, and then I'll send you the thing you want. This is how that works, APIs. So companies can access another company's data through APIs, and that can be used to create new income streams. In fact, Google said, if a company is sitting on a pile of data and they can make the data available through an API, we should create some sort of platform that lets that company publish the APIs that can be called, and then developers can come here, and then we can track it, and then they can build. And then someone said, what should we call it? And they said, G. I don't know. It does API. API G. Apogee. Again, I have no idea how this stuff comes about, but I can believe that this happened in an office. Apogee. Let's do that. So what is Apogee? It's a tool. It's a Google Cloud product. It has a front end called Apogee API Management. And what you do is you're going to add different capabilities to your collection of APIs. You're going to authenticate. You can configure who can call what APIs. What kind of authentication do they need? It's just a central place for you to manage all your APIs. And when you have this, it helps you organize and secure all of your APIs. In fact, you're going to want to make sure that your APIs are responding within a quick amount of milliseconds. There's no delay, nothing's broken. When you deploy another version, you'll put the new version out there as on the little dashboard. It'll be a whole centralized place for you to manage all of the applications that people can call. So Apogee, it's a pretty cool tool. I was recently looking around and playing with, I think there's only like one Cloud Skills boost that shows you how to use it, but it's neat. You've got a layer that people have to hit, and then if the authentication passes, then they go to another layer. You're really protecting and being able to track the usage of all your company's APIs in one spot. So it's pretty good. Now I only have one more question for you, and let me look. I think, yeah, then we'll put up our quick break and we'll come back for the next section. Okay, are you ready? It's a simple question. Hopefully you know the answer. What open source platform was originally developed by Google and it manages containerized workloads and services? Good job. Everybody said Kubernetes and everybody is correct. By the way, Google did come up with Angular. They did come up with Go and TensorFlow, but none of these are the platform that manages containerized workloads and services. Nicely done. All right, I'm going to need 5 minutes to reshuffle the deck, and I will see you back here in 5 minutes when the timer goes out. Nice job, everybody. All right. I don't know why it started there, but hello, welcome back. Let me take you to the top. Hi, how are you? How have you been? It's been a while. I'm just kidding. Welcome back. 1 second while I get myself together. So you're doing very well, I see. Hopefully some of you got past just 2 or 3 on the Flappy Bird. Gotta give you some sort of goal for the short term, right? Get more than 2 on the Flappy Bird. All right. Meanwhile, we need to discuss security. A lot of people talk about, oh, the cloud is not secure. Let's disabuse people of those notions right now. Let's talk about security. Obviously, what is it? What exactly is security, and what terms are often thrown around when it comes to security? We'll start there and let's dive right into it. First of all, the first 2 things that you see on this slide, completely different things. One of these things, privileged access, refers to someone who, special people, not everybody, special people at your organization should be able to log in as admin on those machines that they give everybody. Everybody who has a laptop should not be able to install whatever they want on that laptop. Would you agree? That would be crazy sauce, wouldn't it? I mean, really, we would all be installing all kinds of little gaming systems. If left to our own devices, who knows what we would install? And that's the point. We're not allowed. Privileged access is granted to a few people. But the least privilege is a concept of least privilege. This applies to everyone. Everybody in your organization should only have the privileges they need to get their job done. Not one more, not a thin wafer more than what's needed to get the job done. Everybody. So question, how can these 2 things exist at the same time? How can you have a least privilege posture while having privileged access? Oh, that's super easy. You know what the government does? The place where I used to work, they gave me 2 logins. There was Charlene Banks, the everybody version, and then there was Z Charlene Banks when I wanted to switch to admin and do the admin stuff. Now, they told us when all of the people who were in the Z account groups, there was it's maybe 1% of everybody that worked there. And trust me, I did not feel special, because what this meant was that I had to configure all of the insides of the virtual machine myself and then develop the software to put on it. It was like, there's more work. But that's what happens when you're very vocal about, I don't like what you did with the VM. They were like, okay, well, here's some keys. You think you know so much, you do it. I was like, thank you, I think. So there I was with a Z account and a regular account. When I logged in, here was the rules. They trained us. When you're going to be doing administrative level stuff, when you want to remote into that virtual machine, you must use your Z account. In fact, that virtual machine didn't know anybody. It only knew people who had Z accounts. That's the only list of people who could get into that machine. So clearly there's a separation of duties. If I want to behave as the elevated user that I am, I can only do it in a certain chosen set of virtual machines, not all of them. And I can only do it in a certain way. And when I got there, I could do those things there. But when I came back to my laptop, they were like, Z, who? You are Charlene Banks. You just like everybody else. You can't do anything else. Like, so you can have both. Both can exist. Admin for some things, regular user for other things. And mind you, every single user should only have the privileges to do their job, and that's it. Then, with these 2 in mind, you can get how they could both coexist. The other thing is, don't just trust everybody. This is the trust no one posture that I need you to take when it comes to... I'm not talking about your personal life, although we need to talk later. We'll talk at drinks, okay? At happy hour, we'll discuss. But for now, trust no one. And the architecture of your authentication. This means If you have a request for an API, just like we talked about in the last section, an API should always check the credentials again. And the API, if it asks for data one time, check your credentials. Then you ask again, check the credentials again. How about a third time? Check it again. How about the fourth time? Oh, you know me, just let me through. Nope, ma'am, I'm going to need to see your ID. But we know each other. I was just here. You saw me go to the car to get my workout gloves. I was just here, ma'am. I'm going to need you to swipe in. That is zero trust. Don't trust. Don't just say, oh, I know you. I know him. He's my friend. Because every movie where it starts to go south is some guard trying to be nice. I won't check your credentials. It's part of the story. So trust no one. And then the other posture that we're going to take is bake security in to your applications by default. You integrate security measures everywhere in the system as you stand it up, in the application that you're writing, even before you start writing it, when you're still mapping out the architecture. I'm going to need you to put the authentication pieces in every level because it's not something that you tack on at the end. And this overall, how is your company, how is your team approaching security, that becomes a thing that will get graded. You'll have a security posture with a grade. And a certain amount of violations will cause you to, okay, you have 2 weeks to fix that because we can't authorize you to keep operating if you don't fix these holes. So your security posture is going to be the overall score. What is your status in your cloud environment? Because we need you to be cyber resilient. What is cyber resilience? Well, it's just like regular resilience, but it's how you recover from cyber attacks. And I know you think, oh, it won't happen to me. Everybody thinks it won't happen to them until it happens. So you just have to have a planned approach to cyber attacks in a way that will allow you to respond in a resilient way. So other concepts related to protecting the resources. A firewall. We're going to discuss this, but a firewall, well, let's recommend that. It's a network device. And what does it do? It checks the packets. So all of the network traffic, think of your network like a highway where a lot of cars go by, right? Well, a firewall will halt every car and ask a few questions. Where are you going? Where'd you come from? What kind of gate are you trying to go through? What port? These are the things we're asking each packet. And if they don't answer right, we can create a set of rules defining certain things and saying, don't let that kind of traffic in. But this other traffic can get in. So it's just a set of rules that are predefined by your organization, and they're enforced upon every packet that comes through the network. Now let's talk about it. What's inside the packet, depending on, right? So if we're talking about encryption in general takes data that's perfectly readable by everyone who speaks that language. We take that data and we scramble it. We have two keys. We have one key that will encrypt, and then we have another key that will decrypt. And then only the people with the keys to decrypt it can see it, can actually read it. I mean, everybody can look, but if you don't have the key to unscramble it, then the data looks like blah, 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 blah. Can't read it. Good. Only the intended recipient will be able to decrypt that and say, oh yeah, the bird flies high in the sky, got it. And even that's kind of cryptic, am I right? So the idea is create a way of obfuscation that gets your data so that it's not able to be observed by just whoever. So encryption and decryption, they use keys, and we're talking about the encryption keys that have to do with large prime numbers. They take them, they multiply them together, and then that's the encryption. And then to decrypt it, part of it is public, part of it's private, and together you can decrypt it. It's a whole mathematical thing. There's a show called Prime. You watching it? I don't know. It's probably on Apple, but I have too many streaming services to know what I'm watching it on. But it's called Prime. It's about prime numbers, and anyway, it's about encryption and decryption. That's all I'll say. Watch it if you're a bit geeky like me. But this is important stuff. You have to know how it all works. But first, before I move on, I'm going to check in. How's your brain working? Are you with me? What is the answer to this question? Which security principle advocates granting users only the access they need to perform their job? Let me know what you think. Okay, did you answer it right? Let me look. I was being distracted by the chat. Least privilege. Yay, you got it right. Someone did notice, Catherine did notice that I kept saying wafer thin because I recently rewatched Monty Python and the wafer thin. Oh God. It's hilarious. Watch that too. After you watch Prime, watch Monty Python one more time. Oh my God. Okay. Good job. So here we are. We want least privilege. Do not overprivilege these people. I worked one time with somebody. I won't name these people but it was long ago. It was like 1995. And this person, a database administrator, gave everybody admin privileges on the database because the forms we had would make sure that they could only see what they're supposed to see. Well, I hope nobody goes to Oracle training where people are taught how to write SQL statements because they're going to come home and try stuff and it's going to work. Man. So don't do that. Years ago. All right, let's go back to what you should do. Cloud security. What is going on in cloud security? What are the components that work together to give us that posture that we want? Well, there are 3 components. These are the 3 essential aspects of security. You got confidentiality, integrity, and availability. Hold on, you might ask. Availability? Why, isn't that more related to uptime, service level agreements, and failover mechanisms? Sure, that's related, but it is also an aspect of security. It's not just, is my data confidential, meaning it's only seen by me and the intended party who should see it. Is it integrity? I'll talk in details about what is integrity. It's also available, making sure you have uptime. This is part of it because what good is an application that's purely confidential and has full integrity, but nobody can see it because it's down right now? Could you check back in about a day or 2? What? No, it's part of your CIA triad. That's right, they call it the CIA triad, where every element of this is emphasizing something super important, like the confidentiality, the importance of protecting sensitive information. Integrity, the data accuracy and our ability to trust it. And then, of course, maintaining uninterrupted access to it. So this 3-legged stool or triangle, the most sturdy element in geography or whatever, geometry, that's kind of the idea about this. Now, confidentiality, the first part of the triad, has to do with keeping important information safe and secret. So we need both of those things. It's where only the authorized people are able to access this sensitive data, no matter where it's stored, no matter where it's sent. And really, it's the utmost importance in the cloud because sensitive information is stored and transmitted across cloud environments where lots of tenants are also involved. If you have one region, a Google Cloud region with hundreds, if not thousands of tenants that each have a little bit of something in that area, you really have to make sure that it's confidential. Nobody can eavesdrop or watch what you're doing just because you all happen to be in the same, hosting environment. That should not happen. So how do we get it done? How does confidentiality happen? It's it's a feature of encryption. Encryption is the technique that will take that data and scramble it so that only the intended parties who have the decryption key can actually make any sense of it. And I love that this is a carrier pigeon. I love it. So carrier pigeon has an envelope. And in a perfect, not perfect world, but a Game of Thrones kind of world where that's actually a raven and it has a little thing strapped to its heel. In that show, you could just get a really well-placed arrow and then the bird would come down and then take the thing and read it. But in this scenario, even if you did do such a thing and grab the envelope from the pigeon, you still can't read it. Because the contents of this packet, the contents of the message are encrypted. That's the idea. So only authorized individuals can access it. And even if somebody else accessed it, they couldn't decrypt it. So that's the idea of secure communications. Now, the next thing to talk about is integrity. Integrity just means, is that data accurate? Is it trustworthy? Or has it gotten changed on the way? Did the data get changed on its way here? And you'll hear these stories about man in the middle kind of hacks where you thought you sent a request over from your computer to that destination, but in the middle it got intercepted and replaced with something else. And then by the time it got to its destination, it's nothing like what you originally said. That data does not have integrity. So we do not want our data to be compromised in integrity no matter where it's sent or no matter where it's stored. So this is really throughout the life cycle of the data, it should be trustworthy. And that's integrity in the cloud. We got to have something that makes that true. Data integrity controls. What you're doing, you're going to implement data integrity controls. Now, a lot of places, I know Google Cloud does by default have integrity controls, but we're looking at the ability for a company to authenticate what we're looking at. What is this data? Now, one of the ways is to make sure that anybody who changes or accesses the data has provided some sort of identity. Who are you? What are you supposed to be doing? And of course, a checklist, a little set of things that we do. For example, we have evidence of tampering. There's things that'll give Google Cloud evidence that something has been tampered with. And then, well, I don't want to get ahead of myself, but part of this whole module talks about the many layers of security that are being stacked on top of each other to ensure that on every level of your services that you have in Google Cloud, we're making sure no one has tampered with any of those levels. And just imagine when you turn on a computer, how can you be sure that that's the same operating system with no changes since the last time? We're going to discuss something like that and more. So there's many layers that we check for integrity. And then there's availability. Availability. Make sure that the cloud system and all the services are accessible. They're up, they're ready. Up and ready to go for people to use them. And this is something like if your cloud provider cannot promise availability, then what are we doing here? Yeah, it's like having a backup for your electricity. It's like having a failover device, having something that enables your services to stay running, even if the primary source of electricity or the source of the service goes down. You can fail over and keep running with undetectable downtime. So that's what you'll do. Now, what kind of things can you use to measure availability? So cloud environments, what cloud providers do, they make sure that they do not put all their eggs in one basket regionally. They've got mechanisms like failover plans, disaster recovery plans. Typically, it's don't let your multiple zones have a single point of failure, that when one thing goes down, all the zones go down. What you do is you spread out your risk amongst redundant resources and then create plans that will detect failure and immediately fail over to a standby resource that was anticipated because of the monitoring that you have going on. So listen, cloud environments have to have this. Because if they don't, then we won't bring our service. No, we won't bring our clientele. We won't be clients of the cloud if they don't have this. Like, that's the reason we go to the cloud, because they've got the redundancy built in, because they have failover mechanisms, because we can ride on their disaster recovery plans and have our own for our services. So let's discuss control. And there are many C's. This is in addition to the CIA triad. You got 2 other C's. So let's call it the triple CIA. I don't know. Because you got 2 other C's. One of them is control. Control is all of the measures and the processes that you put in place to make sure that you've mitigated or at least considered every security risk that's out there. You establish policies, you establish procedures, you take safeguards, and you put them in place. And these controls, if you've ever been in a security audit, depending on who audits you, depending on your regulatory body that checks in on things like this, I know I've sat in my fair share of security audits where your application, whatever it is you're in charge of, it has its authority to operate, the ATO. But can you keep your ATO? I don't know. Let's do an audit every year. You sit down in front of these people and they've got a spreadsheet, and every spreadsheet has a bunch of tabs at the bottom. Each tab is a control, and every control has numbers 1 through N. And every control has something to do with an area that you're supposed to keep track of. It's either like this list here, your authentication. Let's go over your authentication controls. Is it true that people have to change their password every so often? Is it true that the password has to be complex? Is it true that da-da-da? Go on and on and on, a whole list of controls for that. And then there's another tab. Access. How do you keep track of who can access what? You have to answer all these questions. It can be a drag, but I want to say something. When you come to a cloud provider like Google Cloud, there are many things that are on that spreadsheet that you could just point to Google Cloud and say, inherit it. We inherit that from Google Cloud. And they're like, wait, what? Yeah, we inherit that piece. We don't have to do it ourselves because we're in a cloud provider that enables that control for us, and we're using it. And later I'll show you where you can download all the documentation of all of the ways in which Google is compliant with regulatory blah, blah, blah. Attach it to the spreadsheet and be like, yeah, refer to item B on the sheet. Inherit it. You're using an organization to host your infrastructure, so therefore you inherit a lot of the built-in security features. That's a good thing. So the goal, though, is that you need to protect against unauthorized access. Protect against misuse and any potential threat. Like, sometimes you don't even know that things are happening. People have little bugs that sit and chill out inside your system and they just watch. And in retrospect, sure, you could look at all the logs and say, oh my gosh, the call has been coming from inside the house the whole time. But you need a little, some forensics to be run on these logs. All of that is available here. So we don't have to worry, but we do have to implement and we do have to check. The other C, so we had control and we also have compliance. This is the part where you could really say inherited. Because listen, every organization, every industry has a series of compliancy regulations that they must adhere to, legal requirements, organizational policies, industry standards. Yes, there's a whole list of things. We must ensure that our security practices and all the measures we're taking align with said standards and prove which parts of our day-to-day work actually support and align with those measures. Obviously, cloud providers are like, yeah, that's what we do. We make sure that our compliance is that we have, again, I'll show you where in the part of the chapter that shows it, where Google puts all of its compliancy reports out there for you to download and little step-by-step how to implement. And we're ready. If you do these things, then you'll be compliant kind of thing. So it's going to make it nice because they have frameworks. They are certified to operate in that way. But to be clear, the benefits of integrating a comprehensive cloud security model, the benefits, or that you keep out this guy. Now, I'm not saying that just based on how he looks that he has bad intentions, but I'm not saying that. I don't know. This says to me, I mean, even your 3-year-old would be like, look, Mom, the bad guy. That little kid would point to that dude and say, look, Mom, it's the bad guy. He looks scary. Yeah, exactly. So watch for that dude. Okay, quick question. Since we're here, I'm going to check to make sure you're with me. Which definition best describes a firewall? I know I said it a while back. Do you remember? Let me know in the chat. You got it. It's D. It is a network security device that monitors and controls incoming and outgoing traffic based on some rules that have clearly identified what's okay and what's not okay. All right, great. We've got 13 or 12 minutes or so before our lunch break, and then we have a panel coming in. But first, let's talk about threats. Let's talk about threats. It's getting more and more scary out there. Now, I don't mean to terrify you. I know how this could come across, but I do want you to be aware. So, new risks emerge. AI, anyone? This AI, did you know recently, I read this thing, it said that there's a new product out there available for the bad guys. You know how we have infrastructure as a service, software as a service, platform as a service? Guess what they have now? Phishing as a service. Phishing. PH as a service. That's right. There's a point and click on the dark web, I imagine. You want to make a site that looks just like Amazon's login screen? Point and click, and the AI will just build it for you, and then you just have to replace your thing, their thing with your thing, and then send it out. What is happening right now? I'm going to need every single person who's operating for evil. If we all just pool our resources, couldn't we have like flying cars by now? I'm just saying, like, if everybody takes that brilliant brain of theirs and stops trying to leverage it to get money from those people who are unsuspecting, couldn't we like fix world hunger or something? Dude, phishing as a service? Seriously? Anyway, let's start with the easy ones. Social engineering. Okay, everybody, let's answer the Facebook quiz. What's your stripper name? What's your stripper name? Oh, that's fun. What could go wrong? Okay, it's a combination of the street you grew up on and your first pet. Those happen to also be security answers for your bank account. But let's play the game, though. What are you doing? Stop it. Which Game of Thrones character are you? Now, just let us know your mother's maiden name. Okay, wait, what? What's happening? So phishing is where some sort of thing wants to collect personal details about you. Quizzes are, I think, number one. Well, and if you're at work, they might want to collect personal details about your employees, and then try to get to your employees if you're running a business. How about your students if you're in school? It's just pretty much trying to get you to divulge something about you so they could use it to get... I always feel like I'm fear-mongering, but it's important. I'm telling a 4-year-old, do not talk to strangers. But why, Mom? I hate to have to tell you this, but let's sit down, honey. All right, what about physical damage? Is that a cyber threat? Absolutely. Organizations are responsible for safeguarding their data, even if something happens and you didn't know it was gonna flood, and oh my gosh, the data center now has water. That's not good for a data center. Oh my gosh, the hard drives are now corrupt. Ooh, we don't have backups. Okay, that's a problem. So you have to make sure that whatever you're using for backups is not physically located in the place that's being backed up. separate those two and maybe take one of the backups and take it offline and put the other one in another cloud provider. Just do a lot of copies of things, put things everywhere, and be ready for power disruptions or damage to hardware. Now, let's talk about some of these other things. I was reading in that same article that said that phishing was now as a service, that people are moving away from the ransomware of it all. Ransomware is kind of going down in favor of the AI generated tricks. Like somebody sounds like your CEO could call the bank and say, yeah, I'd like to transfer $2 million. Like it could, if your CEO is on record as having talked, then they could get an AI that talks like that person. And just this kind of thing is what we're looking at. Of course, we have the typical ransomware where they do lock your files and they hold them. And if you don't have a robust backup system, that, as I mentioned in the previous slide, is also air-gapped. That's what they call it when you take it offline. Your backup is not also accessible through the internet, because they'll run a script that'll go find any attached drives, even your cloud hard drives that are connected as a drive. Those can be vulnerable, so detach those, right? And these are the things you'll want to do. And it's extortion. And if you pay them, then now your name is on the list of people who pay, and that goes out on the black web and then the dark web, and then now everybody knows that you pay. And then they come at you even harder. It's sad. It's sad. All right. What about, okay, so you covered those two. Everything's fine. But what about third-party systems? What about the security of this third-party system where you've plugged in some finance tool and they have a sort of a breach? Or you're running some website and they're using some breachable application like a WordPress that sometimes if you don't patch it, it leaves holes open. Anytime. What if people come and they audit your system, but they come, because they're accountants, they come with their laptop, they've got some spreadsheets, and they ask, where can I plug in? And you give them a hard line into your main company's network. Now, if that accountant's laptop is compromised, the code inside wakes up, oh, we're in a new network, let's go. So it's important to create a boundaried network. If you do want people that come in to be able to plug in their laptop, give them a guest network that doesn't have egress or ingress into your main network. Just kind of border that off. All these things are terrifying, right? I know. I'll keep going, but I'll get through the end of it. I'll get through the end of it, and we'll leave on a good note. All right. You could have some configuration mishaps, too. In fact, a lot of times, surveys have shown that misconfiguration is really mostly the problem. You see, I thought they were going to say people who leave their password on a sticky note on their monitor, that's the problem. That's also the problem, actually. But misconfiguration, it'll happen when somebody installs something, maybe an Internet of Things device, and they leave the password empty. Or have you ever gotten a new router from your cable provider and you just plug it in and on the back there's the password on the router, it's the same as whatever, and you don't change it? That is kind of a good example of misconfiguration. Or you didn't finish during the setup. You didn't take away all the sensitive information that's just part of the name of the device, and now it's just out there advertising itself. So definitely adopt a principle of least privilege. Everybody can only do a little bit, and only a few people can act as admin, the person who installs things. All right, so I'm not going to jump into Google's trusted infrastructure yet. I want to talk about that after your break. So guess what? I'm sending you off to get your lunch 5 minutes early, right? Because this is good. 5 minutes early. Make sure you come back here at 10 minutes after noon Central, so you could be here for the panel. And I'm going to toss it back to Kate so she could take you to your lunchtime. I'll see you after lunch.
All right. Thank you so much. Thank you so much, Charlene. Another incredible session this morning. So a little recap of some of the key things I heard. Charlene went deep into monolithic versus microservices, talked about the tech stack and helped us understand all those layers, had that great Jenga example to explain microservices, talked about virtual machines and then containers, Kubernetes, and started into this whole trust and security element. So amazing work. Thanks for sticking with us. Now we are going to give everyone a 10-minute break. And actually, we're going to give it's about 14 minutes now to go grab something to eat for lunch or a serious snack. And please bring it back with you, as you will not want to miss this amazing Women in Cloud Executive Panel Lunch and Learn. We are going to start right at 12:10 p.m. Central Time, so 10 after, wherever you are. So 12:10 p.m. Central. We will have Krista McGilvery, my colleague and good friend and co-founder of Launchpad for Women. She and I created this crazy thing together. Krista is going to moderate a panel of 4 incredible Google Cloud executives for us while we eat, and you are really going to enjoy it. So please come back at 12:10. Thank you so much. Hello, everyone, and welcome back. As you grab something to eat and get settled, I would like to take a moment to introduce you to my colleague and friend, Krista McGilvery, the co-founder of Launchpad for Women and Regional Cloud Learning Lead for the West in Americas, who will introduce our 4 esteemed Google Cloud panelists and moderate this Women in Cloud Executive Leadership Panel discussion over lunch today. So sit back, relax, eat, and enjoy. Krista, over to you.
Thank you so much, Kate. Hi, everyone. It is truly amazing to be here with you all. As Kate mentioned, my name's Krista. By day, I'm a regional lead for Google Cloud Learning Services. And by also day, I guess, I'm the co-founder of Launchpad for Women. So thank you so much for being here. Anything related to learning, training, empowering women in tech, I'm probably there with a big cup of coffee like I'm doing now. I think this is my second cup by now, but enough about that. I know that we're all here for the real stars of the show. We have an incredible lineup of powerhouse women joining us today, and I cannot wait to dive into their stories with all of you. All right, let's dive in. Let's meet our panelists. I want to first introduce Maria Munoz, who's our Director of Google Cloud Consulting for Northam. Welcome, Maria. Thank you so much for being here.
Thank you, Krista. Hello, everyone.
Next up, we have Jackie Soares, Chief of Staff for the Office of the President.
Hi.
We've got Samya Karunacharan, Director of Go-to-Market Commercial Office. And last, but certainly not least, making her fourth appearance on Launchpad for Women, we've got Alexis Johnson, Director of Customer Engineering for Strategic AI and ISV. Let's please show them some love. Let's get some emojis going in the chat, some kind words, some virtual applauses, maybe some dances behind the camera. Welcome, ladies. Let's kick things off. So to start off, I'd love for each of you to introduce yourself, share a bit just, about your journey, how you got to where you are today, and let's, have some fun. Let's spice it up a little bit. So throw in just a fun fact about yourself. Maria, I'm going to hand it over to you to kick us off.
Thank you, Krista. Maria Munoz, leading the Pursuit Leads here in North America, as Krista mentioned. A fun fact about me, I came to the US, almost 11 years ago. I am from Spain. I learned how to dance. I dance flamenco. I love all the arts. And at the same time, I love the science. So happy to be here. Thank you for having me.
Awesome. Thanks so much, Maria. Jackie, you want to go next?
Sure. Hi, everybody. My name is Jackie. So I'm the Chief of Staff to our Head of Global Revenue at Google Cloud. And his name is Matt Renner. So we lead one of the largest organizations in cloud, about 15,000 employees. And so my job is to make sure he's got, he's on par with the customer engagements. He's meeting up to the employee engagements and demand. I've been at Google for almost 2 years. Prior to that, I spent almost 2 decades at SAP. A fun fact about myself is that I'm an identical twin. So I'm an identical twin, and we're the first generation twins in our family. So I don't know if it's true that it skips a generation or whatever. We'll find out if my kids have twins, and then I can let you know. But I've always grown up as a pair.
Fun. Jackie, I don't know if I can trust being on a call with you anymore. I won't know if it's you or your twin.
I know. I'm telling you, same DNA, same fingerprint.
Different.
Yeah, same.
Awesome. Thank you so much. Alexis.
Well, hello, everybody. I'm about to come on 7 years at Google, all within the Google Cloud go-to-market team, all within the customer engineering organization. And our customer engineers are our technical sales half of our Google Cloud. And what I love about it is that we get to spend every single day working with customers, helping them solve problems using the Google Cloud technology. And it's constant learning, constant collaboration, both internally and with our customers. It's one of the most exciting careers I think you can possibly imagine. A fun fact, I was Always very into math and science as a kid. I was not a sports player, but I have gone hardcore into women's sports. We're about to start our season of the women's soccer team here in the Bay Area, and we're about to kick off our inaugural women's basketball team and season, and I cannot wait.
Amazing. Love that. Thank you so much, Alexis. Samya.
Hello, everyone. I'm Soumya. I lead the commercial office for go-to-market for Google Cloud. And maybe it's not a fun fact yet, but I'm also at a point this week where I'm transitioning teams and I'm moving on to a new role where I will be leading the global deals function for Google Cloud. So now, since we have promised to offer a fun fact, I think the one that I will share is, of course, this is my 10th anniversary at Google, and coincidentally, it's this week, literally, that is the 10th anniversary. In terms of fun fact, really, like, I know we all come from, very strong academic backgrounds, and we are very much focused on like reading a lot of stuff. The fun fact about me is I hate reading. I have like 3 levels of degrees, but then I really hate reading anything, and even not even a comic strip. I really don't like to read. So, but I force myself to read, and now with generative AI, it's much more easier, where it can summarize things for you. So that's my fun fact.
I love that. I appreciate the vulnerability in that fun fact. I feel the same. I fall asleep whenever I read. Just the book's on my face, I'm out. It's nap time. Awesome. Like I said, powerhouse lineup of women. Let's jump into the panel questions. We'll kick things off to try to relate to the crowd a little bit, right? Like I think many people joining us today are probably interested in growing their current career. Maybe they're pivoting to a completely new one or thinking about a mid-career change, right? As the cloud industry continues to evolve, we all professionals, we need to adapt, right? So what skills do you believe are most critical? I probably just said one, adaptability, for the next generation entering the cloud space. And how do you recommend that they develop those skills? Maria, why don't you kick us off with this one?
Perfect. So cloud skills, what do you need? Well, you will hear we need everything. But the good thing about that is I'm pretty sure you already have some of those skills. Let's split them. On one side, we're going to need the technical skills. And this is why we're here, and this is where we want to help you. There are a lot of ways where you can get the technical skills in terms of computing, getting an idea on what it is, networking, architecture, database, data analytics. You don't need to take notes. They are all listed. If you even try to go to Gemini, you will see it. Those are the technical skills you are going to need. But I always say that for any path you are going to take, it is very, very important that you think about the soft skills. When we talk about soft skills, those are the ones that are going to move you from one point to another point and really bring you and making you successful. Think about problem solving. This is all we need all the time. We need to solve problems with all the background and the expertise we are bringing from our lives. It could be on the personal side, it could be on the professional side. Communications. You are going to need to learn how to communicate, better articulate what you are trying to do, and ensure that the other part in the room is completely understanding and listening on what you are doing. And of course, continuous learning. Doesn't matter what you know today, you are going to need to know something else tomorrow. And even if you don't like to read, I'm not going to say anything. You can use all the tools today that are going to help you to be always at the top of all the new technologies and the trends that are coming. So I would say separate technical skills and soft skills. You can work on both and make progress on both, but be ready for the change. We need to be here all the time, present and continuous learning, and ensure that your communication is really, really powerful. What about that, Krista?
I love it. Soft skills. I think it's so true. It's like the one thing sometimes I think we forget about, but it's just as important, I think, as a lot of these technical skills. So thanks for touching on that. Soumya, what's your thoughts?
I completely agree with everything Maria said. And I think one other additional perspective that I would offer is to think cross-functional, right? Oftentimes when you think about something like a cloud technology, things like programming, or like, really the technical skills is what comes to mind. But I'm someone who's actually made the transition myself. I was a software developer when I started my career, but then later I ended up working more closely in consulting, and then from in IT consulting to be more specific. But then from there I moved into doing research work for Google, and then from there I moved into a role much closer to Google Cloud where I do commercial work. So I started working on P&Ls. So you can see the transition that has happened. So when you think about a technical role in a technology firm, it can be wearing multiple different perspectives, and you could be wearing multiple different hats to do that type of work, and all of these are required to make the business operate. And there is no such thing as I'm an engineer, so can I actually do commercial work? Well, I did have that question when I started doing that myself, but very soon I was able to learn and adapt, and now I have a very diverse portfolio of skills that I can bring to the table, and sometimes also think about problems in a different way. So my only recommendation is think cross-functional when you think about expanding your portfolio or your skill set. The second thing is we are at a juncture with AI right now. It presents some unique opportunities. So again, with the opportunities that AI presents, it's not just about looking at it from a purely a technology or technical perspective, but also all the allied things that go with the AI ecosystem. Even so, things such as how do we improve data center technology, like how do we improve security of data centers, or things such as how do we do better cooling for the heat that gets generated out of data center. There's so many other aspects of how cloud works. So I want you to think about it in a much more expansive way than purely around programming or building new products or creating new apps. Of course, that is a big area that we can invest our time and skills on, but think about it in a much more expansive way. That would be my recommendation.
Yeah, I love that. I call people like you, Samya, unicorns. Like you just can wear all these hats. I don't know. I like that term, but thank you so much. Alexis, why don't you close us off on this question? I know you have some good insights here too.
Well, I'm not sure. It's always hard to come last in these questions, but I was thinking a lot about the pace that things are changing, and which model is on top which day for what application. And I was reminded of this moment way decades ago when I was in graduate school. I was studying for a comprehensive exam, and I was trying to cram equations and theorems into my head. And my office mate turned to me. He was a very matter-of-fact individual, and he just said, "I don't understand why you're stressed. F equals ma. You can derive all the laws of physics from that." And he wasn't wrong. However, in a test, that's not really the most useful advice. But the good news is that life is a lot more like studying than it is taking a test. And if you think about it from that perspective, then it really is about making sure that you understand the basics and the fundamentals, because the layers of information that change on top of that are still going to be dependent. And so you can build your knowledge off of that core foundation, right? And so from that perspective, then it's about making sure, what are the basics that I need to understand? Now, I will put in a plug for everybody on the call. We have a Google Cloud Skills Boost, which is available to all of our customers and individuals at our customers for free. So you have an opportunity to go in and learn some of those foundational skills for free. And then, remember that technology is about problem solving, which both Maria and Soumya touched on, right? And so the tools that you're using have the most value when you are applying them to solve a problem. And that is studying, that is collaboration. That life is very rarely a test.
Yeah, absolutely. I agree. And really good call on Skills Boost. Absolutely. For those of you who are joining us today, partners, customers, like Alexis said, you all have access at no cost to Google Cloud Skills Boost. That's where our entire portfolio of on-demand training is. Lots of labs and good stuff. If you don't know how to access it, just get a hold of your Google Cloud rep, and they can let you know who your admin is and get you access to that. Also, we have a lot of other on-demand live instructor-led training as well. Maybe the chat moderators, if you can just throw that link into the chat so that folks can go register for other trainings as well, that would be great. Yeah, I think that's it. So cool. Let's go on to the next question. As an executive overseeing diverse teams, right, your influence really extends beyond your own organization too, right? So what enduring impact do you aspire to create as a leader? Jackie, why don't you kick us off on this one?
Sure, happy to. So first, what I think I want to say that I think anybody can create an impact, whether you're a leader or not. So I just want to put that plug out there that I think anybody can make a big impact. I a little conflicted on this question. What I will say is, one thing that I've managed people for a long time, and one thing that they most remember about me are times when they have been, we'll say, under personal or professional crisis, and we've worked through it together. So as a leader, when I think about that, I think about the times where maybe someone on my team or another team was going through a really challenging moment, and leaning in, rolling up your sleeves to listen to them, to help them. I could think of a couple examples in one hand that truly made a difference in their lives. And it was just because I was there to listen. So whether you're a leader or not a leader, I think that's a quality everybody can leverage and use. And I think it makes a huge impact for people. In terms of one of the things that I tell my teams, because I think it transcends across teams, is you can get into organizations or even, cross many different companies where people might work in a silo. Everybody that knows me or has worked with me knows that I am the opposite of that. One of the things that I always tell my team is overshare. Share. Because when you share with people and you keep everybody aligned and into the same, on the same page that you are, obviously oversharing without giving out confidential information, I think that just wins trust. Transparency, I think, is absolutely key to building trust. And that is something that goes a really, really long way. I think every single time that I've built bridges to try to share and overshare with teams or bring people in, that's only actually multiplied our impact. So I think if I want to be remembered for anything, is that I was collaborative, that I shared, I have this overshare with everybody. And also when things, maybe got rough, that just listening as a manager or in another role might have made someone's day.
Awesome. Thanks so much. Yeah, I love that. I love your approach to just like humanizing the experience, right? Like trust and transparency is so important, and just getting to know someone even.
Yeah. And one thing to add too is one of the mottos that's gone a long way for me also is, like, I always say this to people, is clarity before harmony. I think it's just so much more important to be clear with people and set the right expectations, whether they're on your team, on another team, a customer. I think it's so much more important to be clear versus tell people what they want to hear, right? So clarity, I think you show respect that way. Clarity before harmony. It's never failed.
Absolutely. The ability to have crucial conversations. Important. Yeah. Totally. Awesome. Thank you. Maria, let's get your thoughts.
Okay, so I'm managing a team that, when you are on the sales side of the house, in our case, we are positioning services to ensure that we help our customers to be successful in time and manner. There is always this attitude of, that's impossible. Well, what I'm always focusing on, and this is the impact that I always want to set up in my team, is part of the culture, is the can-do attitude. Yes, we can do it. You need to believe it. It's not going to be easy. It's just going to take a little bit more time than you were expecting. So for me, the culture in the team needs to be, okay, big problem, big challenge, almost impossible, but there is a can-do attitude. The can-do attitude will take you whatever you want to do. That's the first thing. And I have a second one, and it's high performance. I deal really, really bad. And I think in this world where we are competing and when everybody's pretty smart, let me tell you, we need to have high performers. We need to ensure that we are not just, well, it's okay, it's not that good, but it's okay. No, move your standard one level up, and that will help you to move one level up. So when you work with your teams, when I work with my teams, in addition to this can-do attitude, I always focus on, is that good enough? I'm not saying it has to be perfect, but it has to be good. This is a high performance culture that we have implemented in a lot of teams here at Google and in my previous companies. But it's very important that our teams, when they join us and when someone thinks about us, and when any other stakeholder, even the customer, even your colleagues, they think about you, they think about the people that we work with, your teams, you want to ensure they think, oh, those people, they are really high performers, and they have always this attitude that, yes, we can do it. Just let me figure it out. Just let me work with you together as a team and ensure we get where we want to be. And as a team can be even with our customers. So that will create a strong relationship with whoever you want to work. And that will set up, I would say, the impact and the culture that you want to have in your team.
Yeah, I love that. When Maria says can-do attitude, she really means it. Like, she really fosters that. I've had the pleasure of working with Maria closely as we've been in the same org for several years. I think it was just like 2 days ago, you and I were having like we could do this like pep talk about Launchpad and the future of Launchpad. So thank you so much for sharing that. Let's do another kind of similar type of question, but you all, I've said this like a million times, are like powerhouse leaders, right? As exemplified in this conversation and why you're here. What strategies or practices have you found most effective in navigating your personal life, like having a fulfilling personal life while also having a very busy professional life? Alexis, why don't you kick us off on this one?
Sure. And I'll start with a very potentially controversial answer. I don't. I don't expect to maintain balance on a daily or weekly, sometimes even a monthly basis. I expect to create some balance on general timeframes because life is a pendulum. Sometimes work is really intense. Sometimes your personal life is really intense. And in both of those moments, it is okay to not balance, but to focus where it needs to be. And I tend to prioritize focusing where I need my attention to be more than maintaining balance. And that's really important to me. I will say that I also get pretty specific and rigid when I do carve out. So I have moments in time where I spend an awful lot of time every day at the computer, on screen, in meetings. And when I go and say I'm turning off, I turn off. I will turn off my work phone. Sometimes I'll even turn off my personal phone and like go completely screen free, digital free, everything free for a couple of hours. And the biggest thing for me there, and Jackie touched on the importance of sharing and communication, is setting expectations, right? So when I am on, I am on. When I am out, I am out, but I tell people so that they know what to expect. So for me, the most important thing is making sure that people know, whether I'm reachable, and if I am, that I am. And if I'm not, why not, and for how long. And I try to keep a gut check on myself if it's a really intense moment at work and say, okay, I probably need to spend about 6 hours off of the work line for a minute. But for me, I would get stressed if I tried to balance every week. Am I spending so many hours on personal things or work things? So I just try to check in on how I'm doing and make sure I carve out moments where I can put that 100% focus where it needs to be.
Yeah, I love that. All about balance. And I love a good digital detox. Love that. Jackie, I mean, as someone, chief of staff supporting the president, like I assume this has been something that you've really had to hone in on, right? Like this balance. So what would you say to this question?
It's probably a tactical answer, but I am a big stickler for blocking for my calendar. And I'm a mom of two. I also have to run every single day. So without fail, I block my calendar every single day, 7 days a week, to run for 1 hour. Yes, I like to run for an hour outside. I'm in Miami, and that helps me. Like that is my time. And you'll find me on my runs, like I'll be like running and then I'll remember something, or I'll stop, I'll text someone, I'll answer a ping, but it's the way that I think. I think blocking your calendar and being really strict about it is key. Like, you don't move it. You don't move your run if you need it. You don't. Twice a week, I do strength training. It's important for my health. I've gone through some health issues over the last couple of months, and my doctor says I need to strength train twice a week. I try to do it on the weekends. If not, I get one in during the weekday. I block my calendar for that, to do it. Unlike Alexis, I am available by ping. I'll tell you why, because I'm a mom of two. So around 2:45 rolls around, and I am an Uber driver to soccer, to cheer, to cross country, to track. And so what I do is I'm able to get my kids to where they need to be. I'm available by ping. I'm available by cell at any time. And I'm actually pretty honest about it. I just am. I think I could be honest about it because first, my managers have been great. But second of all, I think people know they can count on me. I'm accountable, right? For the people that work with me, I get my stuff done. You get your work done, and then you can live like that. The other thing too, I will add, I coach. I coach 65 kids after school, cross country and track during cross country and track season. And I'm very honest with the team that I manage and my boss that I'm with those kids for an hour every day in the afternoon. And so my work hours look a little bit different. Why? I'm up at 5:36 to take my calls. I'm probably working. I get home from coaching and I'm working till about 8 p.m. But that's because I'm there for my kids in the afternoon. I coach an hour when I need to. So the way that I balance is I've decided I'm going to take those 2 hours in the afternoon to be with my kids. And then at night, I'm going to work after I've done dinner. And that's okay for me. I think you have to stick to what you've blocked for yourself. And you need to know and put those boundaries in place. You're worth it.
Yeah, absolutely. I'm kind of the same with my calendar, although maybe not as much. I should be better about actually taking my gym time when I say I'm going to take my gym time. But I love that. Thanks, Jackie. Maria, let's get your perspective and then we'll move on to the next question.
I'm very sorry, but I'm going to bring a different perspective. Probably some of our people in the audience are going to rely with that. Sometimes we work at companies or in countries or in cultures where it's not that easy to say that I need to be with my kids at 3 p.m. And that was my case. It was not well received and it was not accepted. That for me meant that I had to choose. And I realized that you can have it all, but not at the same time. And for me, I have two kids as well. Now almost the second one going to college. The first one is already there. But at one point in my life, I couldn't do it all. And I couldn't focus on my professional career because I wanted, and I decided I want to spend time with my kids. I want to be part of their life when they are growing. And I just dreamt at that moment, that was my dream, and this is what I'm doing. At one point when they need me less, I will focus on my professional career a little bit more. And it worked. I never put my career on the side. I was always there. I was able to keep it. But to be honest, I want to focus on my kids. My career progression was, let's call it almost flat. You are who you are. You can decide you are a high performer and you will be always a high performer. But that means that you are a high performer on the time you have. But if you want to be with your kids, you need to be with your kids. Or you want to be with your family, or you want to be with whoever you decide is the right thing for you to do. So my takeaway has been always, you can have it all, but not at the same time. And it's okay. I love what Alexis said. I need balance for my life. I cannot have balance in every single minute. I have balance as a life. And what I really, really want is when I look back, I can say, I did what I wanted to do. And that balance is okay for me. And probably I don't become, I don't know, on my professional life, but I had balance and I'm happy. So make your decisions based on what you want to do, and have it all, but not at the same time.
Yeah, I love that. Yeah, I think the general theme here is balance, right? And like maybe it's not going to be all in a week or all in a month. It's just overall, is there some balance? And I love Jackie's point too on just like taking care of yourself too, right? Like get that run in, because maybe there's mornings if Jackie didn't get her run in, she wouldn't be at her peak performance that day, right? It's so important. If that's what kind of gives you your peak performance, taking care of yourself is really important. Awesome. Thank you so much. That's my favorite question. I feel like it's so relatable. I think we all struggle with like this balance. So thank you so much, truly, for sharing your insights. Okay, let's pivot a little bit. So as we all know, Launchpad was really created, like the heart and soul of it is to boost representation of underrepresented groups, particularly in the tech industry, right? So how do you navigate situations where maybe, you're the only person in the room with a different background, or you just somebody in the room with a different perspective? And how do you use that to, position yourself to create positive change, right? Alexis, let's hear from you on this particular question.
I think a lot of this for me is it again comes back to that core anchor of we're solving problems with technology, right? And the problems that we're solving are going to apply to a broad swath of the population, right? And so the perspectives that you need to represent the people who are going to partake of the solution. And as a result, that's why people do user studies. That's why you bring diversity into the process as much as possible. And that's diversity of all sorts of experience, of skills, of perspective. And that's really where it comes down to. And so I think the most important thing is to remember and help everybody throughout the process recognize like why that variety of opinions is so important. And it's because it increases the value of the solution that you're going to be providing. And so to me, the best thing that you can do is really anchor on that solutioning process and who is the solution for. And that is what really amplifies the need for a particular perspective or a variety of perspectives to be present and vocal in any decision-making process. And so to me, has always come back to you want to have more different types of opinions in a room. You want to hear conflicting thoughts and ideas, because that's going to give you the most applicable and most valuable solution at the end of the day. And that's really what it all comes down to.
Yeah, absolutely. I love that. Maria, what do you think?
I'm pretty sure a lot of people that are listening to us really see themselves in this situation, being the only one, and only can be the different one, and different can be anything. You can be the different one because you are the only one that have an accent. You are the only one because for your gender, or you are the only one because you are new to the team. So the difference can be anything. And I would say three things. The first one, be confident. You are in the room because you are in the room and you earn the right to be in the room. If not, you wouldn't be in the room. Okay, be confident, leverage your unique perspective, speak up when you think you speak up, and don't feel like, well, I don't know if I should be here. You are there, be confident. There is a reason why you are there, and share and leverage your unique perspective. Second, be patient. We are not going to change everything all the time. And being the different one and being the unique one is something that is going to take a while. And if you demonstrate your value, how it's really worth it to have you in this room, they are going to call you again, and they are going to bring more people like you, and you are going to bring more people like you. So be patient and demonstrate your value. And the third one that for me is very, very important, be authentic, be you. Don't try to be anyone else. Be you. You are there because it's you. So be you, show that you can provide this value that I was talking about. And at that moment, you will get allies, and they will like what you do, what you say, your value, your contribution, but be authentic. When we are us, when you are you, this is the unique thing that is going to bring to the table. And we need all kind, one of each kind in the groups to ensure that we represent the whole world. So confident, but question yourself, you are there. Patient, Things aren't going to change in 1 second. Be comfortable to be different and unique. And 3, be authentic. Be you.
Yeah, authenticity. I think that's like a theme of this event too, like be authentic. And like to your point, no two people are the same. Unless you're Jackie and you have an identical twin, then fine. But other than that, like no two people are the same. And so having different perspectives is just so critical. We all think so differently, and there's so much value in that. So yeah, thank you, Maria, for that. Okay, so let's focus a little bit on challenges, right? So I think we've all had a challenge. We had one this morning. Our script for the morning disappeared from Google Docs, and we had to figure out where it went and how to get it back. So that was fun, and the way that we handled that determined the next step, right? The success of that challenge. So could you share a bit to your approach on facing challenges or roadblocks? This can be your personal life or your career, anything that you could share. Jackie, let's hear from you on this one.
Well, first of all, by the way, Thomas Kurian, our CEO, is also an identical twin. So both Thomas and myself, we are, there's two people like us out there. All right. In terms of challenges, I don't think I'm going to share anything earth-shattering here. For me, it's always been your village, your people. Like, never do anything alone. There's a challenge. All right, okay, who do I need to pull in? It's literally that simple. I know it's complicated because you got to pull in the right people, but for me, it's always been around who you pull in from your network, professionally, and even personally, right? I'm Cuban, and so I come from a Cuban family, so that definitely means that my mom's involved and someone in my family's involved, if it's a personal issue. But I would say is pulling in the right people around you to just help think it through, determine the next steps, and especially with challenges, not being too hasty, but making sure that you are making timely decisions. I think timing is key for challenges, both professionally and personally. I spent a lot of my career doing crisis communications. And I can tell you, people and timing were probably the biggest factors to ensuring whether we came out of this crisis or we were successful or not. So nothing earth-shattering there. I'm about my village. I'm about the people that you pull in to help you overcome it.
Yeah, it takes a village. I love that. Super important. And goes back, somebody made a point earlier too on like silos. I think it was you actually who made a point on like not working in a silo. So it kind of goes along with that theme. Soumya, I feel like we haven't heard from you. I'm so sorry. I guess we had a bunch of questions that weren't for you initially, but please let's hear from you on this question.
Sure. So I think challenges, it really depends on how you frame it. Like something could be an opportunity rather than a challenge. So I would really encourage everyone to think about like when you're presented with a unique situation, which could be challenging, think about the other opportunities that it opens up, right? Like in my own personal, both personal and professional life, there have been many of these moments where I wanted to do something else. And then you're at a crossroads moment. And there is a challenge associated with all of these. And to the extent you're able to convert that challenge into an opportunity, then it becomes exciting and interesting. And then you want to take on to do and try something and experiment with it. Like as an example, I think throughout my career, I have done a lot of experiments with my career and making decisions, which in somebody's eyes could be suboptimal. When I first started, I started as a software developer. And then within a few years, I started realizing I was more interested in business development and also to move more closer to the business side and not just only focus on code creation. So one of the ways I wanted to like equip myself with that was to go get an MBA. I just had engineering background and had technical training, but I thought it was important that I go through a formal, MBA program to be able to get to that stage. So that meant I had to make this decision of quitting my job and take a much more serious back to school, decision. It was a very challenging decision. And after 5 years of working, it's really hard to go back to school. I also had a very young child at the time. So it was a challenging decision, but then the excitement around the opportunities that this decision might open up made me choose that option. So I did follow my instinct in that situation. So that's one recommendation again that I would have. Oftentimes there is no such thing as a bad decision. As long as you're decisive, and feel comfortable with the decision, we should move on and experiment what happens. Again, a very similar moment arose, and after I finished my MBA, I went on to do IT consulting work. It was a fantastic opportunity. I could travel across the globe, meet with many Fortune 500 execs to be able to help them with their IT transformation journey. I was very content in my job, but then at some point there was this curiosity or learning aspect that I was missing. It felt like I was doing a cookie cutter type of situation. Again, someone wouldn't frame it as a challenge really, but I was feeling it within myself. I do feel like there is a sort of a repetitive type of nature to the job that I was doing. So I wanted to get out of that, and I was wondering what is it that I wanted to do. And I was very curious and wanted to learn more and go deep into a specific problem. So that meant I could do research, but then I didn't have formal training in research. So I had to quit my job again and went on to take a PhD program. It was very risky because, as you know, we don't get paid. I get a very, very small per diem. And you had to let go of a high paying consulting job without knowing the prospects of where you will land after your PhD program. And sometimes these could take several years for you to finish. So it was a big risk that I was taking upon, but the sheer factor of the fact that I'm going to pursue something that's going to be exciting and interesting for me helped me make that decision. And then after that, I ended up working at Google, and I had the opportunity to lead a research team here when I first started. So there have been many of these ups and downs and pivotal moments when it was important to choose something that you're going to enjoy and feel excited about, rather than looking at it from a purely the trade-offs of what you're going to lose by not making that decision. Also look at the upside of making the other decision. So anytime you're bombarded with the challenge, I would say look at the opportunity perspective and also follow your instinct.
Soumya, for someone who doesn't like to read, I am beyond impressed by your academic career. Like, that is pretty incredible. And I love what you said about there's no bad decision. I think sometimes we all get in our head and we get afraid to take risks, thinking that we're making the wrong decision. But at the end of the day, every decision leads us to the next decision and the next decision and the next decision. And so I appreciate that. Okay. Let's conclude with a final question that's sort of just more open-ended, but I'd love to hear from everybody on this one. So what is the best piece of advice that you've ever received? This can be professional, this can be personal, this can be advice you gave yourself, doesn't matter, but the best piece of advice you've ever received. Jackie.
Okay, that's a really tough thing. So I can't say the best that I've ever received. So I'm just going to say the best I got this week. All right. And it was my boss, actually, Matt Renner. He leads global revenue for Google Cloud. And he said, it is not true that nice guys finish last. And that he says that has, I mean, he's in an incredible position. He's had a really great career. That's how he always operates. He's not, and he deals with customer escalations, and of course he manages a lot of folks and under a lot of and deals with obviously manages our customer relationships here at Google. And for him, it's all about relationships. So nice guys do not finish. Nice guys and gals, we'll say, do not finish last. I thought that was really great. He said it to a group of people, including myself, and it says it served him well.
Very interesting. Thank you for sharing that. Soumya, what do you think?
I'm going to take the liberty of sharing two pieces of things that I learned from two different people. One, this is actually coming from my research mentor, and this is about work ethic, right? So in summary, basically have zero tolerance for mediocrity. So whatever you do can't be mediocre, right? So that really resonates with me. And irrespective of what the situation warrants, you could do sometimes things to just keep things going. I really try to go, sometimes even get feedback, okay, you're gold plating this right now, but can't settle for mediocrity. That's the work ethic I associate myself with, and I really advise everyone else to pursue that. And that is where you set a really high bar. The second piece of advice is more around career, and this is something I received from my first hiring manager at Google. She's also the head of responsible AI. This was about forget a mentor. I know we all care about having mentorship, which is important, but she introduced me to this concept of getting a sponsor. right? And I did start the whole session by saying I don't read books. So she gave me a book to read about it, ironically. And I will mention the name of the book, and it's meant to be great. I have read the first chapter, just out of respect. So this is a book by title Forget a Mentor, Get a Sponsor by Sylvia Ann. We can also share it after the session for those interested. Just after reading the first page, I understood where it was going. And this is something that has really helped me with my career. Like, mentors are great, and I take a lot of advantage from our mentors and get their support and input. But then having a sponsor who can speak for you in a situation where you're not around and recommend you or suggest and your skills is super important for us as you go through your careers and as you're aspiring to grow.
Yeah, absolutely. I completely agree. I think having a mentor is super important. Alexis, what do you think?
I think the thing that has been the most impactful for me in my trajectory, which has been a lot of different types of roles and landed me where I really feel like I fit best, was talking to a sponsor and mentor and friend right after I made kind of my first jump, right? So my intention was to be an academic. I wanted to be a college professor. I wanted to do deep academic research. And
You like to read?
I did like to read. I spent most of my time, I was doing physics and astronomy. And I spent 7 years in grad school and don't have my PhD. And in my first job felt like I was starting from ground zero. I felt like I had no relevant skills. And this mentor sat me down and said, you're not thinking about it correctly. Here's like the skills that you had in your prior role. You're teaching college, and here's the communication skills that you had as a part of that, and managing research projects, and here's the skills, and here's how that translates. And so I think every time I'm talking to myself about different roles, or I'm talking to people in my organization about their own careers, we get really laser focused on how our current skills apply to our current role and what that means for what the next level or role needs to look like, instead of stepping back and thinking, really, how do these skills translate a lot more generally? Because that opens up a wide swath of potential career moves that could be really interesting, challenging in new and exciting ways, more lucrative, open up geographic moves, open up all sorts of possibilities that we're not thinking about if we're just thinking about what I'm doing now and how it applies to my current job title. And that's one of the best pieces. I'm really glad that I got that advice in my 20s instead of a decade later, because it means that I thought about a lot of different opportunities from a perspective of I can do this because my skills translate, as opposed to I can't because I've never done it before. And that to me has been the most impactful thing anyone has ever said.
I love that. I completely agree. Transferable skills. I think any good leader can see what I like to call them the unicorns, right? Who have this like variety of skills. And really a lot of these they're transferable, right? So yeah, I love that, Alexis. Thank you. Maria, what is the best piece of advice you've ever received?
Be ready, team. I fully agree with, I love your advice, Jackie, the one you share. Same with you, Soumya and Alexis. But I think there is one that you need to keep always in mind that I got when I was very young. Have fun. Have fun on what you do. This is not going to be easy. You're going to have times where you are going to ask, what I'm doing here, I don't like what I do. You need to wake up every morning and go to work and do your job, high performance, can-do attitude, no mediocrity, excellent. How can you do always that? By having fun. And let me tell you something. When you show people, when people can read in you that you're having fun, they are going to be willing to work with you all the time, because people need to have fun working. So you need to spread that. When you need to show that, reflect that in your daily basis, that if you have fun, things are going to come, you are going to work hard, you are going to do everything you have to do. But please have fun. This is for a long time. You are not working for 1 hour, for 5 hours. You are working every day, every week, every month, every year. Have fun. Have fun, and people will join you, and together you can accomplish the impossible. So That is my advice. Probably it's not the most academic one, but I can tell you, when they told me that, I was very, very young. This is my principle in my life. So let's do it.
Yeah, it's so true. It's so true. I think have fun is that's a good piece of advice. I'm going to try to remember that one. I think it's really important. Thank you so much. Honestly, we super appreciate you being here, your advice, your vulnerability. I know that I wish I could see like the chat going off on the live stream right now, because I'm sure it's being flooded with emojis and thank yous and kudos. So seriously, this was really inspirational. We appreciate you being here. We cannot thank you enough. And I'm going to hand it back over to Kate to kick off the next session.
Wow. Woo! That was incredible. Spectacular. Yeah, exactly. A little bit of woo. I would say spectacular. Yeah, virtual standing ovation is really necessary. That was so inspiring. Just enormous thank you to Krista for such excellent moderation, and to all 4 panelists, the amazing Maria, Jackie, Soumya, and Alexis. Really just so well done. I bet every single person today took away some inspiring nugget. Especially, I would say thank you all for sharing such real and authentic stories and being true role models and examples for all of us. I took a ton of notes, and I'm just going to shout out a few things that I heard because they were incredible. Thinking expansively. Life is more like studying than taking a test. Isn't that true? So understand the basics. Also, don't forget that you can create an impact whether you're a leader or not, and lean into those challenging moments. Clarity before harmony. Can-do attitude, and how important that is for everybody and the team. That the pendulum can swing. It's okay not to be in balance all the time, but focus where you need to at that time. And boundaries. Gosh, the importance of like setting those up, turning off things when you need to. Whew, having it all, but not at the same time. What a true statement for so many of us. The idea of that a variety of opinions increases the value of the solution. Reframing challenges to be opportunities. I love that one. That is so true. Pursuing what is exciting and interesting to you and following your own instinct around that. And finally, the advice. Not true that nice guys and gals last. The idea of work ethic, how important that is to have zero tolerance for mediocrity. Wow. Get a sponsor, not just a mentor. Don't forget about translatable and transferable skills. And finally, have fun. All right, that was my 1 or 2 minute summary. I just had to throw those out there. Just so many great nuggets. Thank you. Maybe 1 or 2 last things, and then I'll turn it back over to the fantastic Charlene. So I know there were many more questions in the chat coming up during the discussion. So here's what I'd encourage you to do. Join that optional LinkedIn community and ask and answer those questions together with each other. Post your perspectives and share with each other. That is how we're all going to help each other through our own journey. Okay, what I'd love to do now is have everyone take a moment to take a very brief survey. So Carolyn, if you can cue up that slide, we would truly love to get your feedback on this Launchpad for Women training event and journey. This will take 1 to 2 minutes. I promise it's very quick. But we truly value, we look at every single one of these surveys to understand what's working well and what we can improve going forward. So please just take that brief survey if you wouldn't mind. We'd really appreciate it. All right, now we're going to take a quick 5-minute bio break because we've all been sitting here listening to this incredible panel. And we're going to come back to start the final section of our Cloud Digital Leader training for day 2. So let's come back at 1:10 p.m. Central Time. So I'll give you 6 minutes, and then Charlene will take us away to do the final section. Thank you. See you in a few.
Hey, welcome back. What a great panel. Just like Kate, I was here taking notes furiously. So good. I love the be yourself part. I had to learn that over time. Just as a little side note, I'm not your typical, we've seen me. I'm not the typical girl that comes and works and does everything. No, but let me tell you what, when you lean into who you are, so many doors open and they're like, just, yeah, more of that. And you're like, what? Definitely do that part. That was my favorite part, but I loved it all. Okay, back to work we go. Let's talk about Google's trusted infrastructure. Again, I was telling you how Google has these layers. Let's discuss. Now, the first layer at the bottom of this little multi-layered approach to security involves the data centers. Of course, that's the first thing you're going to lock down, right? The data centers, the physical location of the infrastructure that we rely on when we use cloud services. So, of course, that is the most important. And what's running on top of that? What is stacked on top of that very secure design? Those data centers, let me tell you, you have more than just facilities that are filled with computers. This is not just a building that just has computers. It actually is the backbone, the round-the-clock operations center for all of the other things. Without that, the rest of that stack doesn't exist. So what's going on inside the data center? So they say here, over 30 state-of-the-art data centers worldwide. I think the number is now at like 40 something. And so the idea is that they have these advanced securities that, or these advanced facilities that enable a secure, reliable, top-notch set of capability. This is what we want. We don't just pick a data center that, okay, I'll just pick a cloud provider that's kind of reliable. No, you want, like Google, who builds their servers with a purpose in mind. They call these purpose-built servers. Remember what I was telling you about if you know that your services are going to be supporting multiple virtual machines, then you're going to create physical servers that are tuned toward that approach. They're actually geared to do that one thing, and they do it very well. With this, we're talking about committing to a certain approach to service that is not trying to be all things to all people. You're narrowing your approach, servers that are built for particular purposes and used in that case. And then it's not enough just to have a server that works nicely. How about the fact that it needs to connect carefully to all of the rest of the servers in the network, and to keep secure both that hardware and that software and that network layer. They created their own security hardware and software. So that's kind of neat. Their purpose-built servers are homegrown, home-built. In other words, they don't just get on one of those websites and order a server. Just send us a few servers, please. We'll just take them as is and stand them up in our data center. No, they're building it from scratch. Every single piece that they put on the server is trusted because it's all coming from in-house, right? And that's pretty neat because this architecture says, because the point of this architecture is that it's zero trust. We don't trust this server that just got shipped from overseas and just gonna stand it up in our data center. No. In fact, they built their own hardware, right? They put it together, and when they put those computers on the network, it doesn't even boot up unless it boots up securely, where the boot up process can tell, has this machine been tampered with? Is it exactly the same as it was when we turned it off? Like before, let's say a machine gets shut down and turned back on. There's something we keep on a little place that it keeps track of things. I don't know the details. I'm not supposed to know probably, but it can tell if someone introduced just a few bits or bytes of information since it was last turned on. Hello? No, we're not booting it up. In fact, I was reading somewhere, I love watching some of the Google videos. I'm going to show you one in a minute that's about something very, very wonderful. But well, I was watching something and it was like, if this server boots up and it does not have the right checksum, then it gets quarantined, set aside, and does not continue to boot onto the network, because what we're not going to do is allow this suspect software, hardware to come online and then crawl to all the other computers. That's what we're not doing. So secure boot. If it doesn't pass the test, it doesn't get onto our network, says Google. In addition to software encryption, which I mentioned before, has to do with large prime numbers. Take two very hard to guess prime numbers that are, I don't know, 50, 60 numbers deep, multiply them together, that's your key. That's a software key. What if you encrypted your data using part of the hardware that the data is on? That's also available in Google Cloud. So technically, if somebody took a hard drive out and smuggled it out, I don't know how they would do it, but if that happened and they took it somewhere else and tried to run it, it would be like, we're encrypted and we don't recognize this place. So no, we're not going to boot up. We're a hard drive that can't be read. It's now a brick. Congratulations, you have a nice little paperweight. These are the things that Google does to make sure that there are layers of security. And of course, you can dive deeply into any one of those in your spare time. But what are we talking about? Physical security. The physical security is important, and that's what Google data centers are in charge of. So this whole chapter is all about how does the Google Cloud provider enable security and trust. Now, if you're talking physical, you're talking about the ability to get into the building. And so I'm going to show you in a couple of slides my favorite video from my favorite, well, I guess I'm just a fan of Stephanie. You'll meet her in a minute. She's going to take us through a data center. But you'll notice too, there are several levels of security in terms of, do we badge in? Are we allowed to hold the door for each other? Are there cameras? Are there any sort of a few barriers of just walking in? Oh my gosh, so many layers of security. And with this, you will, because Google has the ability to protect their physical hardware, they're also very cyber resilient. That's one of their core tenets of their data centers. And their data centers are equipped to be able to handle and recover from cyber incidents. But don't just hear it from me. Let's now take you to the video, 6 Layers of Security, brought to you by Stephanie from Google Cloud. So let me get ready to show it.
Hi, I'm Stephanie Wong, and I work for Google Cloud. While I could talk all day about cloud security, physical security at a Google data center is still pretty new to me. So today, I'm on a mission to learn all about it by taking an inside look at the systems in place that protect customer data at a typical Google data center. Let's go. Now, I've been told there are 6 layers of security here. Security layer 1 refers to the property boundaries, and that includes signage and fencing. But things really start to get interesting when it comes to layer 2, also known as the secure perimeter. And that includes the main entrance gate, which I am pulling up to right now. Hey, how's it going?
Good morning.
So layer 2 has a lot of security features, ranging from smart fencing to overlapping cameras to 24/7 guard patrols and more. I'm on my way to meet some experts who are going to show me how it all works. Hi, Joe.
Hi, Stephanie. How are you?
So I just passed the main gate and I saw guards and cameras, but what are some things that I didn't see?
Yeah, there's actually a lot of technology and operations going on behind the scene. So from the time that you're on site, we know that you're here and we're able to do correlation analysis of where you've been. We have guards in vehicles. We have some guards on foot. There's also the vehicle crash barrier. That's designed to stop a fully loaded truck from crashing through the front entrance.
Ricky, Tariq, can you tell me more about what's unique about the fencing?
This particular fence is an anti-climb fence. It's also equipped with fiber. The technology tells us if someone's near the fence or touches the fence.
So we use thermal cameras and standard cameras, so we're able to see video footage at night just as clearly as we can during the day.
Welcome to Layer 3, Building Access. But just so you know, I am still nowhere near the data center floor. That's a few more layers deep. Let's head inside.
Stephanie, so you've gotten through the gate, you've come into our secure lobby. You have your card, and we know that that's you, but if someone happened to lose their card, what we want to make sure is that it's actually Stephanie who's shown up.
Place into your eyes.
And with iris scan, we can authenticate that it's actually you along with your ID.
All right, I think it's good. One thing that's a little hard to get used to when you visit a data center is for secure areas, only one person is allowed to batch through a door at a time. Layer 4 includes the Security Operations Center, or SOC, a hive of activity that is monitoring the data center 24/7, 365 days a year.
So it sounds like we've been keeping them very busy today.
Yes, you have. So the doors, the cameras, the badge readers, the iris scan, everything is connected here. This is the brains of the security system. So if there's anything out of the ordinary happening, they have to be able to pick that up.
Interesting fact about Layer 5, the data center floor. Less than 1% of Googlers ever get to set foot in here. So right now, I'm feeling kind of special.
This is truly a as-needed only access area, meaning that only the technicians and engineers that have to be there to maintain, upgrade, or repair the equipment are ever allowed there.
And do Googlers or anyone have access to the data?
We have access to the devices, but the data at rest is encrypted, and our customers can issue and keep their own encryption keys. And we do this because protecting the privacy and the security of our users' data is our highest priority.
The mysterious Layer 6, where disks are erased and destroyed, and the fewest number of people are allowed to enter. Drives that need to be retired from the data center floor come into this room through a secure two-way locker system, which means that only technicians assigned to this room can pull them from that locker to either erase or destroy them.
All right, welcome to the Crusher Room.
Wow.
So at this point, we have scanned the hard drive and the software has told us that we need to destroy it.
Can we see it in action?
Back up.
All right, I'll stay back here.
That disk is definitely destroyed.
Yes,
it is. If you didn't think these 6 layers of security were enough, Google Cloud actually has 2 security testing programs in place. One hires companies to try to break into data center sites from the outside, and the other tasks Googlers with trying to break security protocols from the inside. And getting out of a data center is arguably even harder than getting in, as everybody has to go through full metal detection each time they leave the data center floor. Google Cloud supports compliance with over 40 global standards, regulations, and certifications. And the commitment to constantly test, optimize, and improve systems makes it a leader in data center security. Now, how do I get out of here?
That was fun. Uh-oh. I overclosed. Hold on a sec. That's the Kubernetes one. I already did that. Okay. What a video. Am I right? I love that video with Stephanie. I tell you, if I see her at the Google Next, have you guys heard about the conference that's coming up? I'll be like, Stephanie, and she's going to be like, oh my God, who's this lady? Who's this lady? Why is she so familiar? I'm just a fangirl of your show. Love it. So that's what I will do. I'll try not to terrify that woman. Okay, so here we are. We're back. I had to get to the right slide again. And here we are. We're going to discuss a little bit more about the security inside Google Cloud. So I hope you enjoyed that as much as I did. All right. Great. Here we are. Secure storage. Let's discuss encryption. Encryption, as you know, will take data or content that's easily readable in regular text and will make it hard to read if you don't have the key. You can't read it if you don't have the key. Now, we do this to protect our data. Google does this automatically for all of your data. Let's discuss all the different layers of encryption. But just to remind you, encryption will protect your data from unauthorized people looking at it. It'll protect your data from loss, because if you have loss, even damage, what you're talking about is without the right key, no one can steal it, tamper with it, or even understand what the information is inside. So you're keeping it safe and protected. So how does it work? Let's discuss the different types of data. We have data at rest. Data at rest is data that is stored on physical devices, like on a computer disk or on a server, an array of disks on a server. Which means that even if someone gains access to your hard drive, to your computer, they cannot decipher the data without the encryption key, which is used to decrypt. So that's good. That's a great thing, right? Okay, happy. Are you happy? You got a copy of my hard drive. Let's look at your face now. Huh. It was so sad you can't read it. Good. That's a bad guy, remember. Now, Google will also automatically encrypt all your data, even if you think that you don't want it to be encrypted. There is no such thing as optional. Non-optional, it will be encrypted. It's built in, so it's automatic. And if you were to ask Google, please don't encrypt this, just store it in plain text, Google would say, I don't even know how to do that. If you would like such things, please go to Amazon, where you can opt out. You have to opt in. These are the things that you can do in other clouds. We don't not encrypt. It's just a matter of how do we encrypt. Now, if your concern is that you don't want Google to encrypt it using their automated keys, which they rotate, maybe what you've decided is that you want to encrypt the keys yourself. So you're going to be using Google's Cloud Key Management service to generate or to rotate the keys yourself. And there's two types of, just as a little point, you can have customer managed encryption keys, where you decide the period in which you want the keys to be rotated, but the keys themselves are stored in Google's key repository. But if even that is not good, even if you've decided, I don't want Google to have a copy of my keys, I don't want to store my keys in Google Cloud, fine. Then you do customer supplied encryption key. So this manage means you're going to put them in Google Cloud and you're going to manage the rotation yourself. Customer supplied encryption keys, you're going to generate the key yourself, create a key yourself, encrypt your data with this key, and then rotate it yourself at a given time, which means that never in this scenario is a copy of this key stored with your data in Google Cloud or stored anywhere in Google Cloud. The point is, you got to keep track of your key. Did you hear the hopeful yet terrifying news in that sentence? You've got to keep track of your key. Dude, there are people right now who wish they remembered the key to their Bitcoin because they mined it back in 2012 and now it's worth $1 million. And they're like, I wish I knew where the key was. Are we really going to keep track of our own keys? I mean, you do you, but I know me. I'll probably lose them. So I'm going to go ahead and let Google manage. I mean, I can manage the Google key, but the keys themselves stay in a separate vault in Google Cloud. That's me, because I'll probably lose them. Now, having said that, if you do lose your key and you're doing customer supplied encryption key, this is the risky one. If you go to Google and say, hey, I'm using customer supplied encryption key, I lost the key. Can you see my data? Can you get it? Google's like, no, you said you got this. I don't know how to read it. So this is why I'm like, oh, you do it. Now, let's talk about encryption of data in transit. We discussed this is where the pigeon had the little letter and the letter had a little lock. That's what we're talking about. In transit means it's moving over the internet. Now, normally, if you have ever remember the past, I guess 10 years, we all knew to check for HTTPS. That meant that the content moving over the network was encrypted because that shields your data from prying eyes who want to take a look at all the stuff that you're sending. So that's, of course, encryption of data in transit. We know HTTPS is one of the protocols, the S standing for secure protocol. But did you know that when you've got some data that's being processed on a computer in the memory, so in RAM, random access memory, a process typically reads the data from the hard drive, pulls it up in memory, and processes it. If somebody were to grab a peek at the content in RAM, usually that data is not encrypted, which can lead to possible leakage. If your RAM had perfectly readable data and then it had a crash or something, buffer overflow, memory overflow, and then the data gets copied somewhere to disks, and then prying eyes could look, they could actually read what's going on in memory. It's one of the last little holes in the whole data encryption program scenario. So what Google offers is the ability to lock or encrypt the memory too. So now the memory is not readable. The RAM looks like, I don't know. So you have layers. It gets into your network encrypted. It lands and stored on a disk encrypted. When it's read from the disk and put in memory, also encrypted. So now what? Okay, so as far as encryption, what we're using as an algorithm is just in line with the rest of the world. Advanced Encryption Standard, AES. That's the center stage. This is what we use. This is what governments and businesses and banking worldwide, we use this standard. And that's top. That's the best in class so far. So when your data is at rest, when it's traveling, when it's in use, that standard is being used to encrypt the data. So of course, Google takes encryption seriously, and with the implementation of AES throughout, then it's just as good as any other system that's encrypted with this, including banking and government systems. Now, let's talk about who are you? Because the thing about keeping things safe, keeping your cloud resources private and only visible to those who you've deemed worthy of looking at it, let's talk about who are these people? It's called identity. So there's 3 A's when we talk about who. Who are these people? It starts with authentication. That's the first question you have to ask. Who are you? Now, the way that you prove to a machine that you are who you are is going to involve, the 3-factor, multi-factor authentication. You just have to prove you are who you say you are. That's just the first piece. Once we believe you, all right, you are Joe. Hi, Joe. What are you allowed to do now that you're in? That's the second question. And many people think that that's it. There are many courses that are taught. You have authentication and authorization. But a lot of people leave out that third A. The third one is to watch them. Watch these people. Audit the logs. This is where I could jump into stories about how people buy a nanny cam because they're going to watch the new nanny, and they set it up in the wherever, and then they turn it on, and for the first week they review the tapes religiously every day after work. I don't have to finish the story, but let's just let it be known. Keep reviewing the tapes. That's all I'm going to say. I've said enough scary things earlier today. You get the idea. So what we're doing, we're making sure that people have secure access to only the things that they should have access to, and we're just going to confirm. We're going to trust you, and we're going to verify that you behaved right. Trust but verify. That's what we do. So now let's look in detail. Authentication. That's where people are who they said they are. And how do you know they are who they say they are? Easy. You're going to ask for 2 forms of who are you. And any 2 of these should be good enough. One thing is something you know, plus something you are, or something you have. Any 2 of these should be fine. Something you are is a biometric thing, your iris scan or your fingerprint. Did that twin say that they have the same fingerprints? I didn't know they have the same fingerprints. That's kind of terrifying. But yeah, I guess that's a thing. Who you are in terms of your biometrics. What you know in terms of passwords. Now, let's be clear, we're all going to use a password program. It's going to know for us what kind of weirdly formed password's going to be used right now. And then physical tokens. What do you have? Now, physical tokens, I love these. We recently got these laptops here because we're going to be working with this organization that says that they have high security. They sent us a little YubiKey, a little tiny key. It looks like that. You stick it in the thumb drive, stick it right in the USB. Now, you log in with your password, right? And then it's like, touch the key, touch it. And I'm like, why should I touch the key? And it turns out because AI is getting so good, they could come up with an AI Charlene that's all electronic. That AI Charlene cannot reach into the 3D world and touch a key. So that's why they think it's secure. And I'm like, okay, until we get robots, now what? Well, I guess we're going to have to check for biological features. I don't know. We'll figure it out when we get there, probably, says YubiKey. So, but for now, the AI that's running on a machine cannot reach out and boop, touch the thing. So cool, it's a physical token. And you have to touch it. This little thing is a touchable area on the key. I was like, okay, foiled again, AI. We'll see you in another week. It moves fast. Okay, that's enough of that. Authorization. Now that you're in the room, now that you're in the building, what are you allowed to do? Are you an admin? Or are you a regular user? And the things you can do based on your role, that will be determined, right? If you're an admin, you can do a lot of things. You can create other users and you can remove other users. If you're not an admin, then you can just see a list of users as an example. Of course, the list of things you can do will vary depending on your job role. And don't forget to check the logs. People are gonna people. You know what I'm saying? They're gonna do things. At least they're gonna try. That's their job to try, and it's our job to stop them. So, auditing is what comes into play. We're gonna use auditing to monitor and track our user activities. Sometimes we're just gonna count how many times did someone try a thing. Now, if you find that someone's trying a thing again and again and again, you got one of 2 things are going on. One, they don't know what they're doing. That's the generous way to say it. Or 2, they're trying something that they shouldn't be doing, and the system so far is catching them. You might want to grab a little cyber forensics something and figure out, do they have any malicious intent going on? Because one of these two things is true. What's going on, Jerry? Shout out to Jerry. Why do we keep doing that? What you trying to do? Now, if you saw the end of Stephanie's talk at the end, she said, as if this type of security isn't enough, Google has 2 programs that they will reward an employee who tries to break it from inside, and they've hired outside firms to try to break in from the outside. So the person, Jerry, might say, oh, I was doing that for you. Eyes start to wander. Yeah, no, I mean, I got those errors, but I was part of the insider hack. I was doing the thing? No? I do wonder, how does somebody who tries to crack it from the inside, I feel like you should fill out a form ahead of time. Like, if something happens to me, this note proves that I was trying to do it from the inside. How do you tell them I'm really not a bad actor? I was just seeing if I could break it for you. For you. And you just hope they believe it? I don't know. I've just come up with stories because that's my job. But think about it and plan. Now, let's talk about these users. You've heard the term IAM. I'll talk more about this in the next section, but it's identity and access management. Identity and access management. So, the IAM means I can control in a granular manner what kind of privileges people have. So that's it. I can control it. Now, how does it work? You've seen permissions before. Usually you take a set of permissions and you give them a role. You make a role reflect a job description. A job description, like if you are a systems administrator, you should be able to do these things. And then you grant the roles to the users. That's the best way to do it. If you hire a team of people, it should be easy. Give them the roles they need to do their job. And when you let go of some of the people, take away the user from the role. You don't have to reimagine what a job role is. Just remove them from the pre-existing role. That's the best way to do it. And so, monitor your security position by auditing the user's activities. This is what you do. This is the way. All right. Now, network security in a nutshell. Here's how that works. Network security. Now, here are some strategies that you might take to secure your organization's network. Now, we have already discussed Google Cloud itself. The regional data centers are secure. But you're going to put your organization, you're going to put some networks to support your job, to support your software. What should you do when you put your resources in Google Cloud? 1, embrace the power of a zero trust network. And I'll talk about what exactly that means on that next slide. A second thing you'll do, make sure that your connections are secure between your company and your cloud provider. Whether you're multi-cloud or single cloud, make sure those connections are secure. Protect your perimeter. Watch the perimeter of your network to make sure that you don't have any egress. There's no documents being exfiltrated to non-approved destinations. This is leaks. These are WikiLeaks all over again. We don't want that. Let's keep the data within the perimeter. And then definitely stay ahead of all of the issues you might have with an application, a web application firewall, to make sure that only the approved traffic can get in and nothing else. And then you can even check traffic that's leaving. As the traffic leaves your network, you could stop the traffic and say, hold on, where are you going? You're not allowed to go there. And you can control it both directions and then automate it. Automate your provisioning of your infrastructure so that your standards can be replicated just easily enough. So that first thing I mentioned, embrace the power of zero trust networks. That is the basis for this thing that Google offers. It is called Beyond Corp. Don't you love the names of these things? People, especially during COVID, started working beyond the corporate walls, beyond corp. Because think about this. What if you're a legacy practice, you're a legacy organization, you've been everything on premises up until now, which meant that a person would come to work. Once they get to work, their laptop just connects. Because they're in the building, the laptop can do lots of things. What if you want to work without being in the building? Aha! You're beyond the corp, but you should still be able to use logical software network stuff to be able to be seen as still inside the logical corporation. So that's why they offered this. It's used to implement a zero trust security model so that no matter where you are all over the world, each request that comes through the internet to your resources that you have in the cloud, every request will be questioned. Show me your, ma'am, you're going to need to scan your ID. But I was just in here. Every single request, even if you have one system that keeps running multiple requests to that system, every time it's coming through, it will be examined for validity. It will be authenticated each time coming through. That way you have strict control over who can access your network resources, whether they're inside the building, the corporation, or outside working off-site. So we're talking about the ability to expand your net, expand the boundaries. Now, securing connections. We talk about securing connections. A lot of companies have a mix. You got your cloud workloads. You've got your on-prem workloads because you're hybrid. Remember we talked about that. Lots of workloads happening here, plus happening over here. Wait a minute. Hold on. If my compute that's working inside this building connects over the internet to my compute that's working over in the cloud, what about that connection? Yeah, it needs to be absolutely secure end to end. What are you going to use to connect end to end from your desk at your work or at home or whatever? How are you going to connect over there? Typically, people use VPNs. A VPN is sort of a tunnel, isn't it? A virtual private network is a tunnel that is created to secure both ends of a connection. And while the connection is in place, all the traffic travels within that protected tunnel and cannot be, spied on by any other thing that's not inside. So that's one approach, Cloud VPN. However, it can be a bit slow. You're talking about 3 megabits per second. That's not that fast. You might want 100 gigabits per second. If you want that, you'll want Cloud Interconnect. This is way fast. And this is kind of slow, slow-ish. And yes, there are some things in between. And yes, when you come back and take a course that has to do with networks, you'll learn exactly how to configure these two options. But either one of these will allow you to securely connect from on-prem to Google Cloud resources. You're connecting in the private connections using private IP addresses and all that good stuff that we talk about in the network class. But I won't belabor the point, not too much longer. Let's see how firewalls come into play. Now, your perimeter obviously is, I shouldn't say obviously, but your perimeter is defined by every network that's inside your Google Cloud resource. And Google Cloud's network, they call it virtual private cloud. This is their network. So if I were to put a compute instance inside Google Cloud so that I could play with it, and then I put another instance inside Google Cloud in another place, like across the world in another location, then I've got two computers. Maybe one of the computers is on this node in the United States, another computer inside the network, which is a global network. I could put this one over in Jakarta. just to have some fun with the name Jakarta. Okay, I have 2 compute instances. One is here and one is over there. And they are part of the same network, the same one network, because in Google Cloud, your virtual private cloud has as many regional locations as you decide to. You could put your virtual, this is a network with a lot of little subnets. So each one of these things is a subnet. US is a subnetwork that belongs to my big virtual network. And the Jakarta is another subnet. When I create a project in Google Cloud and I want to put a machine, it's going to put it on my virtual private cloud network, which consists of many subnets, and I can sprinkle them all over the world, and they could talk to each other because they're on the same network, using private connections naturally. Of course, I will add a firewall to my virtual private cloud. I will add a firewall to the whole network so that traffic that's coming between these 2 machines, I could set it up so that they allow traffic to see each other, they don't allow it. Do I want the external traffic to come in? I'm setting up a lot of rules. It will apply to the whole network that I create, and then I can put resources inside the network. That's very nice. And then we use this as a secure perimeter, and there's lots of things I can do beyond firewalls to secure that perimeter. There's a lot of powerful tools in Google Cloud. Now, just as a quick comparison, I was working with a student, and the student was taking our class because he was new to Google Cloud, but he had experience in Amazon Web Services. And he was showing me all of the steps he had to take to put a resource in the United States and another resource in an Asian AWS system. He had to set up a lot of stuff to make the 2 computers see each other. Because usually inside Amazon, when you put something in a data center, that's all it could see. You got to open up you got to configure a lot if you want 2 computers in 2 different data centers to see each other. And I was just looking at what he was telling me, and I was like, ooh, sounds hard. Too bad, so sad. He was like, what? Doesn't Google do that? I was like, No, I mean, you do need a virtual private cloud, but if you put a subnet in one region and put another subnet in another region, then you're done. Stuff could just see each other. He's like, what? Kind of blew his mind. He's like, okay, that's neat. So it became a nice little way to expose how many things are just automatically done for you inside this cloud provider. And there are many other things. For example, you could actually protect your web application from distributed denial of service attacks. Doesn't that sound scary? What is a DDoS attack? Well, it's when a lot of traffic that's coming to your website is not real traffic. It's just malicious actors that are flooding your website with fake traffic so that it ends up choking out your system so it can't handle real traffic. Again, who's thinking up this stuff? You guys need a hobby. Anyway, like apparently somebody will take software and they will maybe use some of these unprotected Internet of Things devices, like your refrigerator and your microwave. Who knows why those are connected to the internet? But anyway, if they're not secure, sure, we'll use those as bots. And everybody, the malicious code says, everybody attack. And then your website is sitting here trying to offer services to good customers. Meanwhile, all these bots that are just trying to hurt you, distributed denial of service, acts like these mean bots that are trying to get to your web application. But because you're using Google Cloud, you can turn on Cloud Armor. Cloud Armor is a service that protects your website, your endpoint, your http://www. It protects that from attacks. It's smart enough to look and say, you're not a real person. No, it creates a shield. And these guys will just bounce away, and protected will be your endpoint. And yes, valid traffic can get through, but invalid traffic cannot get through. They won an award recently, not recently, maybe if you look up the record for DDoS attacks, Google set the record, and it was like, how many? 5 million requests per second were headed towards somebody's website, and the customer never even noticed. They were like, oh, did something happen? Because Google protected them. And so every time, there's always somebody that's trying to be malicious, and it's good to be at serving up a website from an organization that has really good tools to protect you. So definitely do it. All right, now you're in security. We talked about regular data center security, how it's up to the cloud provider to provide secure layers like the building itself and the boot up and the data at rest and the data in transit. And then we just talked about making sure that when you put your resources in Google Cloud, you're going to turn on certain security perimeters to make sure everything's protected. So I'm sure you might be wondering, well, boy, that sounds like a full-time job. You'd be right. That job is called SecOps. Security operations is a field of expertise that blends security and ongoing operations in order to make sure that your system is deploying good practices. You're protecting your data across all of the cloud resources. So it'll reduce, if you do good SecOps, security operations, you'll reduce the likelihood that there'll be data breaches. You will reduce the amount of system outages, and then there will be other security incidents that you'll be able to recover from. So let's talk about, how does a company like yours, if you go to Google Cloud, what do you do to make sure that vulnerabilities are handled or watched? You must keep ongoing visibility to anything that might become a security vulnerability in your infrastructure and in your app. Now, as an application developer, I'm very familiar with running scans on my code base to make sure that any known problems are not exposed in this application. But how do you do it for the whole cloud, for your whole cloud projects? Well, with Google Cloud, they offer something called the Security Command Center. It is a dashboard that shows you all of your resources and their status, and it'll help you kind of manage your security posture from a central location. It is heavily based on logs. This log management is huge. Logs. You must watch what's going on by watching the logging. Now, everything that happens in your cloud resource will have logs being generated. What is a log? It is a entry in the system of this is happening. It's just watching everything, and it's saying, here, somebody logged in successfully, somebody hit this endpoint successfully, and cloud logging is collecting all the logs in one place, and then you can filter the logs and look to see if that guy has been here. And my logs for the Flappy Bird, I mentioned I would show you some of the logs. I'll give you a quick glimpse into logs. Now, here's the Flappy Bird service that we deployed not that long ago. And because it was deployed in Cloud Run has given us just a little section that shows us the logs right here. I click logs, and I can see all of the logs activities. I can see all the different people that have, gone to that endpoint and information about each one. But I'd rather take you to the place where all the logs for all the things are happening. And this is where you'll spend a lot of time when you come back to one of our logging classes. Here is the logging dashboard. Let me see if I could get it less huge. And it lets me filter which product I'm trying to view the logs for. And then here I could see if over time, all the things that have been running and if there's anything going wrong. So in a nutshell, I could filter, only show me the warnings. Sometimes people went to Flappy Bird and came back with page not found. Here's another one, I'll clear that. Kubernetes. I'm running Kubernetes right now. Those are the services. So if I want to see how many people tried to buy things, these are all the logs for Kubernetes. So imagine if I have actual products or services being served up right now, I can just come on over to logging and I can just view any of the logs at any time, drill down into them and see what's going on. Logs, they are text-based entries that tell me everything that happened because everything's being watched all the time, all day, all night, log, log, log. But again, there's dashboards and all. But the point here, if you don't look at the logs, things are happening without you knowing that they're happening. So you want to be careful. The logging service is always running. They're there for you. So take a class if you want to and learn more about logging. But let's say something goes wrong. Something happened. Uh-oh. First of all, how bad is it? So there will be some questions asked. Now, based on the answer, what just happened may or may not be an incident. You see, when you say something is an incident, that's why you want to ask a lot of questions. Okay, is it an event? Is it just a thing that happened? Or is it an incident? Now, an incident, I'm not going to take you through all the questions that you have to ask. Once something is deemed an incident, you kick off a certain thing called an incident response. Incident response is should be a formal set of things that happen whenever something goes wrong. And this could be a cyber attack. It could be something just broke. The backup failed to kick in, whatever. You will end up with a team of people. This is your incident response team. You'll have a team leader. That person's job is to coordinate everybody else. You'll have a communicator. That person's job is to say, "Dear customers, we are experiencing an outage in the blah, blah, blah. And blah, 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 blah. We will get back to you in 1 hour. Dear customer, it is now an hour, and here's what we found." That person, that one single point, is going to communicate to everybody. Meanwhile, the rest of the team, they're scurrying around. They're scurrying trying to fix it. So Google has a bunch of expert incident responders that will help you through your movement through this situation, and everybody who's doing SecOps has a formal approach to this. So that means that you probably have some checklists that are going to be given. If something happens, then go straight to the playbook and start working the problem. People, work the problem. Your goal is to get it back running. And with this comes an education experience. You should have all the employees sit through security awareness training. Teach them everything we showed you in the previous section, where what is malware, what is ransomware, what is phishing, what is social attacks, social phishing, that kind of thing. And you want to empower your employees to look for problems and don't fall for everything. And then, if you want, employ a company to send emails. Send those fake emails out. Try to get them to click on a thing that's really phishing, but they should have realized it was phishing. And when they click, tell them, go back to training. It happened to me. I was working at one customer and I was doing two things at once, which is my first problem. And then I wasn't thinking and I just clicked the link and it was like, wah, wah. You fell for it. This was a simulated phishing attack. Bad. And I was like, okay, please take another hour of training. Okay. So don't click the links if it's from an external person. That whole thing, I forgot all about it. They'll test you. But that's the thing. You want to get to your employees who aren't paying 100% attention. You get to them before the phishing people get to them. And so, SecOps, you want to put it in place. If you have SecOps in place, the whole operations of securing your systems, you'll get a reduced risk of data breaches, which means you'll be up more often, more uptime. You'll get improved compliance, because when you answer all those questions from the security awareness or the security review board, they'll give you a good grade. And then your employees will have more uptime, more productivity, because you're not trying to fix everything, you're just working. Okay, let's see if you can answer this question for me, my friends. Which is the responsibility of the cloud provider in the cloud security model? Let's hear your answers. Yay, you answered B. Many of you, almost everybody. I see all B's and I'm very, very happy. The responsibility of the cloud provider is to maintain the infrastructure. They're not going to be able to configure your apps. That's on you. They're not going to decide who can see your data. That's on you. They're not going to decide on access privileges. That's on you. Very nicely done. All right, here's the last section of this module, and then we'll take a short break, of course. Google Cloud's trust principles, and are they compliant? Of course. Let's talk. Just a short thing. Okay, first of all, privacy, trust, transparency. Think about this. What if you brought you're Nike. You are Nike Incorporated, and you decided to go with Google Cloud because you didn't want to put your sneakers in Amazon, because Amazon might compete with you and they might peek at your product, and you're just wondering, what if they look? The reason I put my data in Google Cloud is because they're kind of neutral. They're the Switzerland of sneakers. So you bring your sneakers and you put them in Google Cloud. Now, is Google going to look? What if a Googler said, ooh, those new Nikes are going to drop. Let me see when they're going to be released. Can they just look at my data? No, that would be bad. They're not allowed to do that. So the first thing that Google wants to let you know is they have a trust principle, like you could trust us. And oh, by the way, we have transparency reports. In other words, every time we look at your data, we did it because you asked us. We didn't just, oh, I wonder what's going on with Nike at lunch. No. Transparency reports. Because of their trust principles, here's one of the things they talk about. They want to empower you and ensure you that the security and control of your business data is not going to be compromised. Here are the 7 trust principles. And of course, there's a whole book called Transparency, if you want to look it up in Google. All right, here's the first one. Now we are talking about you, the Google customer. You're the one bringing your data to Google Cloud so that you could use cloud resources to get your work done. I'm not talking about the Gmail customer who uses Gmail for free, although many of these things also apply, but just let's put it in the right framework. Now, you came to Google Cloud, Nike. Yay, you brought us your sneaker data. Yay, you own it, not Google. Okay, that's good. Just because we put our data in your data storage, that doesn't mean you own it now. Good. What else can we be sure of? We're not going to sell your data to third parties. That's your data. We're not selling it. That would be crazy sauce. Okay, says Nike. Yeah, you're not going to sell all the info about my sneakers to some third party, especially Adidas. We don't. Whatever, right? Next, they're not. Google Cloud is not going to use customer data for advertising, because that would be icky. Oh, we looked in your database and we saw that you're about to drop this sneaker. And did you also know that some socks go with that? What is happening right now? They don't do that. That would be crazy sauce. Here's another one. All the customer data is encrypted by default. You can't not encrypt when you come to Google Cloud, and so that is safeguarded. In the unlikely event of somebody unauthorized getting in, they still can't read it because it's encrypted. And now let's go to the 5th one. They'll guard against insider access to your data. That's the one I was mentioning, where the Googler can't just log in and say, hey, let's check out that data because I know we host their services. No, that's insane. Can't do it. And they will never give any government entity backdoor access to your data. I should add, without a warrant. I feel like if there was a warrant, then I don't know. I watch a lot of shows. I watch legal shows. I don't know if I'm informed, but I feel like without a warrant would be warranted here. So if you got served a warrant, I mean, I don't know. Gray area. Okay, next. Our privacy practices, says Google, are audited against international standards. It's like we're not operating in a silo over here. We're not operating in a little dark corner. We're public about it, we're audited, and we pass yearly. So here are the two things that you can do to make sure that you can leverage this. You have reports that you can use as resources. So you can maintain trust in Google Cloud. One of these reports is a transparency report. And a transparency report and an independent audit's transparency, these are the core elements of their entire commitment to trust. So if you were to go to transparencyreport.google.com, you'd see the valuable insights, all the accountability that they're taking through these transparency reports, which shed all light on the government and corporate actions that affect your privacy, all the security and the access to your information. So that's the one that I would read if I was curious about, should I put without a warrant? It'll be right there in those transparency reports and independent audits transparency. All the government and corporate actions that affect privacy, security, and access to information. Now let's talk about that. Who's auditing Google? Well, they undergo independent third-party audits to get their certifications regularly. So it's a verification process that makes sure that the data centers comply with all of the standard practices that are recommended for data centers, and they are participating in the EU Cloud Code of Contact. Listen, say it 3 times fast. Try it. Go on, let me hear you. Code of Conduct. This is where they are rededicating themselves to all the accountability, the compliance, the support, and all the robust data protection principles that are, if you know anything about these data protection rights, EU is more strict. So Google complies with the EU Code of Conduct. And that's more strict, obviously. You might already know the way America is like, your data is kind of our data now. And the EU says, well, is it? We have the right to be forgotten. There are some EU rules that are a little more pro-consumer. So that's what they're compliant with. Speaking of data and residency and all of the rules and everything, have you heard of the GDPR? GDPR. That's kind of what I was referring to when I was mentioning that how the EU is a little more strict with their data. So data sovereignty is the concept that the data that is generated by the customer is subject to the laws and regulations of the country where it resides. And that is one of the things, the GDPR in the European Union, it requires companies to comply with those protection laws when they're processing, storing personal data of all the EU citizens, regardless of where that location is. That EU citizen the individual should have the ability to control their personal data. In other words, they have the right to be forgotten. They can fill in a form, forget you ever knew me. Okay, delete, says the GDPR. That's their right. Now, the other thing you might have heard, data residency. Data residency means where was the data stored? Where is it processed? Some countries or regions have laws that say the data that was generated here has to stay here within their boundaries. So some countries too, they mandate the personal data of their citizens definitely stored on servers within their country. So what does Google do? If you look at their map, if you look at Google's regional map, you'll find a whole lot of little dots in the European area because of the data residency rules. That's why you have so many data centers all clustered together, because Google Cloud data residency requirements are going to be in effect if you're dealing with any European data regions. And then with the European Union, let's say that you create some servers and you want to put them in the European Union. When you do put your data in there, you can select which countries are going to have your storage buckets, and you can have your selections support the rules that govern your company. And that's what I was saying. Google Cloud gives the ability for companies to be compliant with whatever regulations they're subject to. And if you are subject to this data residency rule, then yay, Google Cloud has offered regions that are specific to, or help you enforce those laws, make you able to choose places to put your data that are supporting the rule that governs you. It makes sense. Now, if you are a company that's doing business in the EU and you do need to put your data in some selected places like Germany, Switzerland, Finland, and Netherlands, you can configure your resources to be placed in those countries. And as an organization, you could set up policies, organization policies that, and I'll show you in the next chapter how the organization is managed in Google Cloud, but just let it be known, it looks like a hierarchical chart, and you could set up some rules. You can set up a constraint that says anybody who puts a storage bucket in this Google Cloud resource must put them in, and then you pick which countries. Finland and Switzerland only. So when a person goes into Google Cloud and they're just new to all of this and they're creating a bucket, they don't know the rules about GDPR, they don't know the rules about data residency, but when they go to create a storage bucket, guess the only two places that show up as pickable off the pick list? Finland and Switzerland. Why? Because this organization policy is preventing accidentally picking the wrong region. So your group is going to get together and create constraints in Google Cloud that enforce the rules that you've settled upon. And this is what you'll tell the people when you have your security audit and they ask you to prove that you're doing these things. You just slide the piece of paper across the table as if you were in a negotiating deal. You'd be like, refer to this document that shows how we're enabling this rule and we're compliant with this rule. Lots of different things also are used to control ingress and egress of wanted and unwanted traffic. Service controls are one of them. We talked about Cloud Armor is another one. So many different tools are available to you when you get there to do what you need to do. All right, a quick question. Which cybersecurity threat occurs when errors arise during setting up of resources, inadvertently exposing sensitive systems to unauthorized access? Which one of these things describes that scenario? Nicely done. It's D. You got it right. It is configuration mishaps, because the rest of these are more passive. Phishing, they tried to get me. The virus, it tried to get me. The malware, it tried to get me. The configuration mishaps, oh, that's on me. I did it. It was me. All right, one more thing and let's go on to our break. The final thing to tell you is where to go to find the compliance reports in Google Cloud. Remember, I was mentioning if you want to pass all of your security audits and you want to say, yes, we are enabling some of the, very strictly controlled compliance thing. We're using Google Cloud to get it. Well, here's what you'll get. You'll be able to log in to Google Cloud, go to the Compliance Resource Center, and it's cloud.google.com/compliance. And so what you're doing, this is a comprehensive hub that gives you all the detailed information on all the certifications and compliance standards. And what you can find is mappings of their security, privacy, and compliance controls. What are we doing in Google Cloud to support this thing? Now, what thing does it cover? For example, there's like 40 plus security certifications. Let's say you're a hospital or you are a medical facility and you must enable and make sure HIPAA is being followed to the last letter. Of course, well, this resource center will give you all the necessary insights, all the documentation that helps you align all the things you're doing with the compliance requirements of HIPAA. You'll tweak things and turn things just so that you're compliant. Or maybe that's not you. Maybe you're doing financial things. Well, now you've got another regulation that you have to comply with. That's the PCI DSS. That's the payment card industry and data security standard. You will have to comply with that. There's a lot of different compliances that have to be aware of, and this is the place to go. This is the cloud.google.com/compliance. Thank you, Barry, for putting that in the chat. And finally, with this compliance reports area in the compliance reports manager in that same location, it'll help you, giving you that easy on-demand access to these resources. There's no extra cost, but it lets you go in there and figure out which reports you can leverage to help you solidify your position. All right, one more question, and then we'll go on our break before we start our last chapter. What? Okay, question. What Google Cloud product provides robust protection from harmful distributed denial of service attacks? Which one of these? You got it. It is a Google Cloud Armor. It's not load balancing. It's not IAM. It's not monitoring. It's the Cloud Armor. All right, nicely done. I will see you back here in, let's say 10 minutes. Let's take a 10-minute break. I will switch slides and turn on a little music. Of course, you get a timer. All these good things. I'll see you back here shortly. welcome back. I know you can't see me yet. Hold on. Hey. Welcome back. I hope you had a good break. It is time to start at the top of Module 6. Oh, you didn't see that. Shh, don't look. There's a quiz question giveaway, huh? All right. Welcome back. We're at the top of Module 6. It's just this one and then my summary chapter, and then we're done. Isn't that wild? What's going on with my audio? Okay, let me first turn off my... Okay, now can you hear me all right? Okay, the people in StreamYard says it's okay. All right, I'm in the back room. Online people, hey. Are you ready to do the last round of all of this fabulous learning? Woo, this is a lot. You, my friends, have been sipping from the fire hose. It's a lot of stuff coming in, but we got this. We're doing it. Module 6, scaling. Now, I love the things that we placed in the scaling chapter. You're going to find out really quick that it's not just about scaling, but it's so many other things too. So with that, I will just jump in and tell you from the beginning, when you're managing your cloud resources, the top of mind, the first thing you're thinking about is, do we have the ability to scale? I would even submit that if you move your resources to the cloud, yet still cannot handle bursts of traffic, you're not doing it right. Nope. Try again. It's okay. We got different rounds of efforts that we're going to make. But if your system cannot handle a surge in traffic, now I don't mean a surge to the point where the cloud armor can't take care of the fake stuff. I'm talking decent traffic, on purpose traffic is with good faith trying to get to your services and they can't handle it. You might be doing it wrong. I mean, I'm just saying, no shade. I'm not judging you. You just might want to look at it. So here's what we're going to talk about. Cloud operations. This is the idea of effectively keeping your resources up and running. It's a set of practices and strategies that you're going to put in place to make sure the smooth operations are continuing over time. You need functioning systems, optimized systems that can scale, because there's no excuse. You're in the cloud. It's not like you don't have access to the resources. That ain't it. So what is it? We're talking about cloud operations that ensure that with a combination of monitoring your infrastructure and managing it when it goes a little bit awry, that together you can create something that is reliable, performant, secure, and cost-effective. It is not too much to ask to have all four of those things in a scalable, monitored set of cloud infrastructure, applications, and services that you've got running. And a lot of companies are doing it. It's not unreasonable. So what did our panel say? Expect excellence from yourself. So here's how we're going to do it. Starting with the finances, because I was alluding to a couple of things, but I hope that what you pulled from what I've said so far, I hope you already understood that CapEx is now moving to OpEx, and because operating expenditures are fluid, they could go up, way up, real fast. I want you to realize that if you used to work in an organization that had, let's just pick a number, 4,000 virtual machines running, that we do not expect you to lift and shift 4,000 virtual machines and run them the same way that you did on premises. Here's why. On premises, the virtual machines, I mean, who cares? They're running all weekend, even though we're not coding on the weekend. Who cares? They're up and running. It's minimal resource usage. We've got the servers. We own the servers. It's just a little electricity and it's fine, leave them on. Take that thought, take that same thinking, and don't change anything and move it to the cloud. That becomes a, oh my God, did you see the bill? Yeah, what happened? You kept your VM on the whole time. You used that thing one time in the last month, but you paid for 30 days. And multiply that by 4,000, that's the problem. So it's not just lift and shift and walk away and you're done. No, that's not it at all. Because listen, we're going with OpEx here. It's operations, ongoing usage of resources, which makes you, that's right, your father was right. When you leave the room, turn off the light. Close the door. What, were you raised in a barn? Are we trying to cool the whole neighborhood? I'm just listening to my parents telling me about resource usage throughout the house because that's an operating expense. If no one's in the room, could we turn off the light? It's not that much to ask. This is what you're going to do at scale at the Cloud Operations Center of Excellence. In fact, you should probably create such a thing. The Cloud Operations Center of Excellence. Your job is to nag everybody. Turn off the lights when you leave the room. All right, so you've got to manage these cloud costs, which means it requires vigilance and real-time monitoring. Here's the other thing. It's not enough to just wait for the bill to come. No. By the time that bill arrives, that monthly bill from Google Cloud, it's already too late. You already owe the money. It's better to look every day. Look at it. Just look a little bit. Just take a peek. How are we doing? Are we using any resources? Are they running away from it? Let's discuss. So, in fact, the managing of your IT infrastructure costs are no longer solely in the lap of the few people who have the budget and the procurement and the internal, sorry, my brain stopped working. The capital expenditure person who's in charge of investing in capital, that's no longer the issue. Now everybody, all the people are involved. So what does that even look like? We're talking about the fundamentals of cloud financial governance, and what that means is you're gonna have a lot of people who are gonna be in charge of watching the cloud spend. Cloud spend. It's a term that we use that kind of gauges over time how we're doing, how much money we're spending on these resources, and we need precise, real-time control over what's being consumed right now. So this means a bunch of people should get together and have a governance team that's going to look at the spend. Typically, this will involve a core team that crosses function, a business function swim lanes. You want people representative of every arm of the business, including those that are traditionally IT folks, because these people are saying, all right, we're IT, we're going to need Kubernetes, and that needs to run in this kind of mode, and it needs to be in these 3 regions. And these are the IT people. He will tell you, technically, what do we need? But also, you also need the finance team, which says, that's too expensive. You can't do that. Let's look for an alternative. Now, don't just leave these 2 people in the room because they're going to fight forever. Add a business person who is keeping their vision and their mission front of mind, and it will be all of these discussions between what we need to stand up and pick a different one. That business person will give some scope and some context, and they'll say, well, we are here for the customer, and if this choice will reduce latency and give the customer more of a happy face, then it's worth it. Let's spend the extra money. That business person will help us keep our sights due north, because if we keep fighting, we'll start shifting and all of a sudden we're way left and we don't even realize it. So these 3 types of people should be in the same room, offering perspectives, hoping for some harmony eventually. Because the cloud costs are going to impact all 3 levels. They're going to impact the people that are in the room talking about it. It's going to impact the processes that you take in order to enable this technology. And it's also going to impact the technology itself. which will change over time. It's a lot. So that means also that there should be, maybe come up with a group called the Cloud Center of Excellence. Come up with a logo. Put it on a door. Put the little label on the door. Decide that this is going to be a working team, working involved parties from cross-functional teams. And a few people from finance going to work together with a few people from tech, which are going to work together with a few people from the business team. As a team, huddling together, trying to figure it all out. This is your centralized hub. Have regular meetings. Bring donuts. I don't know. Make it fun. But what you have to do is make sure that you regularly meet and decide as a group what it is you're going to do. So, the Cloud Center of Excellence. It's a thing now. We meet every Tuesdays. There's donuts. Yay. What we're going to do is ensure that the best practices are in place organization-wide. Oh, that's tricky enough. It gets better. You're going to make sure that there's visibility as to how much we're spending so far. And then when you look at the visual tools about how much you're spending so far, if things are going off the rails a bit, then you'll make some decisions as a group which things you're going to scale back on and which things need a little more focus. And so that's the people part of the equation. The people get in the room and they make sure that they've got visibility at all points. Now, the process that you're going to use. What kind of processes are you going to implement? Well, we recommend that on a daily. I recommend daily, but maybe you're going to say, oh, it's okay to do it weekly. Monitor your cloud usage. Monitor it. Well, how do you do that? Don't worry, there's a thing. I'll show you exactly how you can monitor and analyze your cloud costs. Because on a weekly or monthly basis, you will also be reviewing the changes and stuff. And also, by the way, charge back the resources. Let's say you have a bunch of different compute engine resources. Make sure that you've defined a way to map that. Each individual VM should be able to be mapped back to the group, the team that is responsible for that VM. So that when you do your reporting on your budgeting, you can say, all right, let's show the bar chart. Let's see which of us are spending the most money and show it to everybody. There's nothing like a little peer pressure to make someone say, ooh, did I do that? Was that me? Oops. I'll show you what we use. Now, again, I'm part of two things. Like I have my company and there's ROI training, which I teach for. And so I could take you to either one. So I'll just take you to ROI, their little billing dashboard, because mine, I mean, we spend 5 cents on AI. It's not that much. So let's head over to billing. And I'll pick the ROI account just so you could see. Oh yeah, this is probably my own. Which one is this? Oh no, yeah. This is ROI. So listen, what if we were all in a meeting and all of the costs for the current period are showing? Do you see how my total cost from March 1st to 7th, we're at the beginning of the month, so we didn't pay that much yet. But we think we're going to pay kind of a lot. Look, 1.13K, yikes. Now, if you scroll down, you could see which days we spent the most money. Keep scrolling down. Now you can see which projects, because everything, I'll talk to you in the next section how it's broken down. There's organization at the root and then folder. Eventually you have projects. Which projects are the most expensive? Uh-oh, I'm over here. But other people are spending more. This is the thing. You're going to show these bar charts in meetings and you're going to be like, marketing, is this you? And marketing's going to be like, oh my God, I'm so embarrassed. Guys, how come you didn't? You kept the server going. What's going on? So you're going to use a little peer pressure. And then there's different ways of reporting what are we using? What are we spending the most money on? Compute engine. So that's what you're kind of doing. Which reminds me, I should probably delete my Kubernetes. I should probably delete that. We don't need it anymore, right? You be a good steward, because listen, after this class is over, I'll go to the couch and I'll lay out, and I won't even come up for air. And then tomorrow, Grant will text me, Charlene, so that Kubernetes cluster. I'm like, oh, sorry, Grant. I'm just deleting it now. All right, cool. Don't want to hear from him. Love him, but I like positive attention, not negative attention from the guy in charge of all this. We'll go back to my Grant stories soon because there's more to discuss. But for now, just know that that little interactive dashboard is just the beginning. I just showed you the built-in approach. You could create custom little reports that show exactly which resources used by what team, because you would have tagged every virtual machine with the owner or with the cost center, and there will be a tidy little sum with a projected spend for the rest of the month. And at that point, you still have time. You still have time to do something about it if the month isn't over yet. And then the technology is the other piece. So remember, we started with people, then we went to processes, which involves please check the bill before the bill is due. And finally, technology. For the technology, Google has some built-in tools that'll help your organizations monitor everything and manage the cost. And that's kind of what we were looking at. The other things that you could do with technology, there are some this one. Google provides intelligence recommendations. You could go into any one of the things you're currently running, and the recommendations tool will have a little light bulb at the top. And it says something like, you might consider moving this to a different resource because your machines are running 50% idle or something. You over provision this resource. The recommendation engine is always suggesting things. It's a little light bulb that says you might want to do this or that. It reminds me of Clippy. If you remember that from Microsoft Word, do you remember 20 years ago, Clippy? This little animated paper clip to be like, hey, you might want to change something. I like Clippy. Yeah, me too, Kate. I like Clippy. So, back to you, though. We got to get back to being serious. We're almost done. I can see the end of the road. Listen, what are the best practices for financial governance? 1, pick a person, pick a team who's managing the cloud costs. If it's a team, make sure it's a mix of IT managers and the control and the financial people, because leave the financial people to their own devices. They don't like anything. Everything can get shut down if you ask them. So get your IT people in the room too. And define clear ownership. Who owns these things? Who can we map back to? Who's the responsible party for each of these resources across the organization? Next, understand what kind of information can be found in an invoice versus the tool I just showed you. I just showed you a little dashboard that could be filtered by lots of things. That invoice at the end of the month, it's just a final bill with some categorization. It's not to the detail that you might expect. So you want a blend of these resources, invoices versus the other tools of cost management. And then finally, you want to use the Google Cloud cost management tools. What are the cost management tools? Well, I'll show you. There's a way to monitor. No, so cost management tools include built-in reporting like I showed you a minute ago. There's also a budget that you could set up, but don't get too excited. Budgets are soft ceilings that can be pushed right through. Budgets are a suggestion. So if you say, okay, all my projects, you're not allowed to spend more than $500. That's a suggestion. Those projects can go on to bill $1,000. Well, then why have a budget? It's a point that you could tell the budget, please email me if I get close to my budget. If I get close to spending $500, please email me. But this assumes that you're checking your emails. Guilty. Was I supposed to check all the emails? How come it's in the I don't care about this stuff folder? I mean, they tried to tell me. That's why budgets are not spending limits. They're not. Budgets are not spending limits, but quotas are limits on resources. So you have budgets, you have quotas. One of these things, this is just a soft, it's just, okay, you can go right past it. Quotas are hard. Meaning you can have, and I think I have something about quotas. Let me just make sure I'm not pre-teaching something that's already gonna come. And all right, I'll table that. I think it's coming up, but I'll come back to that if I need to. I wanted to talk about the pricing calculator. This is a pretty cool tool. The Google Cloud Pricing Calculator. What it does is it lets you pick which product that you think you're going to be using, configure that VM just the way you think you're going to need to use it, and it'll give you a price, how much that'll probably cost, without you actually building it yet. And so you're creating all of these configurations just to kind of get a feel for how much it's going to cost. And then as you fill out this, it's a nice little tool. Go to cloud.google.com/products/calculator, fill it in. And what I like about this tool is you can kind of type in all the specs for your virtual machine, for your Kubernetes engine, for your Cloud SQL. And if you put in the right numbers, it'll estimate how much that'll cost. And then you could save that estimate and you could share the estimate with somebody. So you could say, this is kind of what we're thinking. What do you think? And it becomes a document that gets shared. It's not a bad idea. So let's talk though. Let's go back to the idea of you have a Google Cloud project somewhere. How does it work? You saw me go in and create a Kubernetes instance, and then I added Flappy Bird, and then I did this and that. What's the organization like? I'm going to show you how in Google Cloud you're going to have access to a organization root node, and then you're going to get to some of the products underneath it. You're going to, in other words, you'll probably never see this level of management unless you are the organization admin. So I'll show you something that kind of goes like this. The organization node, that's your company.com. This is your domain name, whatever it is. Usually that's the root node of an organization. You decide, we're going to go Google Cloud. They'll set up an organization for you. You attach a billing account to that, attach a credit card, and then proceed to create folder after folder to organize the structure. And folders can have folders which can have folders, but eventually you're going to want to use the Google Cloud resources. So those resources belong to a single project. Each resource, whether it's a bucket or a Kubernetes instance, it's going to be inside a project. So let me show you what that looks like, because a lot of times you don't get to see this because you're probably not the organization admin. I mean, I'm not either, but I could see. All right, I got this. My brain is stopping working. Literally, it's not working. Okay, it's here. I don't know what's happening. Manage resources. Okay, this is what I wanted to see. Let me make it a little bit, I think I can hide some columns so it looks more organized. It's an organization resource. So here I am. I'm logged into Google Cloud, and I do happen to have my own account for my own company, but it's super tiny. Not much fun to look at mine. Let's look at ROI. Big corporation, lots of teachers, instructors. So here I am. And I'm not the organization admin, but I'm allowed to browse. I'm browsing around now. The organization root node, like I said, it would have a .com or whatever your domain name is. That's your root node of your organization. Everything you do for your company will be underneath that node. So let's expand it and see all the folders. Do you remember all the folders? I said that an organization root node may have folder after folder after folder so you can organize your projects. Each folder may have more folders. There's mine. Look, the instructors folder has lots of instructors. Hey, everybody. I see all your... That's a lot of people, huh? Each folder can have folders, or they could just have projects in them. Now for me, I didn't create any of my own folders. I just have a couple of projects going on. We've been using this one a lot, Charlene Banks. Oh, good. I only spent 18 cents on that Kubernetes so far. Hopefully that's all, right? Now, that's the story. Everything comes down to a single project, and that project is the one that's going to hold my Flappy Bird, my Kubernetes. Each project is manageable. Now, the thing that I like about these folders is that I can grant, if I was Grant, this is why he has the perfect name for managing our infrastructure. His name is Grant, and he grants privileges. So if Grant gives all instructors access to the instructor folder, view access, then we can all look at each other's folders. But because every privilege, every granted privilege is going to propagate downwards, as it should. So if I want to create a folder for a team like yourselves, if you have a department called sales, I might create a sales folder. And then all the people who are allowed to do sales stuff will be given access to that root folder and all the subfolders. And of course, you're going to give more and more permissions. They'll be more granular as you go lower. I'm not able to go into Blake's and like edit his. Oh, $1. Blake, you're spending $1. But I'm nosy. I can see how much they're spending, can't I? So this is the idea. An organization, in this case, that's the root node of your whole, like all the stuff that you do as a company points at that root node, and then you decide. Most organizations just build folders to reflect their org chart, their organization chart. Why? Because remember that policies that I put on my organization, any rules, any privileges that I create are going to trickle down or propagate. I don't know which word works for you, but notice that any rules I put at this node are going to be applied everywhere. But if I put a rule at this folder, then it gets applied everywhere below it. If I had a sibling folder, it would not get applied there. So I'm choosing what level to apply certain privileges, knowing that whatever I put on the higher level, it'll automatically flow down. And at the lower levels, you're not allowed to override anything. And so that's the high level. You'd have to come back and take one of these courses. But the idea is resources are built inside a project. One resource cannot belong to two projects. It can only belong to one of them. And that's the goal. We build things in Google Cloud. They go inside a project. The project is going to go inside a folder so that they all work together with permissions. That is the reason that we use these hierarchical controls. It's for trickle down. This is where I can do granular access control. I could decide what level of access I want to give people. If I want someone to access everything in a folder, I just give them access to the folder. Oh, that's too much? All right. How about I should only let them access this one project? I only give them access to the project. I decide the level of granularity by choosing the node in the organization hierarchy, and that'll automatically trickle down. It's called propagation, I know. Inheritance, that's the technical terms. And yes, there's security built in to all of this. And by the way, there's strong visibility and auditing. There's a capability to audit everything that I've just talked about. You need this. You could track access permissions. You could track how many changes happen to somebody's access, and then that improves the accountability. And it makes people sort of, remember, you want to trust but verify. Give access and verify that that's all they had access to. All right, quick question for you. Which represents the lowest level in the Google Cloud resource hierarchy? I see a lot of D's in the chat. You're absolutely right. It is the resources that are the lowest. They're down at the bottom. Resources belong to a single project. Each project belongs to possibly a folder or two. You could have a project just sitting out there with no folder, but that's kind of a rare case. Usually people put them in folders. So yes, you got it right. Now, how do you control cloud consumption? This is where we talk a little bit about those things I mentioned earlier, and I'm so happy that I didn't skirt over these slides. It's very important. Think about it. You want to make sure you don't spend too much. But in order to make sure that you don't spend too much, you want to also increase the visibility of how the current resources are being used. You want to make sure everybody's in the room when you show that bar chart. And then you want to improve the compliance where you're making sure your cloud environment is compliant with any industry regulations, which we did talk about already. So here's the deal. There are 3 things people use to make sure that their cloud consumption is kept in check. 1, the quota. There's a thing called a quota. Resource policies can be added to the hierarchy that says no project can have more than a limit of certain resources. For example, we could say at an organization level, for each project that exists, no project can have more than 5 CPUs, 6 CPUs. You could decide how many of each resource is available per project. And as soon as somebody decides to build a compute engine that is bigger than what is allowed, they get a resource quota violation, at which point they have to ask, can you make it bigger, please? Now, to be fair, Google itself has resource limits by default. When you create a project and you go in and you try to you create some script and it says, give me 50 servers, and it turns out you meant 5. Meanwhile, Google itself for each project has some default resource quotas. And it probably goes about and gives you the first 5, 6, 7. At some point, it's going to be like, look, you ran out of quota. You're going to have to request a higher limit. And it's not like they don't have resources for 50 virtual machines. It's just that, do you really want 50 or did you have a typo? Which is it? Let us know. And then you ask them to expand it, and they'll give you more if you need it. It's not because they don't want you to be able to spend your money on resources. It's just that people, have you met them? Have you met us? Have you looked in the mirror? Have you checked your code? Sometimes we do it wrong, and they don't want the wrong code to start eating away at all their resources in a runaway script that just did too much. So not only is Google giving us quotas, your organization can put another limit. They could put a more strict limit and then just keep you from using too much. That's the hard limit. It's hard because the system won't allow you to create a resource that is bigger, that's higher than the quota. Now let's talk about the soft limit. The soft limit is a budget. It's soft because nobody's going to stop you from spending a lot of money. The budget says, what's your target? $500. Okay, I'll email you. But it's very passive. If you blow past $500, it's like, email, Charlene, you know you're spending more and I don't see it. Guess what? So, all right. Yeah. I just have to text my friend there. Okay, cloud billing is the other one. Cloud billing reports. This is the one where I mentioned before, you could run a quick resource check and you can run it down and see how many servers are running, what's the money that's being spent. That's the demo that I gave you earlier. So you could remember that if you tell Google, I am committed to use this thing for 1 or 3 years, remember that is your committed use discount. If you commit, you'll get a bit of a discount. And so if your organization has a dedicated workload, you're sure you're going to be using it. Absolutely. Let's go. Okay, let's ask another question really quick. Which feature lets you set limits on the amount of resources that can be used by a project? Go. You got it. Quota policies. Nice. This is the one. This is the feature in Google Cloud that lets you enforce limits on the cloud consumption. And you can lift them if somebody has a good reason. Nicely done. Okay. The next thing I'm going to talk about. This is kind of chunky, but we can get through this. So here's the deal. Operational excellence and reliability at scale. Now, operational excellence means the ability to keep your systems running even if you run into a hiccup. You want to be able to work around any problems. You want to provide uninterruptible service even when things are getting kind of hectic out there and you've got increased workloads, things are getting complex. So you need to keep it up and running. So what we're talking about are two things. Operational excellence, that means, yes, we're scaling dynamically, kicking up the resources in order to keep up with the requirements of traffic. Also, automating, dynamically scaling up and down, load balancing, all the things, and making sure that even if we have something go wrong, we're not down for long. We don't have a lot of downtime. We are employing systems that are fault tolerant, and we have disaster recovery failover mechanisms in place. So if that's the case, let's look at what it means to have cloud reliability. This is a big topic, but I've limited it to a few things. Here's what we're going to talk about here. Developers, their job is to write code and do things quickly. In fact, they have you heard? They have this phrase, move fast and break things. By the way, I expect to be done with this section by about 4:30, and then we'll be wrapping it up. Sorry, yeah, what time is it right now for you? 3:30? Is it 3:30? No, I'm sorry, I'm an hour ahead of you. That's my problem. It's 3:12. I expect to be done with this by 4 o'clock. And then I will wrap it up. Somebody asked in the chat. I'm going to wrap it up and do the summary chapter, and then I'll leave you to your own devices. So 4 o'clock Central Time. Yeah, final wrap up by 4:30 Central Time. I'm looking at my clock going, oh no, it is 4. It's not. Okay, so here's the deal. Developers have a phrase. You've heard it recently. Move fast and break things. Move fast and break things. Now that's an approach. It is. Meanwhile, the operations team, whose job is to ensure that the systems and the applications are up consistently and reliably, they're like, hold on, cowboy. You need to slow down. And then the cowboy, I want to move fast and break things. You need to slow down. There's a bit of a fight. Move fast and break things. You need to slow down. There's a bit of a conflict, wouldn't you say? It's true. So let's dig in. The expectations of a developer. Oh, gotta be agile. Did you see that show, The Devil's Advocate? He's on the roof with one of the, two people talking, and he's going, you gotta be agile. That's what they want to be. They're pushed to write code and deploy code quickly, with very little testing, I might add, depending on your team. They want to release new functionality very often. And that means that in their minds, they really value new features by bringing new code, and they want to release fast, and everything's fast. However, operations team is like slow your roll. They're expected to keep things stable. It's really hard to make things stable if things are always changing. So their preference is to go about half that speed and work slowly. Make sure it's fully tested. Let's make sure that the system stays reliable. We don't want any surprises, and think about it. As you could just imagine, these usually are two opposing forces. So even though developers and operators tend to work separately and at odds, the idea of DevOps brings developers and operators on the same side of the table so that they can collaborate as they look toward the same goal. The goal of DevOps is to emphasize collaboration. Let's work together. Communication. Let's talk a lot. Let's use measurements that'll give us an idea of how well we're doing. And then we can share the responsibility of the application. We know that we can automate maybe create code with automated CI/CD, continuous integration, continuous deployment. This is a goal of DevOps. It's a team that works together. And so, of course, Google wrote a book about it. It's called Site Reliability Engineering. And this DevOps framework, when you take a developer team and an ops team and you put them together, you give them goals that they both can work on together. Now they're working together to ensure there's reliability and availability in their software systems in the cloud. Site Reliability Engineering. It's a set of practices that one time I taught a class on Site Reliability Engineering, and I started the discussion, and I was explaining it to them as if it was new. And somebody put in the chat, yeah, we are actually certified site reliability engineers here. I'm like, oh my. So, as you know, this is how we do it. Like, I couldn't change the content. I still had to teach it, but it was more short story. As you know, let's move on. But these people were already certified somehow. I was like, okay. So it was fun. But what is at the root of site reliability? It really is monitoring. Let's look at the processes that are running, and let's make sure that there's nothing about to break. Does anything need urgent attention? Are there any trends in the application usage pattern that lets us know that maybe we should scale up? Is there anything that we need to plan for in terms of capacity? And can it get better? Can we improve the client's experience so that they have a happy face? You remember what makes a client happy? Low latency. Listen, you can make the most beautiful button on the most beautiful background with the best little rounded edges. If it's slow, nobody cares. They backed out of that website and moved on. They never saw the button because it wouldn't render. My goodness. So let's get it right. Let's get it correct. And let's make sure everything is good. And when it comes to monitoring, there are 4 golden signals. Here's what you might want to pay attention to. I don't know. Maybe think about taking a few notes here. Hint, hint, nudge, nudge. Latency. That's the number 1, measured in milliseconds. We talked about it earlier. 4 golden signals. How do you know the app or your site is up? Check these signals. They'll tell you. How's the traffic? Each one of these has its own slide. I'll keep going. Is it saturated? Have there been any errors? If you focus your attention on these little indicators, then you'll have an insight into how well it's doing, or maybe it's on its way to not being good at all. Remember what latency is? Measured in milliseconds, how long it takes for a particular part of a system to return data. It directly affects the user's experience. Are they happy or not? You'll know. Changes in latency could be an indicator that something else is coming. Something's going wrong. Now, hang with me and I'll show you what those things might be. And just know that when these values go up or down, they're tied to some demands in other areas. But you can use it. You can use this to measure whether you made any positive changes or not. One of the things we count when I modify the code, well, is it any slower or is it faster? That's what we're going to check. Now, what are the other symptoms? Traffic. Traffic will let you see what is the system demand right now. How many requests per second? That will tell me traffic. If it's higher, then of course traffic is going up. If it's lower, then we don't have it's not as busy. It is a core measure that tells that you're going to use when you calculate how much infrastructure do you need. Well, how busy, how much traffic do you get? This is something that if you're coming from another cloud provider, if you know how much traffic is typical for a particular app, then you know what kind of resources to allocate. So it's very useful. But saturation, boy, I tell you, how full is it? How full is the service? We're talking CPU. We're talking memory. How much of the disk space are we using? How full is it? Because the fuller things get, it's an indicator that that capacity is getting reached sooner, and then of course things will get slower. These are tied to the high latency. Why is it taking a while? Because it's saturated, because there's a lot of traffic waiting for resources. All these things are kind of intertwined. And finally, one of the most standalone, easy to measure things, how many errors are we getting? A lot or a little? And what kinds of errors are they? With an error report, you'll get an indicator that something's failing. And if you configured it wrong, or if there were capacity issues, these errors that you get will be a little different depending on what's wrong. But definitely you want to get an eye on those errors because they could lead you to violating your service level objective. And of course, if you get enough errors, you might want to send an email. Some of these things can be tracked. Some of these 4 golden signals, they can be tracked automatically by Google Cloud, and then you can tell it. If it gets to this level, then alert. Send somebody a text message or something. Tell them about it. So, because humans don't want to sit and just look at dashboards all day, you could get the system to watch the numbers, and when it hits a certain ceiling, then you can have it notify a human. So, all of these things are important. And so, let's discuss then a key thing. I hope you've heard of SLI, service level indicators. SLIs are things that you measure. Things like I just talked about in the previous 4 slides. Things that you measure. So we're measuring latency. Or we're measuring errors. Sometimes people call it uptime. Is it up or not? That's an indicator. Traffic, how many requests per second. The indicator is going to be a measurement of how many, how much, that kind of thing. Then, take that indicator and come up with a target. What target would you like? And the target will be your service level objective. Your service level objective just says, listen, I would love for if there was a request that came across HTTP GET, I would love for the results to come back, service level objective, within 300 milliseconds. Now, if that's true, of course, this is a latency indicator that I'm doing. So I'll just put latency on the left. And internally, we're going to come up with a service level objective. Now, I need you to understand the difference between a service level objective and a service level agreement. The objective is an internal, I want to do really good, this is the number. But the service level agreement, this is external. This is an agreement with the customer that you're going to sign on the dotted line. We, as the service provider, promise that when you hit that HTTP endpoint, the latency that result will come back within, and give yourself a break. You know that internally you're shooting for 300 milliseconds, but don't promise that to the customer. We have a whole class we teach on over delivering on some stuff. Stop it. 500. I'm just saying 500, if you can get them to agree, 500 milliseconds. And you're saying that we will agree that 99.9% of the time, it always has, like, you have to tell it how many requests out of 100 will return back within 500 milliseconds. 99.9 of them will return back within. So that's the idea. You're creating a target. One of these things are internal and one of these things are external. And the idea behind it, if you come back to our other classes, you'll find that a developer and an ops team, we can look at these indicators. They could actually take an app like Flappy Bird and figure out what is the average latency over a period of time and ensure that internally, this comes back. Pretty much every time we go to get the Flappy Bird endpoint, it renders a bird with flapping within 300 milliseconds. Good, because we promised the customer 500 milliseconds. So you hear inside of this a little wiggle room, right? This is considered the error budget. So when you come back to training, you can say, you can take, the class where you're deciding on the service level objective. The query should come back this quickly, and the more lenient thing you actually agree on is the service level agreement. But then you just take a dashboard and you make a bunch of different service level indicators that you're tracking your objectives to make sure that nothing is slipping. And as long as all of your identified levels of service are meeting your objectives, you can rest assured that you can take some time and build some new features. You have a little error budget because your results are pretty much coming back within 300 milliseconds. There's not a problem here because you have actual numbers that are watching these services. The ops team and the dev team are both looking, and you could see we don't have a problem. There is no bug in the latency. And then the ops team might say, but I still feel like you shouldn't work on new things. We're not doing vibes. There's no service level objectives that says the vibe isn't right. Excuse me. So as long as there are several indicators, all with objectives that can be tracked, as long as we're within our error budget, we should be able to build new stuff. Now, granted, the minute that this starts to get a little wonky and it starts to be slower, eating into the error budget, you're now looking at a trend. You're like, okay, guys, I'm going to need you to stop working on new stuff. Check out what's wrong with the apps because they're starting to come back a little more slowly. That's the idea of service level site reliability engineering. It's all about those service level objectives. Okay, so I do have some questions. I don't know how this is going to play out, but let's see how we do. I want to give you some stuff to look at. Here's a slide with 6 different sentences. Each one of these is either an SLA, it's an SLI, or an SLO. So let's go to the next slide and I'll read to you all 6 of these and you type in the chat which 2 are objectives. Now, which 2 of these things are service level objectives? Remember, it's a target that you're trying to meet, but it's internal. The website must be available for customers 99% of the time. Is that a SLO? How about we had 2% downtime for our service last month? Is that a SLO? SLI. What about this? The database query response time must be under 500 milliseconds. SLO, SLI, SLA. The customer support, if the customer support response time exceeds 24 hours, then we'll give you a discount. There's a promise that's being made on that one. How about the company will provide partial refund for customers for each hour of downtime? That's another promise. And then finally, if the system errors exceed 5 per hour, then we're going to send an alert. So people are typing in, yeah, you're right. Anybody that is saying 1 and 3, you got it. 1 and 3. Because they're talking about, this one is availability and how much availability that the website should be. Now, since it doesn't mention how we're going to fix it if we don't, you can see that it's internal, service level objective. Here's another one. The database query response time must be under 500 milliseconds. That was exactly like my latency one. So that's correct as well. Good job, 1 and 3. Now, let's do another one. Let's talk about the service level agreement. As you know, this is the thing you sign. It's external. So which of these two talk about, and if we don't do it, we promise? Which one? I'll put a little music on as you type. Yeah, you did it. You're absolutely right. Everybody who said 4 and 5, those are service level agreements. How do you know? Because there is, and here's how we will make you whole. Typically, service level agreements are talking about, listen, here's what we promise, and if we don't, you're going to get something free. This is where I normally take a moment and tell you that it's important to note that only do service level agreements if people are paying. I'm only saying this because for years here at our company, we created websites, offered them to nonprofits, we hosted them, we did all this stuff, and we charged very little, if anything, did a lot of work for free. And then the reason we did it a lot of times is because, well, we're kind of still learning certain features, and I mean, if it goes down, we'll hurry up and fix it, but at least we don't owe them anything because they didn't pay for it. I know, it's kind of rude to say, well, listen, if you didn't pay, you can't complain, but all of the free services, they're like that. Like, try to find the phone number for any of these free tools that we use for social media, and I'll try to call them. Too bad, so sad. You're not going to talk to them on the phone. It's how they do it. So I'm just saying, all right, let's go to the next one. The final one, it's clear that the last two are what? Service level indicators. These last two items are talking about, what are we measuring? Downtime? What are we measuring? System errors? That is how you get the number. That number is the service level indicator. And when you want to shoot for a certain internal goal, that's your objective. And when you want to promise that you're going to deliver a certain level of service, that's your service level agreement. And if you don't hit it, you'll owe them a little bit of something. And normally, notice that in each of these, you always reward or you always pay the customer back in kind, like in some kind of thing, a discount, a free month, something like that. You know, I'm going to send you a shirt. Usually that doesn't work. Give them something that's in line with the services that you're offering. Nice work. Thank you, everyone. Let's give you your applause. We don't use this enough. Okay, it's getting late. I'm feeling it. You're feeling it. Let's talk about the next thing, which is how do you make sure that your system is truly resilient? Speaking of promising somebody uptime, how are you going to make sure that you keep the system available 99.95% of the time? You are going to make available many different instances that will all be able to fail over for one another. High availability refers to the ability of a system to remain up and running and accessible for users, even if you have a failure. a hardware failure, a software failure, some sort of outage, your system still stays up. Disaster recovery refers to restoring a system, what you need to do to restore a system to a functional state after some major disruption. It could be a disaster or something happens. So looking at the design, what design would you put in place for each of these scenarios? Let's check it out. Sure, let's check it out. Redundancy. This means that you'll have the ability to fail over to something else. Redundancy means, oh, I have a standby. No worries. I have a duplicate of this thing that I'm using. And when you do, yes, you're actually paying for 2 times the resources that are needed, because one of these things is available to be swapped out if its twin fails. So, duplicating the critical components or resources to provide a backup alternative. Now, a lot of times people will use a hot standby database that everything that happens in database A is also happening to database B in another region somewhere. And so all of the transactions that are going to your first instance of this database are being replicated to this second. And so that is a form of redundancy here. You have multiple copies of data or services in general, and you distributed them so that you don't have a single point of failure. You've distributed copies of this resource all around, and depending on how much money or how much, reliability you've promised, you may need to have several copies in many places, so that if one of these goes down, then it's okay. The other copies take over while we fix the problem. And so that's an example here. The impact of a hardware failure on any one of these is not felt because they're replicated to several different places. In this case, look, this guy went down, but these 2 are still running. And of course, you'll get some sort of log entry, some sort of message from your monitoring system. Uh-oh, we lost another one. And then, of course, you'll scramble and go fix it. Meanwhile, it's still up. And then you fix it, you put it back, and now you have all 3 again. So the availability is good when you can replicate. Also, the regions themselves support us in these resource locations. We're going to choose multiple regions all over so that a single problem in a single spot does not affect all of our application. So, sure, you could actually take your resources and spread them around in all of Google's different data centers, and now you have that regional failover capability. So this will improve your resilience because it reduces the risk for your services staying out. In fact, they might never go out. And if they do, they won't be out for long. That's the idea. And what we mean by scalability is that if your organization places some product or some service out there on the web and all of a sudden it goes viral, somebody shared it on their TikTok and they've got 1 million followers and everybody clicked. Well, congratulations. I hope your website is scalable because you're going to need it. So scalable means the ability to get bigger in a fast fashion, quickly, dynamically allocating everything we need to keep up with the load, and then to dynamically, this is important, dynamically deallocate when no longer needed, when these resources are now low usage, scale back down. Now, of course, you're going to tweak it. You're going to get onto some tools depending on what you're using for your scalability. You're going to create some settings. If the amount of CPU collectively on my servers gets to 80% full, spin up another resource. Collectively, now you added a new empty VM and now, we're down. Well, we're up again, spin up another one. And by the same token, if the total collective amount of CPU usage gets below 40%, scale down. Scale down. So you can have a limit a ceiling and a floor. Don't scale up bigger than X and don't scale down lower than Y. And then you've created the flexibility range within which you're ready to pay for, because you just want to be ready when they all come. Maybe you build it and they do come. Now, think about backups as well, because regular backups will be needed just in case you lose some data. And these are, of course, cloud providers will be providing backup services for you, but you want to check to make sure that the resources that you're using are participating in automatic backups. And sometimes, depending on what you're using, sometimes it's just not automatically turned on, so definitely do that. And then remember, once you make your backup, go ahead and store them in another spot. Don't store the backup right next to the actual product itself. I remember one of our first web hosting environments where I was taking these remember, I did these websites for free, and I had this cloud host provider, and I had backups going to my Google Cloud Drive. Backups would happen nightly. It would do a differential backup, and on the weekends it did a full backup. It just automatically did it for me. And one day, none of my sites, not mine, not my 15, handful of customers, nobody, nothing was up. I go to the host provider's website. That's not even up. I'm like, uh-oh. I think they got hacked. I think they got ransomware. I don't know. And so we got together and we started scrambling, and we took the backups from Google Cloud Drive and put them up. Since they're Windows machines, just stuck them up in Azure. Just created a virtual machine in Azure, just put all the sites there. We had everybody's site back by like that night. Our customers, they're nonprofits. They didn't even notice. It was like a Saturday. Nobody cared. That website provider, that hosting provider, took 10, 15 days. I was like, oh, imagine that I had my backups right next to, in that same building, wherever it is that was hosted. What if I kept my backups inside a separate machine by that same host? I would have not been able to come back. So, wow. Definitely back up someplace else. I don't care how small you are, but I bet you don't want to live without your websites or your services. Back up, store it somewhere else. Because, oh my gosh, think what could have happened. So, the design that you use, depending on who's paying for what. Now, to be clear, my little website hosting business, there was no standby database. No. They didn't have it like that. It was, listen, if it goes down, we'll try to make sure it comes back up. But I wasn't paying for redundant hardware. But if you're a business, big business, in charge of big stuff, yes, you want redundancy, copies of things. You want to replicate your data in different regions and have scalable services that automatically expand to provide resources when needed. And you're going to make your backups and you're going to store it someplace else. And then, for the love of all things holy, could you please test? How many of us have made backups? And then, turns out those backups weren't even valid. Whoops. Like, you don't want to find that out when you need it. Have a little day where you practice. Just practice. Have disaster day. Pretend things went south and see what you can do. Okay. All right, we're almost out of this section, but I do need to tell you about the observability tools that I mentioned before. Now, it's important, like people who come to the cloud and they're used to being on-prem, the first thing they ask, hey, hold on, how come I can't? Hold on, wait a second, I'm used to walking into the server room and smacking the computer. Sir, do you smack your computer? Yes, I do. It is called percussive maintenance, and sometimes a good smack, I'm like, I'm so worried for you and everyone who lives with you. Why are you hitting the server? Okay, so I know you mean turn it off and on again. Sure, that must be it. You could press the button because you can see it. What happens when you go to the cloud? You can't walk up to the data center and ask to see your server. They're going to look at you like you're crazy. So what can you do? Introduce the observability tools. You're going to need something, and Google was ready for it. They're like, okay, people are going to be a little paranoid. How can they check on all their services if they're not here in the building? Let's give them dashboards. Cool. What kind of dashboards? All right, we're going to break it up into 3 different sections, says Google to themselves, I imagine. One of them is, let's create a lot of metrics. They could just create a little chart. And then anything they want can be placed in a chart, and we'll call it monitoring. So you can watch the little boop, boop, looking like a little, I don't know, stock market ticker or something. You just want to watch. That's one type of thing that you'll do when you want to observe. But there's another thing. I already showed it to you. Cloud logging. These are not just numbers. These are whole sentences about who's doing what. And remember, logs are always being created. So you want 3 things to keep track of all your stuff. Your third item is a multi-phased set. It goes like this. Developers, my friends, they care about Cloud Trace, Cloud Profiler, and the error reports. The developer is all eyes on these 3 things. I can't, there's not, it doesn't. Okay, hold on. Developers spend a lot of their time looking at that piece. So in a nutshell, and I won't drag it out, I'll just tell you. Monitoring gives me an overview of all my services, anything I want. I could see how many times you ran Flappy Bird. Actually, I did promise you I'd show you that. And I am curious. Did we? We didn't. Okay, let's look real quick at monitoring. I go to logging. Wait. Logging. Okay, what I want is Metrics Explorer. That's monitoring. And I can actually get a little dashboard that tells me how many Flappy Bird queries have run lately. So I could actually select a metric, and I want my cloud run. Can I? Cloud run revision, that one. And then I want to know about that container. And then I do want to see how many containers are running, let's just say. And immediately it says, well, there's just one. Oh, that wasn't any fun. But do you see how quickly I could just point to it? If I say instead of instance count, what I want to know is the container CPU utilization. How much CPU was used to flap of the Flappy of the bird? Let's see. I don't want a heat map. Okay, sure. 5%. Now, over time, how much time are we talking about in the last hour? But you guys aren't playing anymore unless you are. Wink, wink. Okay, let me see for the last 6 hours. Okay, look at that. We got up to 10% of the CPU utilization when we first released the Flappy Bird, and then people played a little more. I could pretty much ask for anything I want immediately. Why? Because every one of your Google Cloud resources that you put in your project, they're all just emanating numbers, statistics, how many people, how much, what's the memory, what's the response time, what's this, what's that. It's always being emitted from all your services. And what you're doing with cloud monitoring is you're just capturing it, and you're just going to show it on a dashboard. Now, admittedly, nobody stares at a dashboard. In fact, that's another plot in a movie. Remember, you got a security guard, and he's just looking at a wall of monitors. He should be looking at the wall of monitors. What is he doing instead? Oh, he's looking at the newspaper because, oh my gosh, did you know that the Yankees are in 7th position? Dude, and in one of these monitors that he's supposed to be looking at, there's like the Grinch going doot, 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 doot. The Pink Panther just sneaking. Anybody Pink Panther? This is old. This is old stuff, but listen, nobody sneaks like a good Pink Panther. I'm just saying. You're going to miss it. So what does Google knows this? Google already read your mind. You're not trying to look at the monitors all day. You've got a life. So what it does is it lets you create an alerting policy where you tell Google to keep an eye on the chart. And as soon as this number goes over this line, I don't know what the metrics are, you decide, it's gonna send a message. It could Slack you, send you a pager message. People still use pagers, but apparently it's an app on your phone now. It's called PagerDuty, not a real pager on your hip, although I think it might be. Anyway, tell people if that line if anything goes above the line. Tell a human. That's what we're talking about. That's cloud monitoring. Use it if you like. And now cloud logging. I went through the logs for a second ago and I showed you some logging. It's great. These logs are being created in real time, and you could create a lot of tools from that. Now, as I mentioned, developers love trace, profiler, and errors. You don't have to memorize this for long, but do know that these are 3 different products. When you hear cloud trace, I want you to memorize this. You're testing for latency. That's the test. When you do it, you're going to actually use cloud trace to find any bottlenecks. Remember, you're working with microservices. It's no longer this monolithic app that's handling everything. No, one service calls another service, calls another service, calls another service, calls another. One of these things is slow. How do you find out which one? You run a trace, a latency check. You're going to be collecting latency data from your applications, and you're going to know one of these things is causing it to be slow. You'll figure out which one. That's why developers love trace. But not to be outdone, developers also love profiler. When you think profiler, you're going to be testing for memory usage. Because you wrote a program and you have some memory that may be improperly allocated. Maybe you've got a heap that is not cleaning, I don't know the words. There's stuff you're going to check. Is it using memory properly? So you've got memory allocation and memory heap usage, and then if you're not doing it right, your code will be slow, but for a different reason. It's not slow because of latency. It's slow because poor memory usage, poor memory management, garbage collection not in place. I don't know, something like that. Profiler will tell you. You run it through your code, it'll say, oh yeah, so that function that you're using, I mean, that's taken a long time. You might change it to a regular expression and it'll run faster. It's something like that that you're going to do. In your code, you'll find where the memory is not being handled properly. And developers also like error reporting for obvious reasons. Error reporting is actually a dashboard that brings all the errors into one spot so the developers can blame other people. No, sorry, some of these tickets or some of the Git, if you ever use Git check-ins, you could blame. There's a button called blame, and then you just pick a team member, blame him. He did it. But this is Google's answer. They're going to take all the errors from an app, pull them into a little dashboard, and it's a centralized error management place where you could actually say, I'm working on it, it's resolved, link to the Jira ticket that's really tracking it formally. It's great. Developers love this too. In a nutshell, developers use 3 of these things. Monitoring is just metrics. Logging is big text. All of that's useful for your observability. So then, quick question to see how your memory works. Google Cloud's Operations Suite provides a comprehensive set of monitoring, logging, and diagnostic tools. Which one of these things collects latency data? Huh? Which one? Music, please. You got it. It's C. It's Trace. You did it. Okay. Just remember those little hints. I have more hints for you if you want to come back to our office hours. But first, I'll give you the final section of this chapter. And then we're going to go into the summary. Oh my gosh, you're almost done. You're almost there. Hold on. Okay. Let's talk about Google Cloud Customer Care. You are part of Google's customer base. You have support, someone you can actually call. Unlike the rest of the people that are just users of the social media, there's nobody there. There is no phone number. That's not true for you. There is a phone number because you are a true Google customer. So let's discuss. There are 4 levels of Google Cloud customer care. And the first one, this is the one I have because I use it in a small way. Listen, basic support. It's free. It's included for all the customers because we don't pay anything extra. It's free. And because it's free, you could have access to documentation. There will be no phone number, ma'am. Community support. Maybe a little cloud billing support. If you have to talk to somebody, they'll probably help you perhaps. And then, of course, Active Assist. All these different things are there for you if you have basic. But for a small fee, sorry, I'm joking with myself. I'm getting a little punchy. Listen, standard support. This is recommended for any workload that you are currently developing, but it's not live, it's not production or anything. You can kickstart your cloud journey if you want to with unlimited access to tech support, which lets you troubleshoot, test, and explore. You get unlimited access to this tech support. And of course, you could get unlimited access to English speaking tech support within a certain range of hours during the day. Listen, we'll answer the phone as long as it's between 9 and 5 or whatever working hours are. And sorry, we didn't invest in a whole lot of different languages, but we all speak English. Make sure that you contact us. We can help. Sure. It's standard support. Wait, what was that? You want more? Okay, sure. The next level is enhanced support. This is designed for your workloads that are in production. So you could easily stay in development mode for a while, but the minute you push one of these workloads to production, I don't know, maybe you should upgrade the support level. Here's what you get. You've got workloads in production, you've got fast response times, and they have additional services to optimize your experience so that's more robust support, more well-rounded. And since you're in production, fine, they'll answer the phone 24/7. Sure, they speak several different languages, and if there's a big line of people who all have the other levels, you kind of get to the front of the line. I'm just saying, membership has perks. This means also that if you talk to a tech support and they can't quite do it, they can't quite get the right answer, you'll get escalations, which means they'll find somebody who can, and a lot of third-party technology support as well. In case you're running through a third-party vendor to get to Google Cloud, they'll help you there too, which is kind of generous. That's kind of neat. All right, now those of you who are like, oh, please, I only fly first class, I'm going to need, you're right, premium support. This is for enterprises with critical workloads. That's right, if you're doing your fintech application and you can't afford any downtime and you need to process this thing and it's not quite working, you get the fastest response time and you're customer aware. You have customer aware support, which I believe what it does is they recognize something's wrong and then they contact you. It's like my car is like, okay, we noticed some stuff. We've gone ahead and scheduled an appointment at the center. I'm like, what? Thank you? It's weird. So I feel like customer aware support might be like, listen, I've noticed a few things. Did you want to talk? I'm just guessing. And of course, you definitely get a dedicated technical account manager, which means they're familiar with what you're trying to do. You don't have to start at the beginning to explain. They already know you, they know what you're trying to do, and they could be just, oh yeah, that's right, tweak that thing. Good luck, talk to you next week. Now you get some Cloud Skills Boost training, although now I believe it's just open to everybody. Everybody who's a paying customer can just get Cloud Skills Boost training. Yeah, Kate says yes. And, event management service. Is your company kicking off something special? You have a planned peak event? They'll help you. That's kind of neat. Of course, operational health reviews. That's the one. We noticed that you're running a little hot on that Kubernetes engine. Did you want some help? And of course, that customer aware support is there again, where customer care learns and maintains information about your architecture, who your partners are, and your Google Cloud projects. And using that information that they store about you, they provide experts that don't need to be introduced to everything you're trying to do. They just get it and they can resolve your case. So that's kind of neat. So don't cheat yourself. Get supported, man. In fact, if you were to ask for some support at Google Cloud, it would start with this. They'll create a case for you and they'll look at it and see how bad it is. Oh my gosh, you're bleeding. Okay, we'll give you a case assignment. Go, get that fixed. They'll troubleshoot, they'll investigate, they'll let you know how it's going. If they need to escalate it, they will. But they'll resolve it or mitigate any things that went wrong. And of course, they'll validate and make sure it works. And I imagine they'll keep bugging you a week after it's done, asking you, is it done? Is there anything else? Can we close it? You'll be like, yeah, okay. And they'll close the case. So that's really nice. I do have a question for you. I know, I have so many questions. Which one of these support levels, again, which one is designed for enterprises with critical workloads and features the fastest response time? What was that? You got it. Everybody said B, and you're absolutely right. I do have one final couple slides, and then we're going to go into the summary section of the course. You're minutes away from ending your day. Oh my gosh. Okay. Listen, let's talk about this planet though. How many people have you heard mention something like, oh, don't use cloud services because they're not green. It's not supportive of the environment. It turns out that Google cares about the environment just as much as we do. They were the first to achieve their ISO 14001 certification, which has to do with green. And yeah, that's important. In fact, they've been focused on the environment from the beginning, making sure that in their founding decade, they were carbon neutral. And then in their second decade, they want to be using 100% renewable energy so that in 2030, they'll be, it wasn't just carbon neutral, it's carbon free. That's the goal, 2030 carbon free. And what does that mean? While governments and business and communities and nonprofits, they all have their eye towards, well, if they're smart, towards making sure that we take care of the environment. A lot of times when companies move their systems from on-prem to the cloud, they're taking a step toward being more green, because chances are they were doing it poorly at their organization. It's hard to be green in your organization if everything's on-prem, but moving it to a center like Google Cloud that has at scale these things in place to make sure it works, that might be a better idea. But don't listen to me. Let me show you this last slide for this section from Sundar Pichai, who's going to talk about their progress and to transition to this sustainable future. Sorry, I have to turn off a thing before I turn on this. I like to turn off my face so you're not looking at me while you're looking at him. Okay, let's get it going. Where to go? Here you are.
Hi everyone. Thanks so much for joining us. We are grateful for your partnership. Fighting climate change is humanity's next big moonshot. And as with any moonshot, we're going to have to answer some big questions to get there. At Google, we've been asking these questions for 25 years. Can a company at our scale operate on 24/7 carbon-free energy? How can we use technology to help others achieve their climate goals and make more sustainable choices? We continue to make progress across all of these areas. For example, behind me is our Bayview campus in California, where buildings are powered by wind, solar, and geothermal. And in Belgium, we are on track to operate at or near 80% carbon-free energy in 2024. The biggest question is still ahead. Can we leave a healthy planet for future generations? I believe the answer is yes. That's in part because of the progress being made globally to transition to a sustainable future. We have worked hard to lead by example. We began purchasing clean energy in 2010. By 2017, all our energy purchases were matched with 100% renewable energy. And today, 2/3 of the energy used for our offices and data centers is 24/7 carbon-free. Our goal is to reach 100% by the end of the decade. We are excited about the ways we can keep driving the energy transformation through steps like our next-generation geothermal project in Nevada. We are also harnessing AI for new breakthrough solutions. For example, we recently shared research that will help airline partners use AI to decrease contrails, a major contributor to global warming. AI powers FloodHub, our system which can predict floods up to a week in advance. It now covers more than 460 million people in 80 countries. With the help of AI, 1 billion people have made more sustainable choices through our products. For example, fuel-efficient routing in Google Maps has helped prevent more than 2.4 million metric tons of carbon emissions. That's the equivalent of taking about 500,000 fuel-based cars off the road for an entire year. And in partnership with local governments, we are advancing Project Greenlight. It uses AI to reduce stop-and-go traffic at intersections and reduce emissions. We are now expanding this project to more than a dozen cities around the world, from Rio to Budapest. Through our products, we want to help people, cities, and other partners collectively reduce 1 gigatons of carbon equivalent emissions annually by 2030. That's equal to the emissions of a major country like Japan. We'll continue sharing tools that help, from making the latest AI models available through Google Cloud to helping city governments understand and reduce their emissions with our Environmental Insights Explorer tool. And we'll keep asking the big questions to help build a more sustainable future and work to find answers with all of you.
Yay! That is awesome. Okay, now let's, before I show the whole new slide deck on our summary, let's just jump into a 5-minute break as I pull up the new deck of slides. Really, we'll be like 20 minutes and then we're done. So let's just 5-minute break and we'll come back and we'll wrap it up. You guys, you did so good. Okay, there you go. Let me play you some music and then BRB. a little fun little tune, huh? All right, let's close out this little timer. Boy, this has been a blast. You all are absolutely fun. Let me show my last slide, the last one for the day. Can you believe it's over? My gosh. All right, well, this is pretty important because they say when you're doing any training, you got to tell them what you told them. So here we are, the course summary. You did it. Congratulations, the finish line. Yay! Hold on, here we go. Yay! Okay. So, did I meet my objectives? Did we do it? Did we identify what the Google Cloud products were? What are the solutions that are going to support us on our digital transformation journey? I think we did. And did we explain how the cloud technology and data can be used to innovate? What data can you use to innovate in your organization? So many data. So much data. And of course, we talked about how organizations can use the AI and the ML of all the things. We talked about using those different products. Remember the Google products that we have access to with the thin layer of custom data on top of the LLMs? Can't wait to use that one. And of course, monolithic? Who? Moi? We looked at application modernization, knowing that there's a journey, and it can be outlined carefully. Moving slowly from monolith to microservices. And of course, security is super important. We walked through the Google Cloud Data Center and talked about optimizing those costs and making sure they don't run away from you. And, of course, the thing that I want you to make sure you refer to some notes on, I know you're going to get some notes soon, transforming business. This was where we talked about Nintendo keeping up with the tech in order to do their why, right? That's what we want. We want to be the Nintendo. Of course, transformation has to do with that data, making it useful and accessible. We did 2 pieces on the AI that was just a small section, but it was so powerful, right? Especially after that little demo from Melitza. The fundamentals of AI, and then what does Google have to offer? And of course, we just were talking about the migration, modernizing things. We did the Kubernetes, remember Katie's? We did Katie's, and then we did Cloud Run, talked about Cloud Function and how all these are microservices, because that is what a modern application is. And of course, the trust and security. We're a little more trustful and a little feeling more secure, perhaps, knowing we're going to a good cloud provider. And scaling is important. Making sure that all our systems are still up and still running, because why else did you move to the cloud after all? And that means that you'll be taking this exam, right? Make sure you do it. So, of course, we will talk about this in more detail on the 14th and on the 21st, but in a nutshell, the length of the exam is 90 minutes. It's multiple choice. And when you come to my exam prep, I'm going to show you the ways the ways that you should think in order to pass the exam. And these will apply, these little tips will apply to any exam that you take. You're going to be super comfortable after you come to my little review. And of course, they've already been giving you these links in the chat, because shout out to the moderators answering every question. Nothing slips through. Everyone give applause to your moderators. Yay. Making us look good over here. So thank you for coming. Don't forget that there is a survey. We would love for you to let us know how we did. Did we meet your expectations? Did we exceed your expectations? Don't forget to join us on LinkedIn. I have a habit of putting little games out there that you could play to help you reinforce your knowledge. So hang out with me over on LinkedIn. And thank you again. Kate, my friend, please take it away. You are muted, my dear.
Thank you so much. Oh, wonderful. Well, what a day, huh? What a 2 days. Woo, thank you. Before I wrap, and we're just really almost there, and we're ending a little bit early, which is fantastic. So let me give a moment of gratitude. A huge thanks again to Charlene Banks for keeping it real and also keeping the energy up, for teaching everyone, bringing your great analogies and energy, and keeping it real and fun. I also want to just thank again my fantastic co-founder on this entire Launchpad for Women program, Krista McGilvery, who you heard from today, moderating the panel. And also huge thanks to our tireless global program manager, Monica Singh. And thank you to the wonderful behind the scenes team who helped make this all so smooth. Shout out to all the chat moderators, which Charlene just mentioned as well. And especially to Cecilia, Lara, Barry, Taryn, Renee, Peter, Vanya, and Sharia, and the entire ROI training team as well. Dave, Kim, Candace, Jeff, Michael, Alex, Corey, Blake. Thank you all. I feel a little bit like the Oscars, and they're going to pull me soon. So thank you, thank you, thank you. So now let's go to our final slide, believe it or not. 3 things I'd love to call your attention to quickly. So we've got the thing I think you're all waiting for, which is the first QR code here. It is the QR code that links you to all the course materials. So yes, you can either put this bit.ly link in or use this QR code. It includes a PDF of all 6 modules of the materials that Charlene just went through, plus a study guide, plus a student workbook, plus sample exam questions. It also includes a link to the entire same course, but the on-demand version that's in Google Cloud's Skills Boost, which is totally optional and free, but it's kind of another way to reinforce the learning if you'd like to use it. And it's got a link to a bonus Gen AI skill badge course, which is basically an intro to Gen AI. Since we talk so much about Gen AI, we know some people might be interested in that. Second QR code is a link to join that optional private community on LinkedIn. And again, this is an opportunity for you to share tips and tricks, share success stories, encourage each other. I'd really encourage you to join it. And then third, survey. We truly would love to hear your feedback. Can you please take 1 or 2 minutes right now, if you haven't done this, and let us know how this went for you? We would truly appreciate it. So, and I hear all my dinging going on in the background. Thank you so much for joining us for both days of Launchpad for Women in the Americas, the International Women's Day edition. And thank you, Charlene Banks, for the incredible instruction. You did it. Now keep going. All right, next steps are Friday, March 14th. There is an optional office hours. I think there's one more slide on here, hopefully, to reinforce that. So optional office hours on Friday, March 14th from 12 till 1:30 p.m. Central Time. Those, you will also get calendar invite holds on your calendar for everybody who attended. Also, Friday, March 21st from 10 till 11:30. So slightly different time for that, but that will be the second optional office hours. Those are both the same content will be included in both sessions. So you can join one or both. And then don't forget to study and schedule that certification exam, and then take and pass that certification exam by Monday, March 31st. So you can also earn that $50 swag voucher, get yourself a cool Google hoodie or whatever you'd like. All right, that's it. And that's a wrap. Thank you so much again. Have a wonderful weekend. Take care.